Government of India inside the auditorium. I request you all to please settle down quickly. I also request you to please keep your mobile phones on the silent mode. I request our dignitaries to please take their respective seats on the dais. We have with us Shri K. Rajaraman, Chairman, Digital Communications Commission and Secretary, Department of Telecommunications, Government of India. He's being escorted onto the dais by senior members of DOT, CDOT, and TSDSI. Shri Uma Shankar Pandey, Member Services, Digital Communications Commission, Government of India. Shri N.G. Subramaniam, Chair, Telecommunications Standards Development Society India, TSDSI. Shri R.R. Mittar, Advisor and Head, Telecommunication Engineering Center, TEC, Government of India. Dr. Rajkumar Upadhyay, Chief Executive Officer, Center for Development of Telematics, CDOT. Esteemed speakers from the government, academia, industry, and global telecom associations, distinguished guests from DOT, CDOT, TEC, TSDSI, and other government departments, representatives from media and press, participants of the workshop who are connected with us virtually, ladies and gentlemen, namaskar and a very good morning to all of you. With our Honorable Prime Minister's clarion call for building Atmanirbhar Bharat, our country has been witnessing an unprecedented transition, marked by a high degree of vigor, enthusiasm, and relentless determination, with active participation from all stakeholders in this eventful journey of achieving self-reliance. Technology is a key enabler of overall development of a country. Telecom and ICT is one of the important pillars of the growth of a country. For a huge country like India, with a diverse geography, technological innovation with focus on extending connectivity to one and all, powered by the latest telecom technologies, assumes wider significance. The role of standards becomes prominent in the evolution of a technology ecosystem. It is imperative that the specific requirements of local community and rural and remote geographies are taken into consideration in developing the technology standards for the larger benefit of the society. This would further boost the growth of local industry and startups, bolstering them to capture the global market opportunities. Today, we have gathered here to deliberate upon various themes related to technology standards, patents, and standard essential patents amid a galaxy of domain experts and field veterans from several prestigious institutions representing the government, academia, industry, R&D, and standards development organizations. Ladies and gentlemen, I welcome you all to this one-day national workshop on enhancing Indian participation in telecom global standards bodies that's being jointly organized by Telecommunication Engineering Center, TEC, Center for Development of Telematics, CDOT, and Telecommunications Standards Development Society India, TSDSI. This one-day workshop will make us delve into the intricacies of standards development and patents amid insightful deliberations with the esteemed speakers in the exclusively tailored sessions. This workshop has been made more memorable and special with the esteemed presence of Shri K. Rajaraman, Chairman, Digital Communications Commission and Secretary, Department of Telecommunications, Government of India, who has kindly consented to be a part of this workshop. We express our sincere thanks and heartfelt gratitude to you, sir. As part of our green endeavor to spread awareness about environmental conservation and making our planet, Mother Earth, more clean and green, may I request Ms. Namrata Singh, ADG TEC, to formally welcome Shri K. Rajaraman, Chairman, Digital Communications Commission and Secretary, Department of Telecommunications, Government of India, with a potted sapling. Can we have the sapling, please? We welcome you, sir. May I request Shri Rakesh Goyal, ADET TEC, to formally welcome Shri Uma Shankar Pandey, Member Services, Digital Communications Commission, Government of India, with a potted sapling. We welcome you, sir. May I now request Ms. Purnima Shandelle, Team Leader CDOT, to formally welcome Shri N.G. Subramaniam, Chair TSDSI, with a potted sapling. We extend a very warm welcome to you, sir. May I now request Ms. Sunaina Dung, Senior Research Engineer CDOT, to formally welcome Shri R.R. Mittar, Advisor and Head, Telecommunication Engineering Center, TEC, with a potted sapling. Ladies and gentlemen, it's a defining ritual in our country to invoke the blessings of the Almighty at the auspicious start of an occasion to steer us through the path of darkness and ignorance to the whole new world of wisdom and enlightenment. May I please request our distinguished guests and dignitaries seated on the dais to please come forward for the lamp lighting ceremony. Let us offer our prayers to the God of light to always keep us treading on the continuous path of prosperity and development. May God give us strength to surmount all hurdles that impede our path to enlightenment. May I now request Dr. Rajkumar Upadhyay, Chief Executive Officer, Center for Development of Telematics, CDOT, to deliver the welcome address.
Good morning, everyone. Respected Chairman, Digital Communication Commission, Department of Telecom, Shri K. Rajaraman ji, respected member services, Digital Communication Commission, Shri Umashankar Pandey ji, respected Chair, TSDSI, Shri NG Subramaniam ji, respected Shri Mittar ji, Advisor and Head Telecom Engineering Center, esteemed speakers of the government, academia, industry, and global telecom associations, distinguished guests from DOT, CDOT, TEC, TSDSI, and other government departments, representatives from media, ladies and gentlemen, a very good morning and a hearty welcome to all of you. It's a matter of privilege to have been bestowed upon this opportunity to welcome you all on this one-day national workshop on enhancing Indian participation in telecom global standards body that is being organized by TEC in association with CDOT and TSDSI today. India has embarked on its ambitious journey of fulfilling our Honorable Prime Minister's clear call of Atmanirbhar Bharat by achieving new milestones in developing wholly indigenous technologies for the benefit of one and all. India is confidently treading the path of becoming a global technology hub with its renewed spirit that is fueled by cutting edge innovation and research. It is indeed an opportune time for India to immensely contribute towards technology standardization that will not only address the diverse local requirements, but will also pave the way for creation of patented technologies. Recently, 6G Alliance was formed after Honorable Prime Minister's released the Bharat 6G vision, and we are all aware that government is taking a lot of initiatives so that a lot of standards and technologies get developed here. In terms of our representation in IEEE, ITU, 3GPP, where the standards are actually made, I think our membership is quite less. I think Government of India is working very hard to increase our our participation in IEEE, ITU, and 3GPP. And today's workshop will deliberate upon various aspects of technology standardization and patenting inventions amidst insightful sessions by eminent speakers across the country. We are honored by the august presence of Sri K. Rajaramanji, Chairman DCC, who has so kindly consented to grace this event by his benign presence despite his exceedingly very busy schedule. Uh, we, on behalf of CDOT, TEC, TSDSI, welcome you, sir, for this event. Sir, you have always been extending your tremendous support, not only to CDOT, but the whole indigenous indigenous ecosystem, so that technologies are developed in India for our nation. We are also pleased to have with us Shri Umashankar Pandey ji, Member Services, who has been a source of inspiration for all of us. Thank you, sir, for attending this event and gracing this occasion. I also welcome Shri NG Subramaniam ji, Chair TSDSI, and Shri R.R. Mittar, sir, for Head TEC, who have been spearheading the standardization activities, both these organizations, TSDSI and TEC. I welcome both of you, sir, here. I also extend my warm greetings to our esteemed speakers from academia, industry, and global telecom bodies who will be sharing their insights into various contemporary themes related to technology, standardization, and SCPs. We have uniquely rich line of speakers ranging from the learned professors of IITs and other renowned academic institutions, field experts from IEEE, TSDSI, TC, and the industry. I'm quite confident that this workshop would enrich the participants with various processes involved in technology standardization and patenting that would definitely enhance Indian participation and contribution towards global technology standardization activities. This would further boost the creation of intellectual property assets and contribute to the knowledge economy of India. I urge the attendees to actively take part in the workshop sessions and gain insight in the domain of technology standardization and patenting. On behalf of CDOT, TEC, and TSDSI, I once again welcome all of you and look forward for a successful workshop today. Thank you so much.
Thank you, sir. We are privileged to have in the midst of us Srioma Shankar Pandey, Member Services, Digital Communications Commission, Government of India. Sir, may I request you to please deliver this special address?
Respected Secretary, sir, guest on the dais, Sri Upadhyay ji, Subramaniam sir, Mr. Ranjan, guest speakers, and other participants, I welcome you all on behalf of DOT. Today's workshop is basically for the standards, how they are basically made, and what is the patent, how patents are getting done, and how patents are making SEP. So all those things will be deliberated in due course of time in detail by the guest speakers, academia, etc., etc. Dear friends, as we all know that Eastern plays a vital role in ensuring compatibility and increasing the usefulness of products and services. This is in turn creates a favorable international market environment. The Department of Telecommunications recognizes the importance of Indian participation in global standardization activities. To further this vision, they are organizing an important workshop. The objective of this workshop is twofold. First, provide the understanding of telecommunication standardization process, how standards are getting made in the telecom field. And the second one is to encourage the active participation of the people, industry, and other participants. During the workshop, participants will gain awareness about the structure and function of various workshops established in the India that correspond to international standards organizations such as ITU-T, ITU-R, ITU-D, 3GPP, IEEE, etc., etc. The workshop will also highlight the significance of standardization in the promotion of the telecom industry and startups, providing the valuable insight in this area. The workshop will, however, various experts or speakers are in the 4 sessions. The first session will be step-by-step process of standard making. That's very important, how the standards are being made. It should be dealt in very details. How to convert a patent into the SEP. When the standards are being made, how the patents are making into the essential standard patent. That's very important. How the academic institution can help building the standards community, and the concluding panel discussion, the way forward. On this occasion, it gives me immense satisfaction to share some of the recent activities of Indian in global standard organization. TEC, the technical arm of DOT, recently hosted successfully the ITU-T Study Group 9 meeting in Bengaluru with the support from IS. This is the first such meeting of ITU-T SG9 in India. India also played an important role in the 6G framework decided by the ITR and WP5D. The Indian contributions were National Study Group 5, chaired by TEC, and these led to inclusion of connectivity and other features in the ITU framework. India is actively participating in all the activities of standardization of ITU T, R, and D. TEC works as a standard setting organization in the field of telecommunication, broadcasting, and related ICT sectors. TC also coordinates the Indian activities corresponding the various study groups. For each ITUT study group, we have set up national working groups in India. These national working groups consist of members from telecom, broadcasting industry, operators, academia, research institutes, startups, other government organizations, whoever plays a greater role in this part. Hope that the workshop will be productive and all the participants will be benefited from it. Thanks to all the dignitaries and participants for participating, press and media to covering the event, the TC and the CDOT for the arrangements. Thank you so much.
Thank you, sir, for setting the tone for this workshop that becomes very relevant for increasing India's participation in global telecom standardization activities. It is an honor for us to have the gracious presence of Sri N.G. Subramaniam, Chair Telecommunications Standards Development Society India, TSDSI. Sir, may I request you to please deliver the keynote address?
Shri Rajaramanji, members on the dais, members of the dais, members of the media, very good morning to all of you. And I was just contemplating what I should speak today this morning, whether I should speak or I should have a PowerPoint. So I chose to have a few PowerPoint slides. So I'll use the presentation medium. But then, this is a very important topic and very timely topic. So on that ground, I would like to compliment Sri Mitter of TEC to have taken the lead, joined by both CDOT and TSDSI, to have organized this workshop, which is extremely topical and extremely urgent, and is going to have several call to action at the end of this workshop, I believe. And I've been with TSDSI for the last about nearly 2.5, a little over 2.5 years. I've learned a lot. I've learned so much about TSDSI, so much about telecommunications, so much about standards, and the opportunity to interact with other standard development organizations. So I've developed certain views and certain perspectives, which I want to share. And in this process, that whatever I'm going to present, some are TSDSI points, some are industry perspective, some are my own personal views. So allow me to indulge. So I'm going to talk about TSDSI a bit but for TSDSI, I wouldn't be standing in front of you here. So I want to say a few things about TSDSI. And then 6G goals, which is the prime motivation for us to conduct this workshop, and then how we want to move forward, and what I felt are the imperatives and certain actions and alignment which I'm proposing for consideration. Now, as India's telecom SDO, or Standards Development Organizations, I think, TSDSI is steering its responsibilities steadily. I purposely did not put the word slowly and steadily, but we have to accelerate, and I think more needs to be done. Clearly, there are three key important themes. One is that, the last about 2.5 years, how do we enhance technical activities within TSDSI? How do we really deliberate, allow people to deliberate, get together and discuss on topics of relevance, whether it is AI, ML, what are the potential topics that we can look at 6G or 5G advanced, what does cloud mean, what does open RAN means, many such topics. And in the process, cloud interoperability standards, application layer standards. So a lot of work that has been going on within TSDSI. Many technical reports have been presented and many workshops have been conducted. Several micro workshops have been conducted in collaboration with the industry and Department of Telecom. So a lot of good work. And then we also have done some analysis of, what does it mean to lead standards, right? Who is doing maximum work? Who is doing the heavy lifting today in 5G advanced? And what does it take for us to lead and do that heavy lifting, right? And the graphs on the right side, clearly, it it's our own estimates in terms of who has done how much of contribution has been made by various countries, whether it is Europe, US, China, and other countries, and as well as India. And also, what does it mean? Who has the maximum patent portfolios, and how they actually convert specifications, contributions to patents and standard essential patents and so on. A lot of good work has been done by TSDSI, and we need to do more, given the current context. The second thing is, in the last about 2.5 years, what I've also observed is Government of India has been, and led by Honorable Minister for Communication and Secretary Telecom, Sri Rajaraman ji, they have been firing pretty much all cylinders. I don't think that, we have seen so much of action, and in a way that, they have set as industry, I'm used to being agile, I'm used to being speed. But I think this government, and especially in Department of Telecommunications, my observation is they are setting different benchmark for being speed and agility. Several things have been done, 6G technology innovation groups to deliberate, come up with a report. Then Bharat 6G Vision document was published. 6G Apex Council was set up. Bharat 6G Alliance got launched. Startup Telecom Innovation Fund, patent IPR support, capacity infrastructure building for labs and who should do what. Many of these things are systematically done. And then market access, then electronic manufacturing ecosystem, right? And then coming up with certain bold vision, saying that, look, India should aim for 10% of all 6G patents at the least, and make at least 1/6 of the contribution. It's a very, very bold vision. And when government is enabling all of this, as industry, I felt there are no excuses. We can't give any excuses. And hence, we have to do a lot of things that we have to come together, put many things together, right? And we have been reflecting as in groups, as industry, as some of the standards professionals. And, it's a, we have in TSDSI, if being the main standards development body in India, we have about 55 IMs at 3GPP, and we made about 500 contributions, in the last year, in 2022. And that's not sufficient to achieve our goal of 10% of all 6G patents or 1/6 of the contribution. It's a huge, huge order, right? If you have to do that, we have to increase our contributions by at least about 20 times. We have to increase our membership and contributions substantially. I don't want to put a number to it. I think, it could be in the order of 20, 25, 30,000 or even more, right? And we have to triple our IMs at 3GPP, given that, there is how much a typical member can work and research and contribute. So the number of IMs that we need to have at 3GPP should be probably tripled, right? From 55 that we have today, or probably even more than that, right? And we systematically will have to align what's going on in research in the industry and academia and align them to India's needs, right? What is it that we need to do? And one of the observations that I have is that, most companies in India that we have, right? Standards is a part-time work. It's a part-time work. We can't afford to have it as a part-time work. It has to become a strategic pillar within the organization, and that need to drive the whole product development, innovation, and contributions therein. Right? So I think we need to gear ourselves for this. And when you have a full-time standards organizations, which I've seen some of the other very well-known standards and R&D product-based organizations, how they are structured as a standards department and standards function globally. And we are nowhere near that. I think we need to really wake up and then see how do we structure ourselves at each industry or each corporation which is in the field of telecom. How do we really drive standards? How do we adopt standards? How do we really contribute to standards so that we are better off, so that we are in the thick of things rather than merely at the receiving end, right? And then whatever research that we are doing, right? Lot of research is being done. I think, no doubt about it. If I go and look at what being done at IIT, what Professor Kiran is doing, and a few others are doing, including companies like Tejas and some of the TSPs, outstanding research, right? Outstanding work. And how do we really make it open, collaborative, and a lot more meaningful to standards contribution is important, right? One of the observations when I interacted with people is that they all work on problems, they solve the problems, but then, they don't think that it merits a standard. They decide that, oh, this is the simplicity of the solution is being taken as the measure rather than the complexity of the problem that we have solved, right? So I would urge the industry to, and all the people who are working on problems, to really focus and talk only about the problem that we are solving, not think about the solution, because the solution often, because of the ingenuity that we all have, it's ultimately come up with a very, very innovative, simplified solution. The simplicity of the solution should not decide whether we are going to patent it or not, but the complexity of the problem that we are solving should be the one should be driving the patents and trademarks and all the other things, right? So, and then, I think we need to really strategically collaborate with US and the other Quad nations, because the amount of respect that we have earned and the amount of discussions and bilateral discussions we are having is unbelievably high, unbelievably energetic, and I think we should really capitalize on that front. I have a few remarks. I don't want to spend too much time on all this, but focus on both horizontal and vertical standards, because India's needs is going to be just not in terms of only improving the capacity, coverage, and throughput and experience, but equally we need to pay the interdisciplinary areas of verticals. What does it mean to agriculture? What does it mean to farming? What does it mean to healthcare? And every one of these areas, then when the horizontal standards areas and the vertical standards areas, when they overlap, it is that cusp is where there are opportunities to come up with differentiated products, experience, innovations, and patents, and standard essential patents. I think, we should also evangelize importance of standards contribution and processes therein with the industry, right? When we are trying to solve a problem, come up with a systematic way of doing it. There are enough things. I take it that all of us know what does it mean to write standards. It's a very, very intensive process. As I said, it cannot be done as a part-time work. There is so much precision that need to come in, right? So define the concept, and then once you identify the need, concept notes, elaborate, and it could be a revision to the existing standards. Incrementally, you will change the standards, or it could be completely come up with a new standard. Doesn't matter. But then, at each stage, whatever the concept that we are coming up with, we need to put it on the labs, validate it, develop some prototypes, tests, collect enormous amount of data, and present facts so that the standards, the concepts that we are trying to put forth has a better chance to be socialized with others. They all see the benefits because there is enough data and facts to be proving this. So it becomes an indisputable area of, or a topic that will get included in release, whatever, 20, 21, 22, and so on, so on. It's very, very important that we also make sure that we socialize and build consensus through facts and results. Then, encourage assessment of organization maturity and standards. I think this is another topic which I thought would be very meaningful for us, because while we all develop standards, and in my own, understanding of industry and how they all interact with TSDSI and many other places, there are people who are observers. There are companies, enterprises, they want to be observing, right? The people who want to be following. The people who are really contributing, who are people who are leading it. So I just put a level 1 to level 4 maturity graph, and it's nothing wrong to being an observer. But then if you want to be a relevant player in the telecom industry, you need to go up the maturity curve. You need to go up the maturity curve, and that's what I'm suggesting. That look, can we really look at an assessment mechanism? It could be self-assessment, or it could be an external assessment, doesn't matter. But then there has to be an intent on the part of the industry, on the part of enterprises, whoever is in the telecom business developing products. They need to take this journey of starting from wherever you are, do an assessment, and get on to the maturity bandwagon, so that you are eventually becoming an important force to reckon with, to contribute and lead standards definition, right? And the last one is also, I think, incentivize contributors and encourage declaration of ideas and patterns, right? Because it's also the problem, because nobody wants to reveal the patents. People come, they want to put in the specifications, contribute, but the declaration of patents, however, we all say that, look, yes, it's important, we recognize it is given. The voluntary declaration of patents is, while we have a very nice process established in many standards development organizations, including at TSDSI, voluntary declaration of patents is a problem, right? And I think we need to figure out a way to encourage this, because it's the centerpiece, and along with it, there are many things comes. It could be design, it could be patents, it could be it could be copyrights, it could be trademarks, many things. But there is a interplay between standards and patents, and that interplay has to be properly understood. And I think my own recognition at this stage is that we have a misconceived opinion about declaring my patents, and that actually has to be resolved and better understood. And then, how do we synergize and scale so much efforts that are going on within the country across several organizations and also international collaborations? There are some ideas that we have, and I think, we need to bring some of these things together and then avoid overlap, put in our best efforts, put all the people in similar areas of work together, have several collaborative research that is going on across the organization on a single topic. And I think that will yield the momentum and the results that we all want to have. So just to summarize, sir, I think, you have been a great enabler for the industry. Tremendous support that DOT has been giving it to institutions such as TSDSI, Bharat 6G Alliance, as well as TEMA and a few other things. What we are proposing is that, look, we have looked at ITOR milestones and deliverables. And if whatever we want to achieve, whether it's 10% more, 1/6 of the contribution, we have to align ourselves to that calendar. So what we are looking at is, the bottom part of the slide is at a high level, what we are saying is that, look, between now and the next 6 months, put in all the infrastructure and leadership and strength that we need to have in terms of work groups, task forces, or clearly, codify the research areas that we want to do, and then, work towards several streams of work, like, harmonizing and govern the whole research projects funding. How do we membership drive that we should take so that we have become more inclusive, more, not just the telecom companies come into play, because we are going to look at other vertical standards and they should be part of this. So like that, we have put in some broad themes and broad streams. And we want to assure you on behalf of TSDSI, TEC, and all the others here that we will do our best to align ourselves to concrete actions that will deliver or that will make the bold vision that our Honorable Minister has set a reality. And thank you for the opportunity. And I count on all your support. Thank you.
Thank you, sir, for sharing various perspectives with statistical insights about emerging telecom technology trends and the critical need to keep pace with standardization in these areas. Ladies and gentlemen, it's time now to witness the launch of some key initiatives towards technology development and standardization. To enhance India's participation in the international standardization activities, TEC has developed a standards coordination portal that is an ideal platform for the concerned stakeholders to share the information and collaborate on the standards development activities in the telecom and related ICT domains. May I now request our Honorable Secretary Telecom to formally launch this portal by pressing the remote button. Yeah, so please press. Say anybody. So, ladies and gentlemen, we hereby launch the Standards Coordination Portal. This fully modular, responsive, and user-friendly portal comes with an interactive chatbot that offers the ease of use. This portal has already been enabled for various working and study groups. Registered members and contributors can access information from all national working groups through this portal. This portal will also be extended to other global standardization organizations such as IEEE and 3GPP. Group admins can also share the documents and reports from ITU and other standard development organizations. The members can also upload and revise their contributions and view or download the contributions from other members as well. The portal will serve as a knowledge repository and collaboration platform for standardization activities. We thank our Honorable Secretary Telecom for formally launching the Standards Coordination Portal designed by Telecommunication Engineering Center, TEC. So, ladies and gentlemen, moving on to the other initiative by TEC and CDOT, wherein a voluntary certification scheme has been implemented to issue online TEC approval certificates based upon the testing of the products as per the latest TEC specifications and standards. This module has been indigenously designed by CDOT. This online module will expedite the issuance of digital certificate for TEC's generic requirements over and above the already functional MTCTE portal to cater to essential requirements. With an aim to enhance the ease of doing business, this will enable the vendors to meet the compliances related to TEC certification in procurements by the government agencies. This certificate is issued for a period of 5 years. May I now request our Honorable Secretary Telecom to formally launch this online module for voluntary certification by pressing the remote button. This module enables the generation of a digital certificate with a simplified process for registering, tracking, and monitoring the applications. The module has provisions for obtaining online certificates, for type approval, interface approval, and technology approval in a simplified manner. This further eliminates the risk of losing documents with an exclusive provision of a dialog box for faster communication between the applicant and the evaluator. We thank our Honorable Secretary Telecom for formally launching the online module for voluntary certification. Ladies and gentlemen, artificial intelligence is becoming increasingly prevalent across various domains, including telecom and ICT, with a key role in decision-making processes that impact our daily lives. Any unintended biases within AI systems can have significant consequences, leading to ethical, social, and legal issues. The National Strategy for Artificial Intelligence also covers the principles that focus on building public trust in AI technology and emphasize the concept of AI for all. Telecommunication Engineering Center, TEC, has developed the standard for fairness assessment and rating of artificial intelligence systems, based on extensive consultations with the concerned stakeholders. This standard outlines the comprehensive procedures for evaluating and rating the fairness of artificial intelligence systems. May I request our Honorable Secretary Telecom to release the TEC standard for fairness assessment and rating of artificial intelligence system. The concerned TEC members are also requested to join the dignitaries on the stage. TEC's standard involves a three-step process that includes assessing bias risks, determining thresholds for metrics, and conducting bias testing. By enhancing trust in AI systems, it aims to contribute towards the overall integrity and reliability of AI technology. We thank our Honorable Secretary Telecom for releasing this standard. Ladies and gentlemen, Telecommunication Engineering Center, TEC, is awarding an approval certificate to CDOT for its conditional access system, CAS. This certificate confirms that CDOT's CAS complies with the requirements specified by the Telecom Regulatory Authority of India, which has designated TEC as the testing and certification agency for CAS and SMS used in broadcasting and cable TV services. This is the first time an approval certificate for a conditional access system is being awarded by TEC, and it is being given to CDOT. May I request Shri R.R. Mittar, Advisor and Head, Telecommunication Engineering Center, TEC, to formally hand over the TEC's approval certificate for CDOT's conditional access system to Dr. Rajkumar Upadhyay, Chief Executive Officer, CDOT, in the august presence of Secretary Telecom. Ladies and gentlemen, Telecommunication Engineering Center, TEC, is also awarding a technical approval certificate to CDOT's Wi-Fi access point. This certificate is significant because it supports the development and manufacturing of indigenous technology. This approval plays a crucial role in facilitating the transfer of technology for CDOT's products and equipment. In line with the objectives of PM Vani scheme, which aims to ensure widespread Wi-Fi coverage, certifying indigenously developed Wi-Fi equipment reinforces the scheme's vision and aligns with the Make in India initiatives. Furthermore, it strengthens the government's efforts to expand broadband availability and helps connect individuals who currently lack access to the internet. May I request Shri R.R. Mittar, Advisor and Head, Telecommunication Engineering Center, TEC, to formally hand over the TEC's Technology Approval Certificate for CDOT's Wi-Fi access point to Dr. Rajkumar Upadhyay, Chief Executive Officer, CDOT, in the august presence of Secretary Telecom. We thank our Honorable Secretary Telecom for formally launching these initiatives. Ladies and gentlemen, it's our great privilege and honor to have the esteemed presence of Sri K. Rajaraman, Chairman, Digital Communications Commission and Secretary, Department of Telecommunications, Government of India, who has been a perennial source of motivation and encouragement for engineers and researchers in furthering their endeavors for homegrown innovation and excellence in diverse areas of telecom. Sri Rajaraman has been instrumental in giving a concrete shape to the vision of Atmanirbharta in telecom sector with his key roles in furthering the indigenous development of 4G and 5G stacks and making giant strides in the area of quantum communication. It is indeed our pleasure to have you here, sir. Sir, may I request you to please deliver the inaugural address on this momentous occasion.
Sri Subramaniam, Chairman of TSDSI and CEO of TCS, Sri Pandey, Member Services, Dr. Upadhyay, CEO of CDOT, and Mr. Mittar, Senior Advisor of TEC, and senior colleagues here from the Department of Telecom and other departments, from CDOT, senior functionaries from CDOT, and the participants in today's workshop from the academic institutions, from industry, from government labs and various ministries of the Government of India. First of all, a very good morning. The context in which I think we are holding this workshop is essentially looking at how all of us together in this in the smaller group can contribute to the larger vision of growth and development in this country. Honorable Prime Minister has said that our economic growth is dependent on a number of factors, one of which is technology. And the goal that the government has set forth, I mean, in terms of GDP growth, in terms of achieving a $1 trillion digital economy by 2025, etc., are predicated on the fact that, or predicated on the assumption that a lot of things will be done under the bonnet to enable this growth and development to happen. And one of the very important factors, I think all of us are aware as students of economics that the traditional factors of production are land, labor, capital. But in today's modern world, I think at least for the last 30, 40 years, technology has joined the ranks of the factors of production, a very important factor of production. And it is increasingly becoming a more important factor of production, to the extent that the traditional factors of production like land and even labor are shrinking into the foreground, into the background. Today, I think capital and technology will dominate the how countries grow and develop. So from that perspective, I think it's very important that if we as a nation are to go forward and make our presence felt in the global economic landscape, the only way forward is to actually get into technology in a very, very big way. And I'm very proud to be an Indian that we have a number of large entities, both in the government and in the private sector, which have been taking this great task of building technology-based products and selling it in this country and also abroad, and creating millions of jobs for ourselves and creating that economic growth and impetus that is required for our growth and development. So in this context, I think we all felt that if technology has to be the basis on which I think we develop, It's very important that India cannot move forward with this pace, I mean, with this proposed rate of growth, unless we become a producer of technology. By being a passive consumer of technology, we cannot afford, or we cannot hope to become what we hope to achieve. So it is very important that all these years, I think we have been very large. I mean, obviously, consumption brings in some amount of growth, but consumption by itself will not produce the desired transformatory results. So therefore, it's very essential that we become producers or creators of technology, I mean, which we are already doing in some ways. But I think, as Mr. N.G. Subramanian has showed in the screen, how we fare in the global map, then I think there's a lot of food for thought. We are doing a lot of things, but I think there are some things that we need to actually put in place in order that we also be part of this global race to build and develop the next round of technology developments. So I would therefore feel that it's, I mean, some of the soft factors, I think Mr. Subramanian has actually mentioned a number of very important elements of this trajectory that we hope to join. But in this, there are a number of intangibles, I think, which is very, very important. The first one is, which I would like to mention here, which I think the Honorable Prime Minister himself mentioned several times, is a whole of government approach, I think, and a whole of nation approach. We cannot actually hope to achieve what was shown up in the screen by Mr. Subramanian unless we work together as in so many ways, I think. Not only, individually, groups, and also as a whole. It's very important that we actually put this, increase the synergy that we currently have. He also mentioned that in his presentation very briefly. So standards development is a very intense process. I think it takes a lot of effort. I as an external observer can only kind of describe it in a very, very, very few words. There are here many champions who are sitting here. Dr. Bhaskar Ramamurthy, Dr. Kiran Kuchi, and many friends from the Dr. Y. Karandikar, and this, and many of the other professors here who actually have kick-started this process for a long time, I think. Similarly, I think the friends from the industry are here. There are many startups here, many companies which have been doing this job, I think, in a very silent fashion. But time has come for us to actually to ensure that this whole of nation approach is put to practice. We have seen that. I have been visiting several of the labs, both in the government as well as in the private sector. It is very important that we know what each other is doing in the country. I think first of all, I think there needs to be an inventorization. Some of us we know in parts, some of them will know in some, to some extent. But I think every one of us to know who else is in this country is working on something similar. So can we work together? Can we put this 2 and 2 together and make it 5 or 10 or 20? So I guess this collaborative and synergistic approach is something that is called for. So therefore, here, in a sense, I think we'll have to be set apart. I think set away our some kind of egos, or maybe our inability to work in smaller groups or in larger groups. So I think there is a lot of human element here, which I think needs to come out. I often hear of stories of how people work in silos. I think because of the imaginary sense of competition, or maybe a sense of who is big, me, whether I'm bigger, I'm doing better than you, or something like that, you become very petty. Those kind of stories also are, I heard, I think. So I think those must be things of the past. If we are to really make an impact as a nation, I think we all have to work together. I think we have to learn to work together. I think, sure there are many good examples here. When I say this, it is not as if it is not happening. There are many people who are already doing it, who have risen above these petty things, these small things, I think, which don't really matter, and have risen above to actually to act as a fulcrum or a pivot, which can actually bring about this transformation. So I think if the whole of nation approach has to be realized, I think it's very, very important that all of us have to put our heads and hearts together in so many ways. Let me also come to it in a different point of view. India is not a country which can afford to throw away tens and hundreds of billions of dollars as many other countries are doing. Like, for instance, in the case of America, has borrowed tens of trillions of dollars in the world market, and it is making available hundreds of billions of dollars to its research establishments. I think it is a very risky thing to do. I mean, I think they are imperiling the nation. They are imperiling the future of the country. I mean, I think that's what I think. So India cannot afford to do that. We are a developing country and we have resources which are very limited. So so there are much more wants than probably the resources that we have. So given that situation, I think India has to always, I think in my view, follow the path of frugal research and development. So it has to be whatever money we have in our hands, whatever limited money, I think we must try and see how we can have a multiplier effect which is far higher than what obtains in other countries. So and that has been demonstrated. I mean, I would like to say give the example of the CDOT's own investments, which they have made in the 4G core and other kinds of work, which I have personally seen. So what would have taken maybe $1 billion for private companies to actually to develop has probably taken a few hundred crores, at max, to actually for CDOT to develop. So in India, it is possible, and it is happening already, not only in government but also in the private sector. So I'm sure that Mr. N.G. Subramaniam, from his thesis experience, also can probably vouchsafe the same. So it is possible to do that, and my belief is that we can extract far more outcomes than what we are doing even now. I think, for that matter, I think if we are able to put our heads and hearts together, if there is somebody who is developing say a 24 gigahertz chip for the millimeter wave, maybe somebody else can actually work on the subsystems, and they can work jointly. And maybe I think if the joint works takes place, then I think perhaps the development cycle can be crashed. It can also be possible that probably the go-to-market trajectory will also be faster. So therefore, it is very important to set aside these petty differences, put in place some frameworks for collaboration. And I think I'm very happy to say that at least from DOT, I think there are many other people who are doing the same. I think this is today during the lunchtime and tea time. I think you must all should be exchanging all these notes on how we can make this happen. In CDOT, for instance, in the last year, they have put in place a collaborative framework, I think. So the target is that, today the government funds CDOT something like 550 crores. So at least, to start with, I think they have, I can say at least about 5-10% of this money is going to the private sector for collaborative research. I think I see a day in which probably next year, I think we must push harder towards a higher goal. I think at least 15-20% of your outlay should go. Similarly, every government lab, every IIT, every institution of research must actually find out some money which they can invest in collaborative R&D. Because let me make it very clear, there is no single person or a single stakeholder or a single vertical which can actually bring about the transformation. It is a group which can collaborate together, which can bring about the transformation. If an academic research institution can create a new concept or an idea, I don't think they can take it to market. I think it requires an entrepreneurial mindset to actually package it and convert it into a commercial product which can sell in the market. It takes a service provider to tell you what is behind the thinking of a customer. So I think unless we all of us work together, maybe it requires a government institution to come in and tell you on how to get through all the processes and procedures. So I think it is collaborative teams, multifunctional teams, faceted teams that will be able to deliver the transformation that we have. So therefore, I would request that in this journey of standards development, it's very important to create that multiplier effect, and I'm sure that can possible only through collaboration. As far as the government is concerned, I think you must all have, some of you must have read this 2018 document called the Indian National Standards Strategy. It's a very important document. I would request, it has been shared in some of the groups, but I would request all the people who are involved in standards making to look at the big picture on why we need to get into the standards. It's very important to understand that, because it is, the big picture will give you a better idea of how to actually to operationalize the small picture. So therefore, it's very important to see what it means, what a standard strategy could mean to the country. We all saw the examples of how Korea, Japan, and many other countries, US and other countries, and even China for that matter, has transformed the ability of the country to derive economic benefit from standards and from patents and from technology products. So therefore, it's very important that we get our strategies right. And therefore, from that perspective, please do read the standard strategy. I think it's very important that it actually it carries a lot of goals, which can probably there are about 23 goals which are set forth in that document. Some of it which may be relevant to us, at least in my view, at least 10-15 of that could be relevant to us. So let's work on that. Then, if you look at the government institutions, I think they are very, very important. I think the TSDSI is a very important institution. I think, Mr. Subramaniam and his team have actually taken it forward. Dr. Bhaskar Ramurthy, who's part of that, and many other doyens have actually enabled this fledgling institution which was set up in 2018 to actually to move forward and create that stimulus within the technology ecosystem. Now we must actually push forward to go to the next level. I think it's very important that, as Mr. Subramanian actually said, it is very important that we push this this organization to the next level, to the creating the participatory effect within the entire ecosystem. We must have, more academic researchers participating in the various working groups. Now I think it's a time to set up those 6G working groups. And it is very important to get the academia, the industry, and the student community, the student community also into this organization on a fast track basis. So I would expect that over the next 6 months, the participation of all those who matter in this technology landscape should all be in your in various working groups or task forces, as the case may be. Similarly, I think it's very important for government organizations, to set up standard cells. I think in India, we have in Department of Telecom the TEC, which I think is done fantastic work over the last several decades. So, TEC needs to, it has been constantly reinventing itself. Now I think TEC has to become a really world-class entity, which actually is a complete facilitator of standards. From an implementer, from a regulatory perspective, I think the mindset has to change into a completely facilitative mindset on how we'll be able to actually to promote, support, encourage, motivate, and assist the various producers of intellectual property within the country to actually convert that into standardization patents and into products. So I think that transformation has to happen, and a lot of reform has been done, and I must congratulate Mr. Mittal and his team for doing a lot of work to actually to make it easy for startups, SMEs, and others to do in doing business, especially on standards. So I think a lot more work needs to be done, I'm sure, under his leadership and with the supervision of Mr. Pandey and Mr. Sahu. I think a lot of transformation can be done in the coming months and years. So I look forward to that, because unless there is a very strong motivator and facilitator, it would be difficult. And today's great work they have done in launching the standards portal, I think is a big step forward. It's a very big step forward. In fact, we participate in the International Telecom Union working groups, task forces, working parties, and so on and so forth. Similarly, I think there are IEEE groups, there are 3GPP working groups, there are Open RAN Alliance working groups, there are many related standards bodies in the world. I would request that all each of you who are present here are interested in a particular sector or a particular slice of this whole standards game. So I'm sure that we should all work together to see how we have a coordinated approach. Let us see that, at the end of the day, we may partly win, we may partly succeed, but our country should win, beyond all counts. I think so. If that has to be done, we got to work together even in standards. We have to coordinate the way in which we function, we work on standards, and for that I think the Telecom Engineering Center has set up the national working groups, which mirror the various working groups which are in the international standards bodies. So I request as many academic professionals to join this, industry professionals to join this, and ably supported by TSDSI. And we should be able to take forward to these standards bodies a very coordinated way in ensuring that our country's strategic interests are protected and stands above all our considerations. Similarly, I think it's very important. I could also take off this point from Mr. Subramaniam's presentation. Very important to incentivize, whatever we are trying to do, or trying to achieve. We need to incentivize creation of IP. We need to incentivize standards contribution. We also need to incentivize standard essential patents in various ways, in various stakeholder bodies that we have. Especially, I think, if you look at the, academic institutions, I think, during my conversations with several of the academic researchers, some of them have the bandwidth to actually to research on a particular project and throw and take a particular idea to a certain stage, maybe TRL 3 or 4 or something like that. But after that, I think there is no patience, because there are other projects which are waiting, there are other commitments like teaching and so on and so forth. So there is a gap. I think the other day I was talking to a professor from IIT Mumbai. I think he has developed some optical transceiver technology. So I was asking whether you are going to take it forward, file ACPs and all that stuff. Obviously he has a restriction on his time. So therefore we need to see how this is like a relay race. if some say about a couple of crores have been invested in a research project, it must be translated into something which actually brings economic benefit to the country. It cannot be dust, gathering dust in a lab as some kind of a patent which has been filed, or maybe a paper which has been published, or so on and so forth. So therefore, that is very important that maybe it is like a relay race. Somebody, I think the persons who are doing research in academic laboratories must find the next person to whom the baton can be handed over so the race can continue. It could be a startup, it could be another set of researchers, it could be a researcher in some other research lab, it could be a large industry body, whatever. A lot of work is being done nevertheless, but this should ensure that every rupee that is spent on research has a multiplier effect on the economy. It cannot be just be used for publications or just filing patents. So therefore, I would request that we all need to work together to create that I need to stitch all these dots, which probably are in smaller groups or maybe unconnected in many ways, and connect them together into a powerful network which actually delivers that game-changing transformation that we deserve, perhaps. I will end by saying that today's standards conclave is just the beginning. I would request that TSDSI and TEC should make it an annual event, to actually to create that kind of that multiplier effect. So I would request you to also work with government to create policies that actually enable the transformation. We in the government have done a lot of work, which I think Mr. Subramanian himself has outlined. I wouldn't like to repeat that, but a lot more needs to be done. I think we need to increase the funding. We need to increase hack away at the policies that actually prevent large amounts of research happening in this country in a meaningful manner, and so on and so forth. The government of India is has just now introduced that National Research Foundation bill. I think it will be a very transformative thing. Nearly about 50,000 crores of money is being spent in various programs of the government of India in research. So I'm sure that this forming this NRF will bring a transformative effect in the size and the quality of the research funding that happens in this country. So though Department of Telecom has brought in this TTDF with about a 500 crore funding bucket on an annual basis, I think the NRF will have a very huge transformative effect once it comes through. So similarly, I think we also need to work with other funding bodies to create that scale and size and the quality that research deserves. So with these few words, I'll stop here. I'm sure that today's deliberation will bring about a lot more wisdom that when we have together. I would request all of you to continue to collaborate offline, online in so many ways that enables that synergy to happen. Please create that groups that you can within your ecosystem. Try to connect all those groups together in various forms, and so that I think we all synchronize ourselves and harmonize ourselves in various ways to deliver that quality of effort, the quality of results or outcomes that we all avidly look forward to. Finally, at the end, I think as the Minister of Communication has stated a few days ago, is that we need to be on the global patent landscape by having at least 10% of the patents which in 6G. Similarly, I think we can set up targets, very difficult targets, but I think collectively, if we are able to work together, we should be able to achieve that goal. And let me also say that that institutions, be it government institutions or academic institutions or industrial houses, I think that the dividing line between our institutions and the other stakeholders must actually disappear. We must actually become seamless in terms of collaborations. Similarly, I think I think it's very important that the right kind of incentives are built in all these institutions, be it government institutions or industry or academia. Like for instance, I will just leave a thought here. In academic institutions currently, promotions, etc., are probably based on publications and maybe a little bit on some patents, etc. So I think maybe productization and actually delivering solutions to the market should be the way in which I think probably I think you should be giving a higher kind of weightage for that. Similarly, in industrial houses, participation in standards bodies, contributions to standards bodies, etc., should be given a strong preference. I think there are many senior captains of the industry here. We must actually incentivize them by giving them cash incentives, etc. In fact, Mr. Dr. Upadhyay himself has brought in a small scheme to actually promote this standards contribution. So I would request that every one of us in small ways, I think these are all experiments, I think one is not very sure whether it is going to work or not. It doesn't matter. I think we can make a beginning by having this kick started, and maybe if we'll fine tune it as we go by. The right kind of incentives will all hopefully bring about this transformation. Thank you, and I wish you all the best.
Thank you, sir, for giving us key insights into the importance of synergy and collaboration across various stakeholders in increasing India's participation in global standardization activities. We once again express our sincere thanks and heartfelt gratitude to our Honorable Secretary Telecom for gracing this occasion with his esteemed presence. Sir, we thank you for sharing a quantum of your precious time to be a part of this workshop. May I now request Ms. Shobha N. Bhambani, DDG RCTEC, to formally present a token of thanks and gratitude to Shri K. Rajaraman, Chairman, Digital Communications Commission and Secretary, Department of Telecommunications, Government of India. We thank you, sir. May I now request Dr. Pankaj Kumar Dalela, Director CDOT, to formally present a token of thanks and gratitude to Shri Uma Shankar Pandey, Member Services, Digital Communications Commission, Government of India. Thank you, sir. May I now request Shri Ravinder Ambardar, Head Marketing CDOT, to formally present a token of thanks and gratitude to Shri N.G. Subramaniam, Chair Telecommunications Standards Development Society India, TSTSI. Thank you, sir. May I now request Shri N. Mohan Ram, DG TSI, to formally present a token of thanks and gratitude to Shri R.R. Mittar, Advisor and Head, Telecommunication Engineering Center, DEC, Government of India. We thank you, sir. We once again extend our sincere thanks and heartfelt gratitude to all our distinguished guests and dignitaries. Ladies and gentlemen, we hereby conclude the opening plenary session. We will now have a tea break of approximately 20 minutes, and we shall reassemble here for the next session. The delegates are requested to wear their badges. Our coordinators will guide you to the designated areas for tea and refreshments. We have also staged an exhibition outside the auditorium that showcases indigenous technological solutions. The exhibition can be visited during the breaks.
2020. This standard is a major breakthrough for bridging the rural-urban digital divide in 5G deployment due to enhanced coverage. As technology development cycles shrink, spurred by softwareization and disaggregation, India, traditionally a software powerhouse and a huge market, has an opportunity to take a leadership position in the global technology landscape. IP and standards will drive the economic growth. With TSDSI RIT becoming part of the global IMT 2020 specifications, India is poised to play a more active role in the global standards arena. Design local, deploy global. Join us to deliver more such solutions that address the specific requirements of the developing world based on indigenous IP. Since the first mobile call made on 31st July 1995, Indian telecom sector has grown as the second largest telecom market in the world, connecting India affordably and transforming our society. Despite the huge diversity in terrain, culture, user base, climate, and constrained power supply and high population density, Indians enjoy the lowest telecom tariffs in the world. Therefore, our requirements are different from other regions. The global telecom standards ecosystem has been dominated by 3GPP and ITU. However, India's contribution was not significant until the mid-2010s. A need for an Indian telecommunications standards development organization that can reflect the diverse needs of our market and promote our IP on the global stage was felt. This was acknowledged in the National Telecom Policy 2012.
I would expect a standard society to articulate India's concern on the international stage, which are India specific, and the world must listen to that. Because I see electronic manufacturing and communication technology also merging at some point of time.
TSDSI is an autonomous, membership-based body comprising entities from across the telecom ecosystem and application verticals. We are recognized by DoT as India's Telecom SDO. Soon after inception, we became organizational partner of 3GPP and joined the One M2M partnership project, and the journey continues with further partnership agreements being signed up with other global forums. TSDSI's vision is to ensure that digital communication standards increasingly drive domestic economic and policy activities, thereby creating a leadership position through India's participation in emerging digital communication standards in global SDOs. Our technical activities are carried out in two study groups: networks and services and solutions. Standards development falls into three phases: pre-standards, standards, and post. Our roadmap is driven by this philosophy, and specific topics are taken up in task forces and technology roadmap item proposal forums. TSDSI, in a relatively short span of 6 years, has made a mark in the standards world. TSDSI's One M2M standard for IoT, M2M applications, and 3GPP IMT advanced standards for 4G have been transposed as national standards. 3GPP has incorporated support for NAVIC, the navigation system created by ISRO, in the relevant 3GPP specifications. Devices supporting NAVIC, in addition to GPS, are now commercially available in the market. Our latest accomplishment is the incorporation of the TSDSI 5G radio interface technology as an independent technology in the ITU-R specifications for IMT 2020. This standard is a major breakthrough for bridging the rural-urban digital divide in 5G deployment due to enhanced coverage. As technology development cycles shrink, spurred by softwareization and disaggregation, India, traditionally a software powerhouse and a huge market, has an opportunity to take a leadership position in the global technology landscape. IP and standards will drive the economic growth. With TSDSI RIT becoming part of the global IMT 2020 specifications, India is poised to play a more active role in the global standards arena. Design local, deploy global. Join us to deliver more such solutions that address the specific requirements of the developing world based on indigenous IP.
And take your respective seats. We'll start our next session in a couple of minutes. I request you all to please settle down and take your respective seats. the workshop, in the august presence of Secretary Telecom, I welcome you back to our first technical session that aims to give an elaborate description of the step-by-step process of standards making. May I request the esteemed speakers of this session to please take their respective seats on the dais. Shri R. Mittal, Advisor and Head, Telecommunication Engineering Center, TEC, Government of India. Shri Shrikant Chandrasekharan, Global Practice Lead, Foundational Technologies, IEEE Standards Association. Shri A.K. Mittal, Advisor Network Systems and Technologies, TSTSI. Dr. Sendil Kumar, Director Standards and Spectrum, Ericsson. Shri Arindam Bhattacharya, Group Leader, CDOT. Ladies and gentlemen, I request you to please settle down and take your respective seats. Our first speaker of this session is Shri Ritu Ranjan Mittal, who is currently holding the position of Advisor and Head, Telecommunication Engineering Center, TEC, an Indian telecommunications service officer with over 35 years of experience in the telecom industry. Shri Mittal has worked on various projects related to the development and deployment of telecom networks, standards, and policies in India. He has also been involved in the development of various technical standards and specifications for the telecom technologies. He is actively participating in the meetings of standards development organizations, including ITU, ETSI, APT, and WRC, and also interacts with other international fora, including 3GPP, ETSI, IETF, and 1M2M. It's our honor to have you here, sir. May I request you to please deliver your talk.
Yeah, so thank you for the kind introduction. Uh, what I'm going to talk is, let's say, a startup kit. Startup kit, how one participates in ITU. We have specially chosen CDOT to be the venue because CDOT has, I mean, of course, being a development center in telecom, we have a lot of youngsters. Of course, CDOT is participating, but we thought coming here and sharing whatever we know in front of young engineers and developers will give a small momentum to the overall effort that Government of India wants in terms of standardization. So as Secretary told, the whole standardization efforts in TEC is done through what we call a National Working Group, NWG. But before I come to NWG, so there are multiple standardization body. I'll talk something about ITU. We have esteemed speakers on the panel from for the IEEE, 3GPP, and 1M, 2M. And okay, so this is the ITU structure. It is plenipotentiary conference, then ITU council, then ITU R for the radio, D for the development, and T for standardization. Of course, there is bodies like WTSA or meetings like WTSA, World Telecommunications Standardization Assembly. For the radio, it is World Radio Conference and the Radio Regulation Assembly. In Government of India, radio effort is spearheaded by WPC. We have Mr. Christopher here from WPC. Then for the development effort is handled by, because it is policy related recommendations, I would say. It is handled by the policy wings in DOT, licensing wings in DOT. Then T work, ITU-T standardization work is given to TEC. So what are recommendations and what are regulations? ITU-T, whatever it does, it is all recommendation. It is up to the country to really adopt. If it adopts, then it can make a standard. Otherwise, it may not adopt. So it needs a national law or regulation. But if there is a radio regulation from ITU-R, then it becomes binding. ITU-D, as I told, deals with contributions come in terms of experience sharing, so that policies can evolve out of ITU-D initiatives. So the mandate of study group is agreed once in 4 years at the highest organ by WTSA. Just to know, tell you that WTSA last meeting was held in 2020 in March. Because of COVID, it went into a 6-year cycle. But to make up for that, we are having again WTSA 2024. It happened in 2022, 2024. So that thereafter it will be 4 years. And this time, you'll be happy to know that India is organizing WTSA for the first time in October. The dates I'm not very sure of. In October in Delhi. So it is all the more important for Indian participation to be seen that, okay, India kind of has arrived in the world standardization map. So the study period between two WTSAs is called a study period. And of course, there are some resolutions which governs how WTSA shall function. So study group, I'll come to the details of study group, but just a hierarchical structure. That study group is divided into, of course, broad technical areas. Then within a study group, there are working parties. So any broad technical area is subdivided into area which is called a working group, working party. And below the working party is something where actual technical work happens. These are called questions. These works are handled by what ITU-T called rapporteurs. The rapporteurs will make the note the proceedings of the various study group meetings, of the various question meetings that happens within the study group, and then make a report with the help of editor, and then present to the next stage for its approval. But the main technical officer, if you can say, is the rapporteur. So these are the 11 study groups. Study group 2 and 3 are most on the policy. You can see it is economic and policy, and operational aspects has numbering. So all the numbering allocations which are done worldwide are controlled or handled by study group 2. Of course, there are other recommendations also. It is a proud privilege to add that last ITU-T WTSA meeting, because of the efforts of our additional secretary and Mr. Shakya, and India got for the first time some leadership positions in ITU-T sector. For example, I chair the ITU-T study group 11 on protocols testing and combating counterfeiting. We have in study group 2 also vice chair Mr. V.K. Roy, study group 13 Mr. Abhishankar Verma. Then not only the government officers per se, the study group positions went to academia. This professor from ISC, who I think Professor Pradipta Biswas in study group 9. Then in 15 also there is a person from, I'm forgetting the name, Mr. Sudhita Vangi, thank you. He's in transport access and home. Transport access as home deals with fiber, basically. So from Sterlite, security also has Mr. P.K. Singh as. So these are the vice chairs and chair positions which are given at the time of WTSA meetings. After that, a study group forms a working parties. So not all vice chairs automatically becomes chairs of working party. That chairs of working party is given based on the experience that a person brings in there, and that is decided by the study group management. So we have Mr. Sushil has a leadership role in study group 20. We have done a lot of work in association with the industry in the IoT study group 20, and on that account he's in working party. As was discussed, so national working groups initially were formed as a co-terminus with the various study group. But now what we have also done is we have analyzed what IEEE is doing in standardization. So various activities that are happening, so we have mapped to these broad 11 areas. And of course, we have Mr. Sri Chandran. He will let you know all the details. Keeping in mind that we are late, I am a little fast. Okay, so so this is just a pictorial recommendation representation that so we bring together startups, industries, academia, government organizations, research institutes, and we make discussion and make contributions. These contributions are finalized in NWG, National Working Group meetings. Then they are approved. In case of ITU-T, it is approved by member services. And in case of ITU T, sorry, it is approved by member technology. For the T sector, it is, R is member technology and T is member services. And then they go as a collective contribution. So being a government, we are representing there as a member state. So member states have voting right. Though in ITU, all effort is made to arrive decision by consensus. So that is what is their forte, that never enter into voting, avoid. So that is the primary purpose of chair and vice chairs, that you don't there will be a system of coffee breaks. So many things are there just to bring a harmonization in the text, because normally dissenting and all those things are avoided there. Okay, so member states are participating, governments are participating as member states. I think CDOT is a sector member and TRI also is a sector member. But it is just to add that sometimes CDOT participates there as a sector member, and sometimes they contribute through the National Working Group. I can take example of National Working Group 11, in which CDOT has given contribution of their CEIR, which was recently launched, Central Equipment Identity Register. And let me tell you that CEIR has a lot of interest in many member states. I would not say that, let's say, USA is interested, but I think completely the whole of Africa is interested in CEIR, depending upon the participation that we get in those meetings, in those questions. So when to submit? At least 2 months before the meeting in question, if translation is requested, because there are 6 languages: Arabic, French, Russian, I think Portuguese also. So if you want a translation, 2 months before. Otherwise, 12 calendar days before the meeting. And if it is within the 12 calendar days, it will be not taken into agenda. It will go to the next meeting, that contribution. Because the idea is that you cannot make a last minute contribution and then kind of try to gather the support. People should, all the experts should get enough time to really threadbare go through it. Okay, so this is a natural work cycle, proposal by members, study group is submitted, then consensus building. So the important thing in ITU at least is consensus building. It will be glad to know how others in 3GPP and TSGSI and IEEE and 1M2M esteemed speakers will tell, but ITU kind of takes pride that, okay, everything is with consensus. So experts in rapporteur groups develop the text as per received contributions. Then the mature text is agreed by study group. And of course, there is a secretarial service wherein professional editing will be done subsequently. So this is another pictorial representation. At the center, you can see there's a member contribution. If there is a contribution for a new work item, then some A1 justification is required. A1 justification means people would like to know why it is brought to ITU. Sometimes I have seen questions being raised that, okay, this particular topic is dealt in other SDOs. Maybe it is dealt in 3GPP. Why do you come here? Maybe we have not mentioned, there is a, if you see the transport layer, router and the LAN switch all working is now on through the standards based out of IETF, International Engineering Task Force. They don't even formally meet. They decide their standards over meeting and mails and documents called RFC, request for comments. So sometimes it is raised like this. But let me tell you here, the whole for example, a country can sometimes strategically decide, and I have seen it happening, not to take a particular study or their request for a new work in one of the other specialized organs. Maybe they want to sometimes avoid expert scrutiny here. And there are some strategic objectives. I can mention China. In the last WTSA, they wanted to push a resolution by the name new IP. So we are aware that there is IP version 4 and there is IP version 6. So there is something called new IP. So it was opposed, and I think it did not see the light of the day. But now what China is doing, that they are seeing what were their important features, and they are bringing the new IP features in terms bits here and there. So they will go to ITF. So there it is. I mean, there is some kind of a strategy also in international standardization. That also is an important message I would like to give, because I have now attended a couple of meetings as chair. So I see all these things happening, and there will be push by countries who are not very comfortable on this to somehow derail those processes. So at that level, so many things. So, and at least I'll be interested to know what other bodies handle these things. So once the study group agrees, then the work is assigned, editor is assigned. So then the editor maintains the baseline text. And of course, it is not a closed door system. So there are a system of license statements within the other study groups and also to other SDOs. SDOs, that means Standard Development Organizations. So that is a very formal kind of a process. License statements will come, the replies will come, the study group meetings or the other meetings will take care. And so once the text is mature, then it is submitted to study group or working party, which initiates approval process. And then, of course, it is circulated to all the member states also before the approval. It is called consented or determined. So then it is, so if a member state objects, then it may not become a recommendation also. At least it will be re-referred to the study group to see it. So this is the cycle. Contribution is important. I would like to take the cue from NG Subramanian's speech, where he said that the solution which we may be providing is small, but the problem which we may be solving is very big. So though there is a big fight whether a particular NWI or new work item should start or not, but I think there is a merit in seeing what existing recommendations are there, and if it's a revision, it can sometimes more easily sail through. Because maybe if, let's say, CDOT develops a product and that product is working based on the field feedback, it develops a patch to kind of fix something. Maybe there is a lesson in that. So I would like to urge CDOT developers to see whether is it something new what they have done? Is it required? Does it merit standardization? So all these things are because NWI, new work item, there is a challenge to start. There is good justification, and it is threadbare, debated, and attempt is sometimes made to kind of, I have deliberated it, to scuttle it. Okay, I have said it is consensus-based decisions in ITU. So there are two processes. One is traditional approval process, which was the traditional one. It used to take long time. Study group 2 and 3, which deals with tariff policy and the numbering and operational aspects, they fall under TAP. Otherwise, it is the alternative approval process. Then there is a word telecommunication standardization assembly, and the study group agreement of anyway. So this is the main three. If anything at the study group level is not agreed, then it will obviously be taken to WTSA. I think I will, in the interest of time, we have broadly have told that TAP, and so if you want to contribute, basically apart from the two study groups, it is alternative approval process. It moves fast. Okay, key leadership positions. I've discussed chairman, vice chairman, working party chairman, vice chair. So there is a vice chair of a study group, which is formalized and approved in a WTSA. But a working party chair is within the study group mandate based on their expertise on the subject. Then rapporteurs also are actually technical experts, liaison representatives, editors. Then there is a secretariat, of course, to help. So I think the main message we would, I would like to give is that making a contribution is not very difficult. There is a very streamlined process. Thanks to the SCP portal now launched with the efforts of Mr. Avinash Agarwal, our DDG standardization, it will be very easy to really become a member and just see what is happening. And again, taking a cue from NG Subramaniam, first just be observer, and then you can be follower and contributor. And of course, the Indian aim is to become leader. So this portal should, and slowly we will interact with other portals, TSDSI, IEEE, depending upon whatever they would like to share through our portal. Okay, so these are the broad areas. It is in presentation. In the interest of time, I will just go through it fast. 9, 11 is signaling, and 12 is QA. 13 is future networks by the name. 17, 20. So all these SGs have a NWG. So all the NWG participation is possible now through the standardization coordination portal, which was just launched by Secretary Sir. Just to tell you, I have mentioned that WTSA 2022 happened in 2022. So I was given this position. We have one officer, Anshul Kumar Gupta. He's a rapporteur on being a technical expert on the subject he's dealing. And also from CDOT, we have Associate Rapporteur, Mr. Biren Karmarkar, who is spearheading the CEIR effort of ITU of CDOT in ITU. So I would urge other CDOT engineers and developers to kindly be a little more proactive, so that the vision just kind of given by Secretary, we are able to march towards that. Just to only a snapshot of one study group. So there is a working party, and then they have a questions. The questions are broad, and under the questions there will be new work items or recommendations. So every question will have so many recommendations. It's a matter of you could make a new work item, take it to the recommendation level, or you could contribute to the existing recommendation. As we discussed, that if you are solving a problem, maybe you can look at the standards document, maybe it is worth taking it through the so there are 4 working parties. So it is the working party 4 where the CDOT CEIR recommendations are being discussed, and specifically the question 15, combating counterfeit and stolen telecommunication ICT devices. So thank you.
Thank you, sir, for giving us an elaborate description of both the national and global telecom standards framework. We'll take the questions at the end of the session, and our virtual participants can write their questions in the chat window. Due to paucity of time constraints, we may not be able to take all the questions, so we request you to put them in the chat window or give it to us. We'll submit the answers to you later. Our next speaker in this session is Sri Kant Chandrasekharan, Global Practice Lead, Foundational Technologies, IEEE Standards Association. Sri Chandrasekharan has been associated with the IEEE since 2012, focusing on developing key standardization programs in emerging areas and building end-to-end trustworthy devices and systems with emphasis on cybersecurity. He also heads the standardization efforts for the Asia-Pacific region and leads business operations for the IEEE's office in India. He was also associated with Freescale Semiconductors for 17 years, managing a global electronic design automation R&D team. It's our pleasure to have you here, sir. May I request you to please deliver your talk?
Good morning, or rather, it's almost good afternoon, I guess. So first, I would like to thank CDOT and TEC for inviting me to give this talk on IEEE standards. So what I'm going to do is I'm going to focus on not on the technology side of things. I want to focus on how people can engage with the IEEE Standards Association, what is the process, and I touch upon some of the work that we are doing in India, where the leadership in India has come together and driving certain standards. So it's not a technology deep dive from that perspective, but hopefully it gives a view of how one can engage with the IEEE. And I think there are a couple of points I just wanted to highlight before I get into the talk. I think the secretary talked about faculty and academia getting into standards. And also there was a mention from the TSDSA chairman about how people can start observing, right? So I think those are extremely important points. We may not appreciate it at this point, but standards is the place where experts come together. So when you are a student and if you want to engage with experts, what is the best way better than just join the working group, right? We start working and you can just observe, you can make the connections, and as you build your expertise, you can contribute and take leadership position. I think it's a extremely valuable point to make, and I just wanted to support that. With that, I will move on with my presentation. I hope this one works. So a couple of things I wanted to mention here. I'm a senior member of the IEEE, but also as per the IEEE SA bylaws, the views expressed in this talk, they are just my personal opinions. They are not reflecting the organizational viewpoints, right? So IEEE, a lot of people know IEEE from different lenses. If you go to the faculty and academia, they know about us from a conference, paper publications, IEEE Explore. And when you go to the industry, they know from a standards perspective, right? So I think now these things are converging in interesting ways. Today, if you look at a lot of academic institutions, universities, they have incubators, they have startup hubs, right? So people who are doing their PhD, they want to already monetize their ideas into a product. And I think it's very important to understand some of the underlying factors. I think we talked about quite a lot about IPR and patents. I think people need to recognize that. And people need to understand that when you're developing systems, it needs to work in a global scale, right? Your system is perhaps going to be part of a bigger system. So these things are converging, and I think we are working together to understand how faculty, academia, industry can come together in developing these standards as these technologies are perhaps accelerating much faster. Back in the day, perhaps research to product development might be 8 to 10 years, but now I'm seeing perhaps it's 3 to 4 years, right? So in that crunch, we need to make sure that everybody is aligned as we progress technology. So the structure of the organization, I thought I will touch upon that. It's very different to perhaps what a lot of people, the systems they participate from India. Typically, I think R.R. Mithar talked about ITU, people might be engaged in IEC and ISO. Those are all what we call as nation-based participation, right? So you represent either India as a country or whichever country you belong to. But in IEEE, it's quite a different paradigm. I will touch upon it. But within the structure itself, IEEE is a volunteer-driven organization. The members have a leadership board called the Board of Directors, and the chairman of that board is the president and CEO of IEEE that gets elected every year. I am a staff of the IEEE. We are represented by different verticals, and I have put an orange box for Standards Association. It's very important to understand a couple of nuances here. Standards Association is the keeper of the governance. That means that we develop the policies on how people should come together and develop standards. What are the policies to create new standards? How do we manage the patent policy? How do you do audits? And our technical experts come from technical activities. People might have heard about IEEE Computer Society, IEEE Communication Society, several of these societies. The experts come from the societies. So it's kind of a tight coupling between technical activities and Standards Association, and I will elaborate that a little bit more in a couple of slides. One of the things about 4 or 5 years back, one of the challenges people had was how to engage with IEEE. It's a very distributed organization, extremely complex. I still learn new things about my own organization even today, right? So it's a little bit depressing sometimes, but talks about the autonomous aspects of the IEEE. But then I think we should make things easier for people from the external world to engage with us, especially in the construct that we are in. We are not, as I said, a nation-based organization. We are based on individuals and entities. And how do these individuals figure out where to engage with the organization? So we kind of, within the Standards Association, oriented ourselves more towards a corporate structure, if you can call that. So we have a set of practices. There is one practice missing in the slide. The latest practice we started was on sustainability. I think everybody is talking about sustainability today. So I manage the foundational technology practice, which is a horizontal practice. And one of the missions of this particular practice is to how to build trust in systems. One of the things IEEE has taken a view, as we are enabling technologies, and the technologies are getting enabled very fast as we speak, how do we also try to come to terms with what is the impact of these technologies, whether it is from a cyber security perspective, or people talk about data privacy, data identity, all these what I call as non-functional requirements of the technology, right? So they don't directly affect the functionality of the product itself, but they are getting very, very critical. So one of the core objectives of the foundational technology practice is called building trust in systems, and we have vertical based practices, and I have mentioned what are the core areas each of these practices are trying to drive within that particular focus area, right? So, any talk is not complete without IEEE 802. I think it's important to, today we are living in a different world. I'm sure I saw posters around saying what is the SSID and the guest Wi-Fi password. So wherever we go, whether it's at a hotel, a airport, it doesn't matter where you are. The first thing you want to do is how can I download and interact with the world without paying much cost to it, right? So 2020 marked the 40th anniversary, so now we are almost 43 years of this technology. But one thing I wanted to really bring to raise the level of awareness is when we develop standards, there are a couple of things we want to keep in mind. Let's assume that we are starting a working group today. Perhaps the standards will hit the market and get adopted in the market a decade from now, right? You have to understand it takes 4 or 5 years to develop the standards. And the fact, just because of the fact that the standards get developed, doesn't mean everybody is going to switch on the lights and start implementing those standards. It takes another 4 or 5 years to perhaps for the market to embrace the standards, especially if it is done in a good way. So you are looking at a horizon of 8 to 10 years before the market is adopted. And the reason I talk about that is when we are developing standards today, we need to kind of appreciate that people are probably going to use it mainstream 5 to 10 years from now. So I think the standards need to be future-proof. You have to understand how the society is evolving and make sure that you are able to scale the standard as the technology is scaling, right? These things, now it is 40 years. The technology that used Wi-Fi in the very beginning, perhaps in the 80s, you will see it in the museum today. Every other technology is using it, not the technology that it was intended for. And 802.11, yesterday Subhash gave a great talk at the Telecom Regulatory Authority of India. We did a small workshop with them for the TRAI officers. And today at Wi-Fi 6, of course, we moved from alphabetic numbering schemes. People don't understand B, G, N, A, C, X. It's all very complicated. So we are trying to embrace marketing terms. So, IEEE is not great at marketing, but we are coming there eventually. So today's technology AX is called Wi-Fi 6. And there is an extended Wi-Fi called Wi-Fi 6E when you play in the 6 gigahertz arena, right? So today it's 2.4 and 5, and Wi-Fi 6 also allows for 6 gigahertz. And there is discussions happening in India as we speak. How do we manage that spectrum? And then there is Wi-Fi 7, where the first draft is already available. So that is going to give you speeds close to about 30 Gbps. That's amazing. But having said that, I reflect on my own life. When I travel on the street, when I travel in the metro or airport, people are downloading 4K video and watching it live, right? So there is a lot of hunger for data, independent of where you are from. And I think these are the technologies that are driving that hunger, right? So, and you have to understand that as we are driving data, you have to look at power efficiencies, the privacy aspect, randomization of the MAC addresses, several innovations that are going in. And that requires a collective thought process. It requires experts to come together and try to understand how we can do these things, progress technology, progress also the impact that the technology has in the same way. IEEE used to be expanded as Institute of Electrical and Electronic Engineers, and I do not know how many people are aware. Back in the day, maybe 30, 40 years back, you needed to be an engineer to be part of the IEEE, right? The world has evolved significantly from there. In fact, today's perhaps largest ecosystem is coming from non-engineers. It's coming from ethicists, philosophers, right? People are looking at social impact of AI, and the social impact of AI, you don't want engineers to be defining that. I don't think that will be the right approach. People who are using it should be defining it, what it means to them, right? So that requirement no longer exists. Along with that, we no longer expand IEEE. So sometimes I interact with the people, and when you hear the prefix doctor, given how my brain is wired, I assume that they have done a PhD. But then you go to industries, particularly in the healthcare segment, they are actually medical doctors who are actually coming into standards organization and developing healthcare products and devices. And I think it's a great community, because you want the doctors to be designing what is required for them, not engineers to be designing what is required for the doctors. I don't think that's, engineers develop the protocols, but the user interface, how it should reflect what they need about the patient, I think the right community should come together. So in that perspective, I think we have broadened our horizons. We are across the technology space. I've touched upon a few things like organic components. I talked about the social technical standards. And when we started doing the socio-technical standards, there was a little bit of a challenge from the community, right? Is IEEE the right place to look at these kind of problems? I think absolutely it is, right? Now every organization is doing it. And not only we started looking at AI ethics, but there are some critical work happening in children data framework. For example, today, I'm sure everybody will appreciate in this audience, people at the age of 3, people at the age of 5, they are on laptops, iPads, mobile technology. They are using applications. Sometimes my daughter comes and says what I'm doing wrong with a particular application, right? And as part of using that application, they are interacting with the external world. They are interacting with the application developer, with the privacy terms, everything, right? So they are almost in some sense behaving like the way I behave and interact with the technology. So in that context, how do we manage the privacy? How do we do the data governance of children data, right? So very interesting work that's happening. I really want to emphasize that, because we can get very bogged down in the technology side of things and lose the big picture, right? So how is the technology impacting our society? So I just wanted to make sure. And a lot of these technologies are being driven by the technologies that people in this room are developing. It is the 5G standards or the Wi-Fi standards. So it's very important to understand how these things are making an impact. So a lot of people know IEEE from the industry side, mainly from a standards development perspective. I wanted to touch upon a couple of things. The idea is not to go through all the bubbles here. One of the things we started developing about 10 years back is a program called the Industry Connections Program. Very important program, because when technology was evolving at a very fast pace, one of the things we realized that it was becoming multidisciplinary. It was becoming very complex. So in that context, we thought that there should be a platform where people to come together and kind of debate what needs to be developed before actually developing the standard, right? So we called it the pre-standardization platform. It's a 2-year program where people come together, debate the technology use, the technology evolution, perhaps develop a roadmap around the technology, and then say what standards are required, and then get into the standards development process. The other thing I wanted to touch upon here is the impact of open source. I'm sure, when I was in university, I used to use a lot of open source, and it's still there. But one of the things that open source is doing is it's creating a lot of de facto standards. Even in telecommunication world today, there are people talking about ORAN, right? So it's becoming very critical part. So, and these two paradigms are quite different. If you look at a standard setting environment, the formal environment, and the open source environment. So how do you make sense out of this, right? And then IEEE started a platform called IEEE SA Open, where they worked on it for about 4 to 5 years, creating a governance model on how these two communities come together and work on it. Because today, one of the things we are also doing as the technology is becoming complex, we are developing a lot of reference architectures, reference frameworks. So what does a reference architecture mean? They are actually not implementable. It's a high-level view of what the architecture should look like, and a lot of times that implementation happens on the open source community. So you need to understand, how we can make these two communities work together. So a little bit on the governance and the process side. Within the IEEE, it's a fairly watertight process. When you have watertight process, the governance is not trivial. It is quite complex. I want to touch upon a couple of things here. The IEEE Standards Association Board of Governors, which actually met in Delhi beginning of this year, they are the epic body, they are strategic body, but the bread and butter of our organization is the standards board, which look at how new standards are proposed, how they go through the cycle, and how they get published. And I have a chart to explain that. So I mentioned about 10 minutes back when I started the talk that the standards development is a kind of a coupling between the standards association, which manages the process, and then the technical activities. So the standards committee is the bridge between the two. The standards committee actually belongs to the societies. So if you look at IEEE 802, there is a standards committee called the Landman Standards Committee. That's the name of standards committee, and it sits within the IEEE Computer Society. And then the governance happens within the IEEE Standards Association. So that is the stitch between the two. And then the standards committees does a lot of different things, right? They do study groups where people try to understand what needs to be developed. And then they do working groups, and they have an administrative committee to manage the whole process. It's a very large and diverse ecosystem. I said that it's no longer about electronics and electrical engineering, right? So these are the number of committees, standards committees that you have. For example, if you look at Power and Energy Society, they have 16 standards committees looking at different aspects of power and energy, looking at transformers, relays, smart grid. So there are all different things, right? Everybody has a scope, and they work within their scope, right? So and sometimes, and it's getting very confusing these days, when you talk about a particular problem, what should be the standards committee that you need to pick, right? For example, communication in a vehicle, should it go to the communication society or should it go to the vehicular technology society, right? So with multidisciplinary environments, it's getting complex, but the structure allows for multiple societies to come together. And the beauty of this system, the reason why it is created is, one, it houses the working groups itself, the standards development, but we are time constrained. Not everybody can participate in every working group. It is just not practical today. So what happens is, once the working group develops a standard, then it goes to a standards committee where experts can actually critique on that standard. And when I say critique, don't take it negatively. It is a positive criticism on how the standards can be made better, right? So it's a very powerful structure on how you can actually contribute to the standards without actually being part of the working group. So there are two types of standards development, the individual method and the entity method. Simplistically put, in the individual method, each human being, each person, they get their own vote. They represent their own expertise, not the views of their organization or of their country, right? They represent themselves. IEEE 802, for example, is an individual standard. And then we have an entity-based method where entities come together and develop the standards. So one entity, one vote, similar to the ETSI structure, except that it's always one entity, one vote, and independent of the size of the entity, right? So and there are a couple of nuances here. In the entity-based working group, only you need to be a member of the IEEE Standards Association as an entity member to participate. But recently they made a change that if you are not a corporate member, you can still observe the working group. You can actually come in and join, and it's up to the working group chair actually to allow whether they want to take your views. In the individual method, it's even more open. the leadership have fiduciary responsibility to the organization, so they need to be individual members. But the working group members do not need any affiliation to the IEEE, any affiliation either to the IEEE or to the IEEE Standards Association. Pretty much anybody with an interest can join an individual working group, can start participating. They have a slightly different governance structure where you earn your voting rights. So you just can't rock up to a random meeting and just vote on the ballot, right? So you have to actually go through the process. You have to earn your voting rights. Typically, they say that you need to have attended 2 out of the last 4 meetings to vote on the 4th meeting, right? So just to have some sanity around the structure, right? So we do different types of standards. Of course, the standards are mandatory requirements, which typically is governed by the word shall. Then we have recommended practice, which is a view that the working group has taken, but they are not enforcing it. There are perhaps other ways to do it, so that they typically, you will see the word should. Then we have best practices guides, where the working group is not taking any perspective on it. They are saying that there are multiple ways of doing these things based on your environment, your parameters. You do the appropriate approach, and I won't delve into the trial use. So when we talk about stages in the standard setting process, the first one is ideation. You really want to come together, ideally a group of people, but IEEE does not impose that the idea needs to come from a group of people. Even a single person can say that I have an idea to develop a standard, and then it goes through a process. Then you create a proposal, and in the next stage, I will highlight some of these things. When you create a proposal, it's a proposal that you take to the IEEE Standards Association board, the new standards committee, and you say that I have this proposal. I would like this proposal to be accepted, and so that I can form a working group. And once it goes through the process and it gets approved, then you create a working group and you start drafting the standard. Then you come for voting. There are multiple levels of voting. There is a voting that happens within the working group. And once the working group has voted, then it goes to a standards committee. Then it goes to the public comment period also, right? And then you have publication and maintenance. Publication and maintenance is very important. Our standards have a lifespan. Their lifespan is 10 years. So after 10 years, if the working group or the standards committee need to tell the standard is still relevant. If it is not, if they don't have that feedback, we actually move that standard into inactive. But IEEE, given the nature of the beast, right, like a very distributed system, people download our standards in various ways. 10 years after it has been made inactive, I get a call saying that I need a clarification on that standard. Then I look up at the standard, I'm saying, what are you doing with the standard? Like, it has been inactive or it has been superseded, but I do get those queries. So it's very interesting, right? So then we have to nudge them to move to a more recent version or figure out. So when you have an idea, right, so the project approval process takes 2 steps. I said that there is a proposal phase. The proposal phase takes 2 steps. You go to your standards committee. First, you identify your standards committee. Say that, hey, this is the proposal. Put a project authorization request, which is equivalent to an NWIP in the ISO IEC system, right? And then you say that, is there a merit? Then the standards committee, which is made up of experts, they debate on that. And once they approve it, they submit it to the new standards committee within the standards board, right? So the rest of it, I mentioned it. It's a fairly robust process. One of the process that it has is when it goes to balloting at the standards committee level, one of the things we ensure is all the comments have to be addressed before it gets published as a standard. Otherwise, the IEEE Standards Board will not approve that standard at all. Who can, what are the principles? It's the WTO principles we adhere to. It's a direct participation of the individual or the entity. All our policies and procedures of each working group and the standards committee working group are publicly available. One of the things I would like to highlight is we go for broad consensus. It's very specific that we don't say 100% consensus, but because we will never achieve that, right? So we have a, what we call it, a super majority to achieve that consensus. But certain working groups have, that is the basic minimum threshold, but some working groups can adjust that threshold. They have taken it to much larger level. For example, IEEE 802.11, given its impact, they say that the super majority might be about 68%. They say that their response positive should be 92%, right? So they make that threshold much higher for their own working groups. It is a balance. We don't focus so much on whether we have different countries being represented, but what we focus on is whether we have the stakeholders represented. That means, do you have a designer, a manufacturer, a government regulator? Who are the different stakeholders and what are the perspectives they are taking, right? I think that is more important than country-based. We encourage countries to participate because the countries come with unique requirements, and it's better to bake that within the scoping and the development of standards than reflecting on it later. So yeah, so pretty much anybody can participate. It's an open membership, and in an individual standard, you don't need to be a member. One of the things we realized as we developed this process is it's a very bottom-up process. We realized that there is a need for also some kind of a top-down approach, especially with the penetration of mobile technology, cell phones. The society uses technology a lot more. That means that there are people who govern the society, particularly government agencies. They care a lot more about standards, right? So we created a platform where we created a government engagement program on standards, where the entities can become part of the IEEE as an observer, and they can actually provide feedback and observe what is going on in this particular system. And I've listed down few of the work that's happening from India. So we have a national standards adoption program. We have an adoption document both with the Bureau of Indian Standards as well as with the TSDSI, which enables the organizations, these institutions, to adopt standards that are developed within the IEEE. There are quite a few adoptions that have actually happened within the Bureau of Indian Standards. So I will skip that for a minute. So there are quite a few standards that are driven out of India. So when I say driven out of India, please take it very broadly, because standards are not regional, not within the IEEE for sure. What I mean by that is perhaps most of the community is from India, the experts, or the leadership is from India. In fact, recently we published the work on IEEE 1930.1 2022 that got published. This was championed by Professor Abhay Karandikar and Pranav Jha is the chair from IIT Bombay. They championed that work, and going along with that is the work happening on 2061, I think, which is getting very close to getting published. This is very important because in the morning, I think Secretary made a comment about looking at it frugal, everything about frugal. 2061, the code name for 2061 is what we call as frugal 5G, but the official name is the low mobility energy efficient network. 2872 is actually being driven out of CDOT. Sandeep Agarwal is the chair of 2872 standard, which is almost taking the PM Wani architecture and taking other viewpoints and taking it to the next level, right? So the GPS members from India, there are quite a lot of organizations. We have automobile organizations, the standards organizations, people from the power sector, METI, DOT, so you can take a look at it. So they are pretty heavily engaged in our process. We also launched a professional certification along with CDAT for 5G. This happened about a few months back. It was launched by the secretary. It's a joint program for people to take 5G certification. It's an array of programs. We started with wireless networks to begin with. We are working on cyber security, and there are a few other courses that we are looking at. So I did talk about standards and social impact. I'm just going to conclude my slides. There are a lot of resources that are available here for people who want to take, and I'm sure this deck will be distributed to the audience. And with that, I thank the audience for their time and also for the organizers. Thank you.
Thank you, sir, for sharing with us the details of the extensive framework of IEEE Standards Association. In view of time constraints, I request the speakers to conclude their talks in 15 minutes. We also have the pleasure of the gracious company of Sri A.K. Mittal, who is currently the advisor, Network Systems and Technologies at TSDSI. Sri A.K. Mittal began his career in R&D at ITI Limited and later joined the Department of Telecommunications, where he worked in a variety of domains like satellite communication, OFC, microwave, mobile networks, switching systems, network management, licensing, regulation, standards, testing, and certification. He also served as head DEC and represented the Government of India in various bilateral and multilateral international meetings. It's our honor to have you here, sir. May I request you to please deliver your talk? Yes, is it possible to open? Yeah, you try it, sir.
Good afternoon, everyone. So actually, I have been enlightened with lots of information which has been given by my previous speakers. And maybe I have the smallest number of slides, keeping in with the time which we have. So in TSDSI, just to show you the structure that how we are organized and where are the technical works happening. So at TSDSI, we have a general body. We are a membership-driven organization where the individual members cannot participate. It's only the organizations which can participate, and it can be anybody in telecom, and not only in telecom, but the user organizations, because as IEEE also it has been said everywhere in the world, now the user organizations are also participating because we need to meet their requirements to actually create standards. So non-engineers are also now participating in the standards, and we do have members of those verticals coming into TSDSI, joining TSDSI recently. Now, so we have a general body consisting of all members, then the chair, vice chair, and the treasurer of the chair and vice chair that are actually elected people from the governing council. And governing council is a 21 members body, elected members, and 8 audio. Voice louder? Okay, sorry. Is it okay now? Thank you for reminding. Thank you. So, so here, if you see here, there's the governing council with 21 members who are elected out of the general body or the total membership, and 8 are government nominees. And then we have a secretariat headed by a DG. And the technical work happens, if you see on the right side on the top, study groups. There are 2 study groups. One is study group networks, and other is study group services and solutions. So as the name suggests, anything on the telecom network side is in the study group networks, and anything on the services and solutions side is in the study group services and solutions. So I have not detailed their scope of work, as the name itself suggests that what they are actually doing. And these study groups actually meet normally every quarter, once in a quarter, but there is no limitation that when they should meet. And they also have suggest offline meetings and email discussions, and we can have working groups among the study groups. So today, in the study group services and solutions, we have actually 3 working groups also who are handling different areas of work. So this slide is basically giving a overall view of how the standardization life cycle works, normally everywhere. But in a generalization, we will see how it is working for TSDSI. There are 3 actually stages. One is the pre-standards stage, before the standard work starts. The other one is a standards work, which happens. That is the main scope of TSDSI. And third is a post-standardization. So in all the 3 stages, this is, except for the middle one, there is a combination of TSDSI activities and outside world, external world activities. And in the post-standard also, it is TSDSI and external people, and including the members of TSDSI. So we will go to each of them separately. So now in the pre-standards stage, if you see the bigger box on the right side, you will find that these are the activities which happen before a standard comes or a proposal comes to TSDSI for making a standard or doing a study. So what happens in the outside world? There are some white papers being published. There are some studies happening. Research and innovation is happening. Then there are various user forums. There are various associations of, for example, COI, Broadband India Forum, and various other forums where the requirements are generated, or where they have technological inputs from variety of members which they possess. So there is a continuous process of feedbacks which are coming from external forums, and which give rise, where the members of different verticals, they meet, they understand each other, they know what kind of standards first is required to be done, what studies are required to be done, where the world has moved, what people are doing in different domains. So all that is happening outside. And within TSDSI also, we have discussion forums, which we call TIP forums, technology roadmap item proposals, where an idea which is not mature enough to take to standards, so we create discussion forum where non-members also can participate. And they generate a white paper and they create a recommendation. That recommendation is really useful for identifying that where is the gap
in the current standards and what new standards need to be created, or whether further formal technical studies need to be done to more precisely identify the idea, what is to be done. So all that happens, and then we do have a roadmap committee, which is a governing council, is a committee of the governing council, headed by a governing council member, but it can have members from who are not governing council members, and it can invite non-members also to provide advice. It holds regular workshops with the stakeholders from outside TSDSI, ministries and engineering colleges, academia anywhere, and whatever kind of stakeholders, to get ideas that what users want, what different people are doing a research, which are the areas which are of importance, where TSDSI can actually benefit from that feedback and start the standards work, which finally results into a roadmap. So currently we have a roadmap version 2.0, which is on our website, which has identified some items. And then all of this combined, the industry feedback, the external forums, the TSDSI internal work, it all now creates into new idea, which is called a new item proposal, or a NIP, which is a formal document which has come to TSDSI. And how it works, let us go to the next one. So this is the main domain of TSDSI. I will dwell it a little more here. So if you see the bigger box on the right side, standards work, so you saw that the new item proposal has come. So that new item proposal is here. Let me clarify that whatever is coming from that upper box, which we just saw, it is not that only source of a new item proposal, because roadmap creates a guide. Okay, these are the things which the stakeholders want, that standards should be created on that, or a study should be done. But members are free to bring more items or any other item for work, study, or specification work inside the study groups as a NIP, as a new item proposal. And that new item proposal can be for a study, because sometimes as we say, that idea is not mature, we want to understand more, and that study item then creates a technical report. Technical report will then study various aspects, there will be various views, and it will finally recommend whether we stop here, we have done the study, it's not worth, or maybe it requires further study, or it may say, okay, recommend that we go for a further standards work. Then it is up to the members to bring in another NIP to carry out a work for standards. Or the initial proposal itself could be for a work item, means normative work or a standards work, and it is debated in the study group whether it is fit for standards work. If the members agree, then it is taken as a standards work straight away without doing a study. But sometimes members are agreeing that, okay, this can be done, can go straight away for a work item, but then a short study phase is required to refine the idea. So within a work item, there can be a study phase. So you create a technical report within a normative work and then go for a study for a normative work. So these two, so study item leads to report, and then work item reports to a technical specification. Now, technical specification, which is approved by the study group, any of the study groups, is called a draft standard. And that draft standard becomes a TSDSI standard once it is approved by the general body. So once the job is done in the study group, the document is circulated to it's electronic approval from the GBM, general body. We circulate to all members, invite comments, and if there are any comments which are substantial in nature, then they are debated further, clarifications are to be issued, and if something is to be actually referred back, then the standard can really come back to the study group for further work and clarifications. And after that cycle is over, then the general body approval is finally obtained, that okay, this is the one, and then it becomes a TSDSI standard. We publish it on the website, and it remains voluntary. Now, the next stage of standard is that as per our bylaws, the rules and regulations, we have to send any of the standard which we create, we send it to TEC. And TEC has a guide for national standards or adoption of SDO standards, any SDO, and currently it is TSDSI in India, to adopt that as a national standard. They have a guide, they obtain public comments, there is a consultative committee, and TSEC, there is a procedure in TEC, and TEC then adopts them as a national standard. But another important part of this whole process is that when we are creating a work item and creating a standard, then there is a process of declaration of patents or IPRs. So this was being, you would have heard in the plenary session, there was emphasis on the patents declaration. So there is a patent policy or the IPR policy of TSDSI, which every member is bound, and the policy says, okay, you can declare, the members can declare the IPRs at the earliest, whenever they're possible. There is no binding when they should do it, because there are commercial considerations at the back of mind of every organization when they want to declare. But what it does is that it binds the members that they will license the patents which they have to the users of those standards in a non-discriminatory basis or FRAND basis, fair, non-discriminatory, and reasonable terms. So this is what they are bound, that they will license. Of course, if they don't license, the dispute goes to the court. But there is a understanding and a confidence building exercise for the users that members have committed that they will license. The terms and conditions are not in the scope of TSDSI, that what terms and conditions they agree for license and how much time they will take to agree. So this is a matter of law of the country, and courts then finally decide if there are any disputes. One is that, so patent declaration is one part, and whatever patents are declared, we just host it on our website. They remain there, and it's open for public to see what are the patents declared. And in the patents declaration, there are two things. One is that whatever patents a member has, they will license, and another process is that they specify that this is the patent they have, and this applies to that particular section, so and so section of the standard which is applicable. So these two things, these two options are given. Members can choose any one of them. Another part we do in the standards making is that we do contribute to 3GPP, 1M, 2M, and ITU. We are members of 3GPP. We are members of 1M, 2M, and ITU. We are sector member of ITU-T and ITU-R. So we in the study group, when a new item proposal comes, so it can specify that we are going to contribute to a so-and-so item work happening in the ITU. Because ITU, when we take a contribution, it goes as a TSDSI contribution. While in 3GP and 1M, 2M, there are individual members. So TSDSI members who pay further fee for becoming individual members of 3GPP and 1M, 2M, they can directly contribute into 3GPP and 1M, 2M. And some people may like to mature the idea within TSDSI, and thereafter they can take it to 3GPP. So this new item proposals which come, they can result into contributions to ITU and the standards organization like 3GPP and 1M, 2M. And we also then transpose 3GPP and 1M, 2M specifications by virtue of our agreement, partnership agreement with these two organizations. And those transposed specifications also become a standard in the study group. And then we send it to TEC, and then TEC adopts them as national standards. So we have already sent a large number of specifications transposed to TEC from release 13 to 17, for example, for the 3GPP, and for 1M, 2M also release 2 and release 3. So these are under, many of them have become standards of TEC, and some are under consideration in TEC. But then the detailed, how actually the detailed exercise happens inside the study groups. So as you see on the left side of this graphic, the graphic is not in a very fashionable shape, but it is very straightforward. So I can show you I just wanted to show that how within the study group the proposal progresses. So if you see on the left side bottom, a proposal has to be brought by a proponent. For example, company X, they want to bring some proposal. So they have to get support for minimum 3 more members when they bring in the proposal. The idea is that a proposal is not individual driven, but there is more members are there who want to support. So there is a wider spread of this proposal, and it becomes a NIP, and submission, it is submitted on the website of TSDSI on a portal, which is available to the members, and a number is allotted, and it becomes part of the study group meeting documents, because all the submission of documents is all electronic. There is no physical documentation. And when a study group meeting happens, the documents have to be submitted 1 week in advance, at least 1 week in advance of the study group meeting. The dates are declared for the study groups. The study group meeting happens, these proposals come, they are discussed, And one more thing I want to say, that when we say proponent plus 3 members, sometimes the proponent does not have enough idea that who are the people who will be interested in this. So on the floor of the study group, even if the proposal has come without any supporters, after discussions, some members may like to support there itself, and the 1 plus 3 can happen there. If it doesn't happen, then the proposal is noted, and the member is supposed to then work offline and come to the next meeting with a revised proposal with new members to support. And if they want to even revise the scope of the proposal, that also can be done as per the wish of the group of 1 plus 3. But normally many proposals come with 1 plus 10, 1 plus 9. It is not that it's only always 1 plus 3. So some proposals have a big support right from the beginning. Some people gather support during the meetings. Then after the acceptance, it is either becomes a SI, study item, or a work item. So I mentioned about what is study item and work item in the previous slide. And after they are accepted as SIWI, then another WISI number is allotted. This allotment is done by Secretariat. And then after this is done, then in subsequent, there is a time plan. There is a time plan which is to be submitted by the proponents, that how much time they will take, how many meetings they will take to complete the work. So discussions happen, and those discussions happen in every meeting. People bring in contributions, and those contributions are called SWIC, study and work item, study or work item contributions. And after these discussions matures and the report, study group feels, yeah, this is now mature enough to be frozen. It is frozen, and it becomes either a technical report or a technical specification or a draft standard. So just to show you that what kind of thought goes into a NIP and SWIC, I would request the team here, if they can click on the embedded document in the box which is written as NIP. Can they open the Word document here? Somebody here? No, I think there is. Oh, I think there. Yeah, somebody is coming. So, okay. So what I want to say is that in the NIP, it is not that people just write a proposal. There is a format, there is a template which asks them to provide the objectives, the description of the proposal, and the impact what is want to create, and its relationship with any existing standard of TSDSI or existing international standard. And if so, then they have to say that whether they want to modify something, they want to add something, create a new standard. All those things then have to be explained in the objective and the impact part, and also whether it has a link to the roadmap, which has been TSDSI roadmap item, and also how much time it will take. These are the mandatory things they have to fill up, so that the people who are attending the meeting, the study group, knows that how this item is going to progress. And it's very important for all the members to know, who are committing to this work, 1 plus 3 or 1 plus n, whatever number you are supporting, that whether they can devote that much time for this work. Suppose somebody says, I want to complete this work in 4 technical plenary meetings, 4 study group meetings, which is about 1 year. Some members may feel, no, it requires more time, etc. So all that is debated. So either that time which is asked for is either can be reduced or it can be enhanced. So it is up to the study group to decide. The study group is completely autonomous to decide this course of action. And in the SWIC stage, the study or work item contributions, these contributions are actually the documents which actually build the text of the specification or the report. So there 1 plus 3 is not required. Individual members can come alone or with support of other companies or the organizations, member organizations, and submit a contribution. That because at the SI WI stage, the first work is to be done is to decide the table of contents. What is going to be the content of this document? So based on that table of contents, members bring in proposals and say, okay, I want to populate this so-and-so text in this area. So like that, the text gets on getting populated. Members are free to comment. And when the text is stabilized, normally then when it is just going to be released, normally changes are not accepted, and it is frozen as a final document. And here at the stage of what is expected is that before the standard is released, ideally the members should declare their IPRs, but then the IPR policy says that members are free to declare at appropriate time, whatever they feel so. So declarations do come at different points in time. For example, today we have declarations on our website. We have 5G. Many of our members have declared their patents in the 5G in 3GPP. Because as per the policy of 3GPP and 1M, 2M, they don't get the declarations directly. They say that you declare your patents to your parent SDO, parent organization from where you are coming as a member. You declare there. So we have 5G patent declarations with us. We have other declarations also. And out of this process only, we have standards 5GI, many of you would have heard, which is an enhancement over 3GPP 5G standard. Of course, later it was absorbed into release 17 of 3GPP. Then recently we published a standard only this week, which is cloud interoperability and portability standard. Recently, this week only it is finalized and published. Then we have a standard on CPRI front haul. So all these standards have been published, and many more standards on 6G in pipeline. We actually started, just for information of the people here, that we started work on 6G even before the 5G was actually finally frozen by ITU. We started the workshop on 6G in 2020, January, and a study item on 6G use cases and technology trends was started in March 2020. And this report was released in September 22. That means it took about 2 years to create that. Of course, there was COVID in between. It was slightly delayed, but then we released. And based on that, we made contributions to the ITU documents, future technology trends, and ITU framework, the recommendation which was finalized in June. We have our contributions there. So, there's a lot of things which are being done, and we have today 8 work items or study items or work items on 6G in TSDSI. So idea of telling this is that the engineers here, the researchers here, they should know that I am just finishing. Thank you. So this is my last slide almost. So idea is to invite people to come and join TSDSI and become part of this accelerating journey. And CDOT here, they have lots of talented engineers who are doing so much of technical work and giving so much technical outputs. So I invite them to join TSDSI. This is post standards. I will quickly go through. This is evangelization of a standard. Whatever standards we create, the adoption takes time. It is not that the next day people adopt. So you have to go to the market, create workshops, invite people, go to the industry. So this is a job of the SDO, but more on the people who actually are party to this standard, who created those standards, that they also participate in reaching to the people so that it becomes a standard. Then maintenance of a standard is another part, that once it is implemented, there will be feedbacks. There are errors or need enhancements, and etc. So it's a standards maintenance. So all that feedback comes from the post standards activity, and it comes back into the study groups, and then we can modify that. I think this is the last one. Thank you very much.
Thank you, sir, for briefing us about the activities and initiatives undertaken by TSDSI in creating the indigenous standardization ecosystem. I once again request all the speakers to conclude their talks in 15 minutes. Our next speaker in this session is Dr. Sendil Kumar, Director, Standards and Spectrum, Ericsson. He is currently responsible for leading standardization and spectrum activities in international standardization bodies like ITUR and APT, and regional standardization bodies like TEC, BIS, TSDSI, and other industry bodies like the GSMA, COAI, and 5G-IF. He represents Ericsson in various committees set up by the Department of Telecommunications, including the 6G Task Force and national study groups. Prior to Ericsson, he was associated with various R&D organizations contributing to 3GPP RAN standardization. We are pleased to have you here, sir. May I request you to please deliver your talk.
Thank you. You could have saved a few seconds between now and the lunchtime. And it's a tough job, and I'll save some time for Arindam also, so that we can make it to lunch. Um, I'd like to thank TEC especially for the SCP portal that they have launched. It has been a very good initiative, and we have been doing the work even without the portal, and we have been looking forward for the portal for having a more formal documents and everything available. And I'm also delighted to share that I have my mentor here who brought me into earlier 3GPP standards activity during my PhD at IIT Madras. Professor Bhaskara Murthy is here, and also Professor David. He was also from Ericsson. And my day one from my research activity has been into standards related activities. And being in Ericsson, I learned there is a lot of so many things else that happens before we get into the research and the 3GPP contributions. I'd like to share some learnings that within Ericsson, what I learned, and what we see is how do you contribute to 3GPP. And as of now, from till now, we have been only learning or hearing about ITU, 3GPP, and IEEE. There are so many other factors which actually influence how 3GPP standards are developed. I would like to quickly walk through some of them, and I'll try to skip some slides which you can find in public domain. Can you? Okay. Thanks. And I think as a researcher, I think there was always a common question: why do we really need to standardize? And then when we say standard, we look at Wi-Fi standard or 3GPP standard, and then there are other standards which are in the form of saying open code available, for example, an image format. It's not a standards body, but then the moment it is publicly available, we call it, oh, there is a standard way of using it. For example, Microsoft Windows. You write an API, a DLL file, and then it's a proprietary standard. You just interface to use these applications within the OS. So there are multiple ways to call, yes, this is a standard or not. And as of here, I think from a 3GPP perspective, when we say standardize, it's all about saying, can an Ericsson radio talk to an Apple phone, which has a Qualcomm chipset? Or it could be any other companies also. So it's all about making them interoperable between network and different entities in the ecosystem. And then there's one important part which we always miss is we don't standardize every component in 3GPP because we need to have some room where we could also innovate when we do the standardization. For example, if we have a radio RAN product, we standardize the main interfaces or protocols and how they behave. But what to react and how to behave is something left up to implementation, which helps to allow innovations in different products. For example, multiple vendors who are building radios need to differentiate their product capabilities and efficiencies. Similarly, from a device perspective, I think there are reports which talks about saying this particular phone does good in 5G conditions, or when they do handover between a 5G to 4G. There are a lot of implementation aspects within the chipset which helps to differentiate between different vendors. I think that is key to allow room for innovation when we write the 3GPP standards. Like I said, standards could be in different ways. You have a 3GPP spec available in an FTP portal, much open than any other standards body. Then there are standards where you implement and make the source available. Or there could be API which just specifies, for example, government's data portal, where you can have access of government's data on different statistics that is available. Then it's an open API available. That's another way of interacting with the data. And Ericsson has been there since long time, right from the 2G to 3G timeframe, where it's always about cooperating with the right stakeholders and then trying to bring that what is the minimum thing that we need to standardize so that the device vendors can implement as flexible as possible, just to ensure that it can talk to any radio equipment. And one other thing which I learned from being from an academic side when we did standards related activity, and today what we see from 5G and 6G, is what is it that is influencing the 3GPP development process. From 3GPP started with taking 2G and then evolving it to support core and the radio functionalities. But when we started moving into 4G, the focus was, is the 4G core ready to run OTT applications or a video streaming application? So we need to be prepared whether the capabilities are okay to run that kind of data applications or internet browsing. But then with 5G, what we realized is there are other stakeholders other than the normal phone who want to use the 3GPP connectivity as such. So it was industrial automations, factories. So the important thing as a vendor would be to talk to those companies and say, what is it that you are using today in wire? what protocols are you using? For example, 3GPP also looks at, can I run a IEEE's TSN network protocol in 3GPP connection wireless network? So there was a lot of interaction that happens with these different entities. That's what you would see around the slide. We'll look at 2012. Even before 2012 is where Ericsson started its internal activity talking about what are those technology components we need to leverage by the time we have a 3GPP spec for 5G. So there's a long time frame that is needed. And not all of the things are in a public domain. What is a study report? For example, in 3GPP, when I did my PhD in IIT Madras, we started looking into what are the current study items going on in 3GPP. Can we do something more? So even before 3GPP talks about a study item, there's a lot of thing happens background before that comes to a 3GPP platform. I think those are some activities I think we need to get involved before we start contributing to 3GPP and make a big impact in the standards process. So I'll skip this. From Ericsson view, I think this is a slide which you would have not seen outside. What we see is the 3GPP is more focused in the access layer and the management part of it, where the operator exposes to say, how do we do billing? How do we access to other counting of the data and everything? But then what we see is from the 5G timeframe, there are so many other standards forum which actually influences the way 3GPP specs are written. For example, we are active in the Kronos organization, which writes specifications for XR, VR, or if you want to do visual processing on it. That basically says as today, if a VR headset which is connected to the 5G goes to a core network in an operator's network, and that operator's endpoint goes to a rendering application in some other cloud, how do I ensure that my core network and my radio are optimizing its connectivity to render that kind of a data pipe? So we are actively involved in knowing what's happening there. We contribute to those standards also. And similarly, like what I said, 5G ACIA and 5G AA, they both are automatic and the manufacturing industry. Then similarly, we have IETF. I think someone earlier spoke about IETF. IETF writes a lot of information on codecs, and these codecs are something what 3GPP layer need to run on that. So it is important to see that are our wireless protocols written to optimize that kind of payload. Yes, this is how the relations of these forums are. I think GCF, Mr. A.K. Mittal knows that there is one forum where it talks about how to get certified the devices. 3GPP writes a spec, but then the device, when it goes into market, the operators require certain key essential requirements. For example, Indian operators may say that I would want devices to support these bands. Unless this is not there, I am not allowing this device to enter into my network. Similarly, North American operators, they have certain requirements. So these certification bodies help ensure that the devices which are using 3GPP, but certain features are definitely included in the devices before it gets into a commercial network. So we need to know what is this operators asking for. What are the requirements coming from the market area? For example, if you would see on the right side, there are 4G Americas, 5G Americas, GCF, right? These bodies actually say, this is the requirement that we're looking 4 years from now or 5 years from now. That actually influences saying from company like Ericsson, is it what operators are looking for after 2 years or 3 years down the lane? If yes, then we need to see that can the today's product which is there in a network, can it run these new applications? So based on that, we need to see how much of changes in the 3GPP spec we need to go in the next release, or it should be prioritized to next releases. So it is important to drive our strategy based on what is the market need. And there's one more organization which 3GPP works very closely is its timing alignment with ITU. Because ITU is the one, as 3GPP is a partnership project, but then the recommendation or an official recognition to a 3GPP standard comes from ITU's recommendation. And then when 3GPP starts writing its releases, it needs to know that what is the release which can meet the requirements of ITU set IMT specification. So most of the time, 3GPP works in parallel to ITU. For example, we have the 6G vision. We now look into saying what is it that requirement that ITU is going to set for 6G. Then from a 3GPP timeline, we need to see, can we use release 17? What features can be enhanced to address those? If not, what are new technology challenges we need to address? For example, if you're looking at 7 to 15 gigahertz as a new frequency where we want 6G to operate, then we look at saying, are there PAs available today which can have that same efficiency? The research that goes into that need not to be part of 3GPP, but then we need to still look into that research activity going within the organization. There are 3 components that goes into 3GPP standards development. One, the protocol, where it talks about between two interfaces, for example, the device and the network, what are those interfaces and what protocols goes between those interfaces. And then the behavior part, which talks about saying when the UE is seeing two different power levels between two networks, should it initiate handover or not? Those behaviors are loosely defined in 3GPP. But then what is implemented or not, how it reacts is up to the device and the network side. Most of these behavior are very strictly defined for devices, but loosely for the network sides. One of the most strictly implemented specs are for the RAN 4 specifications, which is for the radio transmission. Because radio, when it is put into air, I think TEC ensures that unless you are adhering to those radio requirements, which is coming from ITOR, you cannot transmit into those frequency bands. So radio requirements from the RF side is very strictly standardized. All devices and radio equipment need to adhere to that one. This is an example, like I said, there is a balance needed between standardization and innovation to be allowed. What if everything is already standardized? Then everyone who implements that will have the same performance as an output. So 3GPP ensures that there is enough room for innovation. This is an example where we see that to allow interoperability, you have random access as a procedure. When the device turns on, it connects to the network, and then it does handover between two cells. But then what vendor implements can deliver into two different results. For example, vendor A can have a different scheduling algorithm, which can have different speed and latency combinations. Similarly, the same 3GPP spec is used for writing an FWA radio. So it is up to the vendor how he implements the scheduling to ensure that there is a fair, consistent throughput available. So it gives enough room for innovation. So when you go to 3GPP and contribute, we also need to say, is this specification or is really need to be specified in 3GPP or not? Can I make a product without getting into 3GPP? If yes, it allows you to distinguish your products compared to competitors. So it is important to know how much is the minimal requirement that you want to take into 3GPP and standardize it. This is giving an example. For example, if in 2021, there were more than 95,000 contributions that went into 3GPP, out of which only 26,000 got approved. So you can see that the amount of contribution you need to take it to 3GPP is not like I take one contribution, it gets approved, and my work is done. You need to put a lot of efforts to see the status is going in. Even from Ericsson's perspective, what we see is only 22% of our contribution got approved in a 2021 contribution. So there's a lot of effort, more contributions need to go. We need to have a high target of number of contributions you take it to 3GPP. There are so many players. We have operators, network manufacturers, chipset manufacturers, and terminal vendors. All of them need to agree what is it that they want to put into the chipset and the hardware. So what you don't see in a timeline typically is you have a 3GPP timeline, ITU timeline, but then what is it that internal product strategy timeline is? Do you have a product which you're going to launch in 2 years? And if 3GPP releases a new release in 15, 16, 17 going on every 15 months, is your current product ready to upgrade to add those features into the product? If not, then you'll have to see that how closely or what is the incremental features that you want to add. So that is very important when you strategize your contributions to 3GPP. I'll not get into these details. This is known. And yes, I think Mr. A.K. Mittal just mentioned that when you participate in 3GPP, you need to share the IPI declaration. Yeah. Yes. I'll take last 1 minute to say how we conclude the activities. Usually it starts with a study item, work item, and then you talk about what features you would like to drive in 3GPP. And then based on that, you see whether it goes into current release or it's a new release. Based on that, you need to bring contributions to those meetings. I'll skip this. Maybe the slides will be available later, so or we can catch over the lunch break. What's important is this. 3GPP meetings are busy scheduled meetings. So you cannot have one person who is saying 20% of the time the guy is working on standards. That's not how you can have it. For example, Ericsson put 17% of its revenue turnover into research efforts, right? So if an organization wants to get into 3GPP, it's a serious business. You need to follow throughout the year. We cannot do it over one or two meetings you attend and then we give up. So it is important to have a consistent contribution in 3GPP and presence. And then there are a lot of things that happens outside 3GPP, talking to the key stakeholders. If you have a change that coming which goes into radio side, you need to see whether the device vendors are accepting or not, because they are the one who needs to accept most of the implementation. I'll skip this. Like other work groups, it's again based on consensus. There is no voting. Worst case, it ever goes into voting. I had few examples, but how to prepare a contribution, but I'll skip it. I'll give more time to, yes. So if you want to contribute to 3GPP, I think you also need to follow what market requirements are coming from other organization bodies. I think it is serious to participate in those groups also. Thanks.
Thank you, sir, for sharing your perspectives towards contribution to 3GPP standards and your experience at Ericsson. I once again request the speakers to please adhere to the time limits. We are also joined by Sri Arindam Bhattacharya, who is a group leader in CDOT and leading the activities of IoT M2M communication, including National Trust Center and other security projects. He has 34 years of industry experience in varied fields of computing and communications. Currently, he holds the vice chair position of Marcom Group of 1M2M. He has been a key contributor to various policy and roadmap documents of TOT on M2M communication. He also leads several working groups and contributed to various technical reports in TEC. We are pleased to have you here, sir. May I request you to please deliver your talk?
Thanks, Aman, for the kind introduction. Dignitaries on and off the dais, ladies and gentlemen, and dear friends. It's a very arduous task, actually, to be the last speaker just before the lunch. So I will try to do my best. I will skip majority of the slides because I wanted people to get a view on what 1M2M is about. Beyond what the procedures of standardization are. Because unlike other standardizing bodies, 1M2M is very focused on one particular aspect, that is IoT. So it creates standards for IoT. M2M was the phrase that was more popular earlier. So the M2M and 1M2M, so that one standard for M2M was coined. So IoT is a natural progression to that. And we all know IoT about. So moving on, there's a small video that we created as part of our Marcom exercise. Can we have the, yeah, thank you.
The world's changing fast. The number of connected devices is rapidly outstripping the world's mobile phone population. This wave of hyperconnectivity is transforming the way we live and work. Welcome to the Internet of Things. Imagine a system that makes your trips faster, safer, and more predictable, fusing real-time information from traffic systems, connected cars, environmental sensors, and many other sources. Or imagine a factory where real-time data from thousands of machines helps business owners monitor productivity, predict problems, and interact with suppliers to optimize output and meet customer demand. It's a new world where billions of devices can communicate with other devices, systems, and applications. Making it happen depends on interoperable systems, allowing designers and developers to combine new technologies with legacy assets seamlessly and reliably. And that's why we need open standards for the Internet of Things, to make innovation more accessible and cost-effective, and turn ideas into scalable solutions that everyone can benefit from. This is the mission that inspires 1M2M. We are the global community of leading standards development organizations, working with industry experts and researchers to shape our hyper-connected future. At 1M2M, we're developing IoT standards to enable interoperable, secure, and simple to deploy services for the IoT ecosystem. Our internationally recognized specifications are backed by interoperability testing and global certification schemes. One M2M standards work across different industry sectors, breaking down boundaries and enabling exciting new possibilities. They're continuously evolving, meeting industry needs and supporting sustainable investment in the Internet of Things. There's no charge to access all our technical specifications and developer resources. So join us and help build a world of secure, interoperable, connected products and services that make a difference today and tomorrow.
So, so this is what which makes 1M2M so unique, is that it's not one particular SDO which is focused on this. Rather, 8 SDOs who are joining their heads and hands together to create the specifications. The specifications are open, as you saw in the previous video, that anybody can access those specifications and can develop products around it. And what is standardized are the mechanisms, the interfaces, those are standardized. So like 3GPP, here also the scope of innovation is already there. There's room for that. And people through their implementations create solutions which are innovative, which are different from each other. So one particular organization's offering the similar product may be different in performance and other parameters. So ATIS, TIA, ETSI, TSDSI, TTA, ARIB, TTC, these are all different SDOs across the globe who are actually contributing through the partners, through their members. So there are 200 plus and counting, so who are contributing to that. CDOT is one of them, who are together with TSDSI are contributing immensely into the specifications. So this was initiated by ETSI, and then it was handed over to all the other SDOs together. ETSI is still a very, big contributor to the specifications, and along with their members. So these are the key event timelines, as you can see. So release 4 is ready and ready to be released, and the work is going on release 5. So it has matured from 2012, and we are standing on 2023. And the release 5 initial plan is at the end of 2023, and it will be rolled out soon. So just to give a brief about 1M2M, what was shown in the video. So the concept is to break the silos. Unlike the other proprietary vertical implementations, the concept is about a common service layer to create a service layer, and the whole set of specification is focused around creating the rule sets and the features for the common service layer. So I will skip all these slides. Maybe. So these are the main ingredients of the common service layer. So these are the functional module, or we call common service functions, which make it the common service entity, and all the specifications are mostly oriented towards them, along with the feature sets they are there. These are the technical details of that. I will skip. So this is how the releases are progressing. So we are on release 4, and very soon this will be launched. We are slightly delayed because of COVID, and we will be moving towards that. Release 5 in the offering. So these are the ways that So the mechanism. So our contribution, CDOT, had been invested into this in a big way, and CDOT takes chair positions, though there are many. Now in 1M2M, it's fairly straightforward mechanism. All the domains, because IoT is about various use cases and domains, so requirements from various use cases are gathered together, and they are put in a specification document, WS0002, and those requirements are given to create technical reports and technical specifications. Those technical specifications actually are put to implementation, and those implementations are tested in interoperability testing and conformance testing, organized by the SDOs one by one. And those interoperability testings actually ensure that one organization's product interoperates with the other organization's offering. So thereby ensuring interoperability, which is a key ask for any IoT ecosystem. So once this is done, there's a certification body, as was mentioned, GCF. GCF is the body which provides certification for 1M2M implementations, and the implementations are certified for their conformance to 1M2M standards. The structure is, so these are our contributions. So we have around 450 plus contributions in this. So the structure of 1M2M is also fairly simple, much simpler than the other SDOs, because it relies heavily on the individual SDOs as to how the work program will happen. So there is a steering committee at the very top. That steering committee is kind of takes care for finance, it takes care for industry liaison, it takes care for the legal aspects, marketing methods, and other procedures. And that steering committee also overlooks at the technical plenary. That technical plenary actually controls the work program, the coordination groups, and the methods of the work. So under that technical plenary, it's a very small and very lean structure. So there are only three different verticals. One is requirement and domain model, because in IoT, the domain models are important. So it creates that group. So gathers requirements, so gathering requirement and freezing onto the domain models is the work of RDM. Then specifications and security, SDS is another group which looks after the security and other specifications. And there is a testing and vertical. Now, all these three verticals create work programs, and those work programs and work items are worked upon. People contribute to those work programs through the work items that they propose, similar to what has already been told by Mittalji, that people contribute and bring out information with regards to what are the requirements in different domains. They are discussed, and then contributions are given in the form of technical reports, and they are deliberated upon in technical plenaries. TPs are held. So those TPs are where all the members, organizations, they join their heads together to discuss. So these are physical meetings. I mean, of late, we have been talking about the global presence and remote access also. So we have been having the technical plenaries online as well. So the online technical plenaries and physical meetings actually give shape to the specifications that are formed, and the contributions, they come in the form of change requests for any specification that are discussed. Those change requests are either agreed, noted, or rejected. If they are noted, they will be deliberated upon at a later stage. If it is agreed, that goes into the specifications. Now there are 27 technical specifications and around 17 technical reports in the release 4, and they're counting. So it's not necessary that all technical specifications would continue to be there in the subsequent release. Certain technical specifications have been made obsolete because those specifications are no longer relevant in the subsequent releases. So, but majority of them stays, and majority of the new work items, they come in to form the specifications. So you can get more details about 1M2M and following the links. So because of paucity of time, I'm not getting into the details part of it. So here I close. I hope I could give you a good account for this. Thank you very much.
Thank you, sir, for giving us insights into the need of having open standards like 1M2M for accelerating the development and deployment of all-encompassing solutions. We thank our esteemed speakers for this insightful session. May I now request Shri Piyush Chetia, DDG TEC, to formally present a token of thanks and gratitude to the esteemed speakers. Shri R. Mittar, Advisor and Telecommunication Engineering Center, TEC, Government of India. So you're also the speaker in the session. So we have the one for you. Shri Shrikant Chandrasekharan, Global Practice Lead, Foundational Technologies, IEEE Standards Association. We thank you, sir. Shri A.K. Mittal, Advisor Network Systems and Technologies, TSTSI. We thank you, sir. Dr. Sendil Kumar, Director Standards and Spectrum, Ericsson. Shri Arindam Bhattacharya, Group Leader, Center for Development of Telematics, CDOT. I request all the speakers to come forward for the group photo. Ladies and gentlemen, we'll now have a very quick lunch break. I request you all to please reassemble here at 2:45 p.m. for the next session. Our coordinators will guide you towards the designated areas for lunch. I request all the delegates to please wear their badges. how to convert a patent into a standards essential patent. May I request the distinguished speakers of this session to please take their respective seats on the dais. We have with us Professor Bhaskar Ramamurthy from IIT Madras, Professor Kiran Kuchi from IIT Hyderabad, Shri Gaurav Khandelwal, co-founder Intricate Research, Shri Avinash Agrawal, DDG TEC. We also have Shri Vishnu Ram, independent expert TSTSI, who is connected with us virtually. Our first speaker in this session is Professor Bhaskar Ramamurthy from IIT Madras. Professor Bhaskar Ramamurthy is a BTech in Electronics from IIT Madras and MS and PhD in Electrical Engineering from the University of California at Santa Barbara. He's also worked at AT&T Bell Labs. He heads the Center of Excellence in Wireless Technology at IIT Madras. He's also a holder of several patents related to 4G and 5G technologies and was the national coordinator for the project to build an end-to-end 5G testbed. He has also served as the chairperson of TSTSI. It's our pleasure to have you here, sir. May I request you to please deliver your talk?
Good afternoon. This is post-lunch session. Even I'm feeling sleepy. So, actually, Kiran and I will probably have fair, we are telling the story from the same storyboard. So, there'll probably be some overlap, which is good in a way because we'll have a different way of conveying rather complex activity. Since the time is limited, we'll also be stressing on different parts of it. So I'm hoping that between the two of us, we'll give the flavor of what has to be done. So both of us have adopted the same strategy without planning it. We've just taken, each of us is taking one case study and using that as an example to give a picture of what has to be done. So just briefly, I want to say that this business of working on research, doing research that is oriented towards standards contributions was entirely new, I would say, in the country, pretty much. And in 2005, as a result of a report of a task force headed by the late veteran F.C. Kohli, METI set up this Center of Excellence in Wireless Technology. They approached various institutions, including IIT Madras, and it was set up at IIT Madras. And the focus of this, it was set up as a autonomous society because they wanted to be sure that it doesn't become another academic research institution, which they were familiar with because METI supports that kind of research quite a bit. And so it was set up with the task of doing standards-oriented research, contributing to standards and so on. And to work with industry to the extent possible, because in a mature state in any country, this is done primarily by industry with collaboration with academia. Here it's inverted model because it was not industry was not in a position to do this at that time. But the idea was, the charter was that should be the end goal. And it's very clear that this is very different from the kind of academic research projects that METI itself funds on a regular basis, which whose primary output is high quality academic publications. And this effort has had sustained support from METI from 2005 onwards. And I would say till in the first 10 to 12 years of this effort, there was no sort of understanding of the importance of this kind of work and building capacity for this kind of work in the country. So in that sense, that task force and what followed from the task force report is fairly far-sighted. But of course, when we agreed to do this, my first reaction is we didn't agree to do this because I also told them that I don't know how to do this. I've not done this before. But then nobody was there. Nobody knew how to do this. So we said, we have to start learning. So we learned from former students who are doing this kind of research elsewhere. So that is just what we call in Hindi giving gyan. No? Called my students and said, tell me what you do. So some things we were told. But also by some early employees, one of whom was Kiran. So Kiran had done this kind of standards-oriented research in his previous employment. He was moving back to India. So I managed to get him to join CIVIT. And along with some others, we learned how to do this. In wireless standardization is primarily done in 3GPP, and except of course Wi-Fi has been done in IEEE. And this is carried out by a fairly cozy club, meaning a group of people who have a lot of understanding of how to work together and what's done and what's not done and so on. And it's not easy to penetrate this group, not easy to get acceptance. So that itself, how to do that, the human aspects, the political aspects, all that also takes a lot of learning experience. I don't want to get into that. This is not the focus of this talk. We just wanted to give you that brief thing so that, there is a lot more to, even if you figure out how to do the rest, there's a lot more to it. But this formation of TSDSI and everything has really made the ecosystem available now to get into this in a big way by almost anybody in the country. So I've taken one case study, which is dates back from 2017-18. And this deals with the definition of what's called the NB-IoT physical random access channel. So this is a channel that the phone user or the UE user equipment device uses on the uplink if it has to communicate to the base station, if it has to initiate communication to the base station. So you have to use a random access because you're communicating at random. You're not being scheduled by the base station. So you have to use what's called a random access channel. This refers to the physical part of the channel, the radio part of the channel, and for NB-IoT, right? That's what the acronym is. And for TDD bands, this is, by the time this came up, for FDD, this has already been standardized. Okay. So there was a demand from operators to make NB-IoT available in TDD bands also. And so now you cannot, even if you have a great idea for doing this in TDD bands, if nobody is willing to take it up as a consensus, there's no point pursuing it. Okay. So either you have to latch on to a topic that everybody wants to do, or you have to lobby and get this topic included in the next release as a study item. You have to lobby with operators, you have to convince people that this is important. So either one way or the other, it has to become a study item. And then in this case, since it is not an ab initio or new thing, it is sort of an extension of something which exists in FDD to TDD. So obvious that whatever you do, whatever you suggest has to be maximally overlapping with what's done in FDD, because then the implementation in the UE becomes simple. Otherwise, people will oppose it. And not only that, the SCP owners in the FDD case will also oppose it, because this TDD version will replace their patterns. So again, I'm not expecting you to go into the details here, but just want to tell you that there is the method is basically what is shown on the y-axis there are carriers, are tones. So some 6 symbols, including the cyclic prefix, 5 symbols and the cyclic prefix are transmitted on one tone for some time. Then it goes to another tone, then it goes to a third tone, then it goes to a fourth tone. These tones are in some pseudo-random fashion, and this is called one repetition. The same set of 5 symbols in CP are transmitted 4 times. And then there's a second repetition, okay? This improves the coverage because you can average signal much more. And again, it's in a pseudo-random fashion. So this is what the FDD definition looks like. So whatever you suggest as a new idea, whatever you patent must somehow be maximally overlapping with this and yet address the differences that you have to have in order to fit it to the TDD case. So the problem, if you want to take these ideas and extend to the TDD case, was that the entire set of 4 symbol groups that were transmitted in one repetition will not fit into the available uplink slots. So the uplink slots are already defined in TDD. You can't change that now. It won't fit there. Okay. For any of the configurations, right? So that is the problem. So that's an opportunity for coming up with a solution. So the obvious solution is to break up that preamble of 4 repetitions into 2 two mini preambles. Okay. And if the method by which you suggest it should be done is adopted, then you get a standard essential patent if you have patented your idea. And the second thing in the TDD cases, after the UE transmits, the uplink, the downlink will occur, and there is a flight time for the symbols from what you transmit to reach the base station. If you don't take the flight time into account, the downlink will start transmitting before your symbols reach, and the base station will not be able to receive your uplink PRACH transmission. So you have to put a guard period. You have to go silent a little earlier so that you finish transmission before the base station transmits to the downlink. So this also is not there in the FDD case. So this is an opportunity for you to put in your proposal. So these are the potential for patents. So I'm sitting somewhere in your research lab, you have to recognize this early. Okay. After you realize that they are going to take this up. Okay. And you have to file a provisional patent invention report, right? You can do this in India itself. This will establish your precedents. It will give 12 months for you to file the patent after that. And if you make a PCT filing, which is under the Global Patent Cooperation Treaty, you get additional 18 months protection. So something like 31 months of time you get to complete filing your final patent after you do your provisional with protection on your invention date. This is the timeline also in which the standardization will occur. So this is a very important thing to understand. In this case, the provisional was filed in March 2017 with just this description, what I just told you. I don't want to read it here. Okay. It just said there are two, just like in the FDD case, there are two repetitions, and each repetition is broken up into two mini preambles. Actually, it didn't talk about repetitions, I think, just said each is just broken up into two, and then there are multiple symbol groups followed by a guard period. So this guard period idea was also introduced, and a picture was added, because at the time when you filed the provisional, this is all we knew. So some key ideas you put in there and establish your precedence. Okay. You don't know how many symbols and all those things. Okay. Sorry. Yeah. The complete patent filing was done on 28 March 2018, almost a year later. And in between, something's happened. I'll come to that. And a document containing the detailed explanation and set of claims establishing the novel features, etc., has to be filed along with this. This had 28 claims. So by this time, you added up all the things. And we filed, in this case, both in India and the US. So some patents we file only in India, some patents we file in both India and US. Why US? Because for one thing, the cost of patent filing and prosecution is not very expensive in the US compared to, say, Europe. Secondly, US actually processes patent applications quite fast. And India was very slow. In fact, our patents we filed in 2008 and 9 got approved only in 2 years back. But it's speeded up now considerably. So when it was very slow, this was actually, you used to get the US patents much earlier. Now, even now it happens a little earlier, but not much earlier. And usually once the US has gone through the process, and you've cleaned up the patent, the Indian patent also gets approved. We have seen quite easily. We usually file in the US patent, so there is an additional cost. So we file it only when we feel they are SEP candidates. So there are many claims. There's no time to go through all this. Just want to give you a feel for the language and so on. So you have to write it in the appropriate language. So you have to have training. And if we think that there'll be wonderful people outside in the legal firms, IP firms who know how to do all this, they will say they know how to do all this. But the fact remains is everybody in India is learning. So you will not get completely satisfactory support from the legal firm whom you employ. They also have relatively inexperienced people, and you have to be ready to get into it, learn everything, work with them. So you have to. In this case, you can see that we already extended the idea that there could be multiple symbol groups. We don't want to say there'll be two, because you don't know what will happen in the standards body. So plurality of symbol groups, right? And so on. So you have to have language like that. And just wanted to show you that in the standards body, various meetings took place. I'll give you the dates. This is the text that is taken right out of the standard specification, which occurred, of course, in 2018, right? And if you go through the analysis of this text, it will not be that your wording will come there. It's not possible, right? But if you analyze this text, dividing the preamble into plurality of symbol groups is interpreted from the above text, okay, from this specification text, because that is there in that. It divides into plurality of symbol groups. It's never one symbol group. And the preamble is divided into two, can be interpreted by the fact that this P by G is always 2 in this table. So that P by G is actually determines the number of divisions of the preamble. And so the fact that it is 2 can be established, and that's exactly what we have in our claim. So you have to make sure that your claims are matching what is getting into the standard as the process goes on in the standardization. I'll come to that. Similarly, the guard period. Remember, these are the two main ideas, right? The breaking up of the preamble into 2 mini preambles and the guard period. So the guard period again is not directly mentioned. It has to be calculated in the standard specification. If you calculate them, you get a guard period in all cases. They have many options, right? In all cases, you get a guard period. And it is added to the, and it's very evident that it's added to both the symbol groups, right? So that is exactly what we have in our claims. So you have to make sure that your claims are protected in the way the standard is going, or the standard is gone in a particular way, you have to go and amend your claims. And I'll talk about that also. So I think there are many such things. I don't want to go into this. So like this, you have to keep checking in every, as the meetings go on in the standards body, what's agreed on. And Kiran will give you better examples of this in terms of the actual, in 3GPP, how it occurs. There are something called chairman's notes. There's something called way forward. These are all hard-coded documents which are released at the end of every meeting. Those have to capture, have to match what you are putting in your claims, or you have to keep modifying your claims to match that. Okay, so there's frequency hopping, just like in the FDD case, that's also defined. Okay, so, and that's there in our claim, and so on and so forth. I think I will skip this CP and everything. Okay. Also, you can infer from the specification that only one CP duration is defined, and therefore it is the same equal CP across all symbol groups. But when we filed the patent, we didn't know whether that will happen. So we filed for the possibility that the CP will be different for the symbol groups. Okay, but we also said they could be the same, so that's covered. You have to be so you have to be very, very cagey about all this, because if you put it as one and the other gets decided, you are finished. Okay. In that sense, this research is very different from academic research. Academic research itself, I keep saying nowadays, is 1 degree of separation from Saraswati, because we are all chasing H index, we are all chasing awards, we are all chasing tenure. But this is 2 degrees of separation from Saraswati. Okay, so but you have to learn all this. Okay. Okay, I think just want to tell you that a lot of claims, and you have to do this. There's a lot of homework back. Meetings occur every 2 months. In between meetings, you have to track all the email threads. You have to keep joining all the calls, and you have to keep doing all this homework. Okay. So we have to track the agreements arrived at in the 3GPP meetings over 12 months roughly. That's what each study item takes, and monitor the claim infringements. That means how much those agreements infringe our claims. Because in more infringements, the better it is, right? That means our claims are important. In this case, this happened over 3 meetings. Those 3 meetings, exact meeting numbers and dates are specified. And the specification got frozen in June 2018. That is why we filed the May, patent filing around the same period. Of course, sometimes if these go longer, you have to still make your filing and then file amendments. In this case, we didn't have to file initial amendments to match the 3GPP process, way forward, because we were able to file the full patent filing after this was finished. But sometimes you have to file a little earlier, and then you have to amend the filings. But we also file amendments for other reasons. I'll come to that later. That happened in this case. But sometimes you have to file amendments just to match the way forward that's happening in the standards body. So after this, now the issue comes that you have filed a patent, but like any other patent, it may have overlap with prior art, patents that have already been granted, or published documents. The patent office examiners will look into this issue, and they will raise what is called office action. So they will send you and this, the US patent office does it very well. They have done this for millions of patents, and they're very well equipped to do this. So that it helps clean up the patent a lot if you file in the US jurisdiction. So they said in the first office action that, it appears that one of your primary contributions is the presence of this guard period in every preamble, and you have put it as a dependent claim, move it into the main claim. So they're also very helpful. They also try to improve your patent. So we did that. The second office action, they actually came with what they felt were conflicts with existing prior art. They said in prior art 1, something is there which is similar to yours, and prior art 3, there is something else. And so you have to go through email exchanges, documents, and so on, and tell them why it is not so, etc. And then they'll even suggest that you make some changes in your claims to capture what you're saying, and you do those. Okay, you make those amendments. Then they came back. This is in 2020, 2 years later, and said, no, we think that if you combine prior art 1 and 3, we think it is overlapping. Okay, and now it needed a phone call, an actual presentation to convince the examiner that it's not so. Okay, and again some amendments were filed to capture this, why it's not so. So in some, they're not, while it's a somewhat of a process where it's you can say oppositional, it's also a process in which you can get helped to improve your patent, provided you do have something that's novel. Okay, and so the main claim, the independent claims were all modified as a result of these office actions. And finally, the patent was filed and the patent was granted. Now, based on those analysis, we feel that it's an SEP. Okay, now there is no office that will declare that yes, this is an SEP and this is not an SEP. Okay, this is like, I go around telling people I'm great. Right? That's so. So the only way is to test it by telling anybody who implements the standard that you have to license this patent from me. At that point, they can challenge, saying, I don't believe that this patent is essential. And you have to be ready for another legal battle if required. Normally, if you are an established player and have lots of patents, etc., people settle all of this outside, But if you're a new player on the block, there may be an attempt to take you to court to see whether you can survive that and push you out of the play. That also can happen. Okay, so it's not, the job is not done even if you think you have a good SEP. I think there is an issue of size, there is an issue of numbers, there is an issue of ability to prosecute. Okay, so sorry, in summary, the ideation in this, compared to, of course, some of the other patents will require simulations to be done. It may involve performance of the RF link, and then you have simulation results to use in the standards body to convince others that you have something better and so on. I didn't take one of those kind of patents because it's even harder to explain in 15 minutes, but some of it may involve that. The ideation in any case, in many of these cases, may take only 1 day or 1 hour. But the work that follows that will take 3 years. Okay? You have to have patient and persistent attempts to incorporate your text, what you want, into the and your ideas into the standard. So that whole process, you can't skip meetings. You have to keep going. You have to keep persisting. You have to keep fighting. You have to keep having offline meetings to try to negotiate agreement. And this happens over several meetings, spread over 1 year or more. It's very, very arduous. And anybody who thinks that the people who do this enjoy the foreign travel, so-called foreign travel, and enjoy these things, they are totally mistaken. This is very hard work, and it gets very tiring and taxing on the body once you get into this. The amendments to the patents that you have to keep filing to reflect the emerging consensus in the standard, the way forward, as you mentioned, he'll talk more about it. The amendments to satisfy the patent examiners finally, okay, about the novelty of and establish the novelty of this patent. So a typical standard, 5G standard may have hundreds of SEPs, not thousands, but hundreds, right? There are thousands, maybe 50, 60 times the number of patents which people have related to the 5G standard, but only a couple of % of those will be SEPs. Generally, many entities in more advanced countries tend to file a lot of patents, and a smaller fraction become SEPs. In our case, we are funds limited, so our ratio is not that high. I mean, our ratio is not that small, but still, even in our case, the number of patents we file is easily about 9-10 times the number of SEPs that we think we have. And even the specification of a single signaling bit, 1 will indicate this, 0 will indicate this, some feedback that you're giving from the UE to the base station. If the standard has the same definition, you have got a SEP. Okay? So don't think that all SEPs are something on OFDM or some, error correcting code and all that, some very basic fundamental thing. Lot of things are like this. But all of them take this effort because there'll be somebody else trying to do the opposite, okay, or something different. So this is what it's roughly about. I hope I've conveyed some picture, and maybe once Kiran has done his part, there is a better picture that comes and not a confusing picture. So thank you very much.
Thank you, sir, for taking us through this case study of wireless technologies for converting patents into standard essential patents in such a meticulous manner. We also have in the midst of us Professor Kiran Kuchi, who is a professor in the Department of Electrical Engineering at the Indian Institute of Technology, Hyderabad. He leads 5G Advanced and 6G research and standards development efforts at 3GPP. Professor Kuchi is the author of more than 200 international patents. Some of them are declared as 5G standards essential patents to TSTSI and 3GPP. Professor Kuchi founded Visig Networks Private Limited, an IIT Hyderabad technology incubator. Visig has developed and commercialized a 5G base station and user equipment. It's a pleasure to have you here, sir. May I request you to please deliver your talk.
Thank you. So I'm glad that the stage is set on this topic of the standard essential patents. First thing I want to tell you is that Professor Bhaskar was saying it's not fun to go to these meetings. Statistically, half or more people who do this work, they're divorced. Okay. And I survived mainly because COVID came and the meetings became offline. And I started sending other people. I realized the risk. But I just gained 10 kilograms. That's the penalty I paid, and missed 6 birthdays and 20 festivals and so on and so forth. So okay. I'll try to fit this into 15 minutes. I think this is already explained. I just reiterate once again. SEP is a patent that claims the invention, that must be used when a standard is implemented in product. What it really means is that there is a phone that is, you call it a 5G phone or a 4G phone, and this phone is adhering to some class of 3GPP or TSDSI standards. If you have a patent that is mapped to a standard, that's enough, because this phone is anyway adhering to that particular standard. You don't have to go and prove that my patent is included in this device. But of course, if you have a unique way of displaying and somebody uses it, you have to go and prove that the device is using your idea. But that's not required with SEPs. In SEPs, it's a pen and paper exercise and go to the court if required. Not necessarily prove that a chip uses your idea. Okay, next, I'll go to the next. I think some of you might be familiar. There is something called a provisional application. This only takes you about 25,000 rupees. If you have an idea and you can describe it in any amount of detail you wish at that point in time, and it gives you 1 year protection before you go through this whole complex route of filing in countries, PCTs and national. There's a whole bunch of process. Essentially, you get about 3 years time if you decide to not to actually get a grant. You can actually delay deliberately for 3 years, or you can get it granted within 1 year if you file directly in US. That's the shortest route, and even India is doing better these days. So there's a whole process around that. This one I picked up. I want to give an example of a good claim, because this lawyer was paid probably $200 an hour. This was in 1999. This is my first job and the first patent I did, and I spent 2 weeks explaining the core idea to this lawyer who is employed by Motorola at that time. He used to sit in this what is called a pager building. That's where the pagers used to be made. I was in the adjacent building, and we spent 2 weeks, and then he drafted the claims and the specification, and he used to dictate the notes to his secretary, and she used to record it. He also used to record it on a tape recorder, and then that gets typewritten Then I used to go through it and amend it. It was a different process. But in any case, these claims were written by this particular lawyer, which I consider as good set of claims. Writing good claims is very hard. These days, for example, the company I founded, we have a lawyer who is an electrical engineer or electronics engineer with a degree from IIT, and he also has a law degree, and we sit with them and write these claims because it's really hard to write good claims. And there is a guy I recruited in US. He charges $650 an hour. You know, that's a huge amount of money, but that's what it takes to write good claims. This particular patent is a very interesting one. This is the first space-time code that works for 4 transmit antennas. Just my boss at the time gave me a paper written by AT&T Labs that published the first space-time code. It's called space-time block code, developed by a guy by the name of Saivash Alamoti. And that paper, he put it on my table, and then we were actually developing something similar, but we didn't call space-time code. We were calling it transmit diversity scheme. That was my first job. And this one was expanded from the Alamoti code, and there's a clean way to expand it to more than 2 antennas. And algebraically, it was shown that it's not possible to construct space-time block codes more than 2 antennas. The linear algebra doesn't allow that. So I have to play some tricks, and this is one of those tricks. So the top portion is one transformation, linear algebraic, and the bottom portion is another transformation. There's a switch in between. And then we use a bunch of spreading codes and other dimensions to expand these transformations onto other antennas. And Motorola fought tooth and nail to get this into wideband CDMA standard. Well, there was no consensus. So idea had to be dropped. So just because you have a good idea, it doesn't mean that it gets into a standard. It was dropped. But later on, what happened is that 8 years later, a variant of this code is implemented in LTE. All LTE handsets and base stations use this transformation. But this patent is still not valid for that because that's an OFDM system. All these transformations were done on spreading codes in time. In OFDM, everything is manipulated in frequency. So if this patent has to be read on to OFDM, you have to change some 10 words. Then you will read on to OFDM. But that doesn't mean this is an SAP that reads onto the 4G. It is not. So the way in hindsight, this patent could have been written in such a way that it can be applied to CDMA, TDMA, and OFDM. That's what we do actually when we write patents. We try to make it, this applies to space, time, code, all sorts of things, okay? But of course, this is 1999. There was no OFDM in cellular back then. So the point here is that the way you draft the claim, it has to be so general and so elegantly written that it should be applicable and be enforceable even after 10 years in a different setting, in a different standard, which is hard to do, but a good claim can achieve that. That's hard to do. That's why you pay $700 an hour to somebody else, not the inventor who writes these claims. What are the prerequisites? Usually, you should have a year or 2 experience attending standards meetings, knowing standards, doing simulations, computer study, computer simulations. You have to have a good deal of exposure before you can actually come up with an idea that's patentable. At least a year of experience is required after you graduate from college, and somebody should guide you. I mean, it's not that you sit there and you create an SCP. It doesn't work like that. But there's a complex system around that. You have to be in a group, working in a group, and somebody can guide you. So typically, a person working on a year or more on some technology should be able to develop ideas like the one that I've given as an example. So what I want to actually drive the point here is that SCPs includes the 2 words, standards and patents. So what is this link? I mean, let's say you say, I have a patent. Can I make it standard essential? Well, actually, it's very hard. You can't take a patent that exists and make it standard essential. That's probably the hardest thing, because you have not actually conceived an idea in the context of a standard that has industrial utility. Of course, this is possible, but maybe one in a million can be of that kind. And those are rare patents. It happens, but very infrequently. But from an industrial setting point of view, generation of standard essential patents requires you to be part of standards development process. This is a prerequisite, more or less. So I'm giving 3GPP as an example. Of course, this holds for IEEE, TSDSI, and any other SDO. In order for one to drive these, develop these ideas and make them part of standards, there are two reasons why you participate in a standard. First of all, you want to build a standard. That's for the benefit of the ecosystem. You don't go there for the sole purpose of developing standard essential patents. I mean, of course, that's your selfish reason to be there. But the other reason is that you have to build a standard that's usable for the society. So standards development process is a very unique exercise. It's a contribution to the society from a company. But of course, the selfish reason is that you want to control the product, control the ecosystem, own patents. There are two parts to this. So if you want to really succeed in promoting your ideas and incorporating the standard, you can't just be selfish all the time. It doesn't take you anywhere. You will be discarded, thrown out, or disliked. So you have to actually contribute to the project. You have to be a good member of the team. You have to add value. If I'm going to a 3GPP meeting, let's say I'm a newcomer, I can't just go and bulldoze the whole place. You have to earn the goodwill. People have to feel that you bring value to the table. Then only your ideas will be heard. It's all done through the process of consensus. So in all these work item development, study item development, everything is based on consensus. You don't vote all the time. Of course, voting is there when the situation gets very complex. And these standards evolve highly incrementally. You don't just get everything done in 3 months or 6 months. It's an incremental process, and you have to go there, contribute, look for opportunities, solve problems. Everything is all the inventions takes place on the fly. Of course, sometimes you may be clever enough to develop, let's say 6G is coming, then you develop your patents. How do you do it? Well, you kind of know what was missing in 5G, 3G, 4G. That's because you have done that. And you know what needs to be solved, and you develop a portfolio of patents, but you have to be armed with a large number of patents, large number of ideas. You can't go and say, well, I have this great idea, and this you try to incorporate. That doesn't work. You have to actually be armed with a lot of different ideas. Some of them you have to give up, some you try to incorporate. It's a complex exercise. But even though you are able to develop a patent, you get a grant, actually the value of the patent increases, enhances significantly if you can actually show that there is a TDoc, the document that is submitted, there's a timestamp, it is submitted on so-and-so date, there's a meeting that took place, this is the chairman's notes, this is the way forward, this is the agreement. All this is recorded for almost 20 years time period in 3GPP. All these records are kept for a purpose, because when enforcement happens, when you go to a court of law, these are the things that matter. You have to be able to establish that. It's just not that you got a patent grant. You actually contributed, it's all time-stamped, and you have to explain to a judge that you have really done this work yourself. That matters a lot. So, and then there are these features called mandatory and optional. This is another big thing in 3GPP. There are so many features that are in 3GPP that are unusable, that are never implemented. So releases of 3GPP standards come in, but the wider market only adopts a subset of them. So you have to be very careful where you are putting your energy. And then there are optional mandatory features. That is, from the phone point of view, there is an optional mandatory feature list that is released by RAN plenary at the tail end of the standards declaration. And then from the base station perspective, there is no such list. Base station can choose to implement an optional feature, then it is implemented. And then of course, base station has to implement certain features mandatorily so that communication takes place. So this is also a complex matter that needs to be understood. So it is preferable that whatever you write in the TDoc is patented very clearly before you submit a TDoc. TDoc is a technical document that you submit to 3GPP. So I'm just summarizing here that there is a matter called consensus. That is, 10 people get together, they work on an idea, there'll be 10 proposals, then naturally a candidate emerges. through a process of deliberation, consultation, some backdoor channeling, technical merit. It's a combination of many things. Technical merit is very important, and at the same time, you have to be able to convince others that this is an idea they should be adopting. And there is a giving back and forth. So that's very important. Therefore, if you just have a patent with you and you go say, well, use this patent, it just doesn't really work most of the time, except in rare situations. I'll give you some examples of what has really transpired for some of the proposals. February 2017, this way forward was agreed. You can see there is something called working assumption. Working assumption means it's not an agreement. It has the potential to become an agreement. So 2 years of effort between 2015 to 17 has resulted in that sentence. You see that 5G NR supports pi by 2 BPSK modulation for DFT-UFDM. Then there is some further study and all that. This was supported by, you can see, IIT, HCVT, IITM, Tejas, Reliance, Qualcomm, Samsung, Intel, AT&T. Some of the acronyms I forgot: Panasonic, Huawei, Sony, Kyocera. I'm just reading them out because actually you have to go and spend time with all of them, convince them that this is a technology that is useful. Okay, so that's not easy to convince, but it took 2 years. And 2 years of effort resulted in only some 6 lines of text. But of course, the 6 lines have a deeper implication. So this is in February 2017. In September 2017, this working assumption has been elevated to an agreement. See how many months has elapsed. Agreement is cast in stone, that this something like this must be part of the technical specification. But yet there are so many things that are unresolved. So agreement says that what kind of pilots should be used for this waveform, what should RAN 1 do, what RAN 4 does, and all that. And again, so many people have supported this contribution. So this is all captured, and all these matters, if you really have some patents behind this, all these matters, what has happened when and who has contributed what and all that. Now, fast forward, there's so much that happened between 2017, release 15 of 5G was established, pi by 2 BPSK was incorporated as an optional feature, release 16 came in, new pilot sequences were defined. It again remained as an optional feature for sub-6 and somewhat mandatory in millimeter wave. And then, some of you are aware, then 5GI has carved out of this 3GPP, and then that has a specific 1+D filter, and then that's called 5GI, submitted ITU. Then finally a merger has happened. And in the merger, what really happened? Well, actually, of course, I didn't put all the text. This note was added. That's one. Then on the tables, the optionality was made into mandatory, and a few other changes happened. And look at the dates. This is 2021, during COVID. So, I mean, I'm talking about 2015 to 2021. That's the beginning, and this is the end of the exercise. And that's what it took, one major feature to be incorporated into a standard. But of course, this is a bigger piece of technology. It had more implication to the phone, device, RF, baseband. So physical layer is hard. If you are just introducing some bits here and there, maybe it's much more simpler. And not everything has to be this hard. But if you want going after a feature that really has a profound impact on the power, spectrum efficiency, coverage and all, then the bar is generally a bit high. The point is that this is all what happens on the floor in the meetings. I'll skip all this. This is my last slide. Then you have to disclose your patents. I'm just showing a sample disclosure here. You have to, this is a TSDSI declaration form. I'm just showing you a part of the document. You have to say which standard, which section, which patent, which claim reads on to which section. You can see the claims read on to so many different sections, that particular patent. So these declarations have happened. That's probably where it ends in terms of developing patents and declarations. The rest of it is commercial activity. How to enforce it. That's a different ball game altogether. I'll stop here. Thank you.
Thank you, sir, for bringing to the fore various aspects of a standard's essential patent, including the underlying processes and procedures. Our next speaker is connected with us virtually. We have the gracious company of Sri Vishnu Ram, independent expert TSDSI, who has hands-on experience in the field of telecom industry for 25 years in developing and implementing standards, and he holds 14 international granted patents. He's a senior member of IEEE and was also nominated to Scientific Advisory Board Associate Member of Motorola Networks and was Senior Specialist Radio Resource Management at Nokia Networks. His current work includes coordinating standards initiatives, liaisons with other SDOs, industry bodies, open source and academia, mentoring student projects, and coordinating the ITU's AI ML in 5G challenge around the globe. It's a pleasure to have you here, sir. May I request you to please deliver your talk? Sir, can you hear me?
Yeah, thank you very much, Aman.
Yeah, sir, you're
Thank you
also,
for the-
yes, sir, you're also audible here. So we can just see, so your presentation is also visible here.
Thank you, Aman. Yeah, thank you for the introduction and thank you, colleagues, for the invitation. Sorry, I'm not physically there. I'm currently in Geneva for the ITU meetings and working on this particular subject actually. And you know, Professor Kiran's statements on divorce got me a little worried, but yeah, that's where we are. So yeah, so let's get started. I will take 15 minutes. I will talk about creating a sustainable, inclusive pipeline of innovations and standards. I mean, I stepped back a little bit from patents and I called it innovations specifically because it makes it a little bit more accessible. But I will come to the patents part at the end. Okay, so this is what I will cover. What are the steps in the pipeline, the success stories from around the world, what we have done with different countries, and what is the way forward. Okay, so the pipeline, what I call as pipeline is what you see here. The planning steps for sustainable innovations involves mainly 4 steps. So you look at what are the pre-standards activities, that is step 1. What are the normative standards activities? And then putting a little spice into it in terms of the local flavor and what are the India specific positions and debates that one could push into the standards. I take the example of ITUT because I mostly now currently working with ITUT as a global standards body, but I have at the end I have 3GPP standards which we have worked with as well, and the SCPs which are relevant to that. Then another part I think Professor Kiran mentioned this also in terms of extensions and customizations which are possible. And this monetization is very important. Pushing this into the products is very important. Leaving that as a paperwork does not count. So how to do this is the question. And we will talk about some examples of doing this as well. I have some mapped it into currently what we have done previously in the last 5 years. For example, pre-standards activities, we worked on focus group. ITU has these focus groups which are pre-standards activities. They are not normative standards, but that's the entry point for us where an academic institute, for example, does not need a membership of ITU. You don't have money to pay for funds for paying for membership of ITU, but you would like to contribute in the beginning. This is a good entry point for you. And this is also a good point where you could validate your ideas. So that's what we did. We did a focus group contribution. And then after discussing this for 2 years, it became a normative specification, which is a standard, so to speak. That is what we call as ITUT Y.3172. That's a good example of what we did from India. Finally, we then on top of it, we built an add-on, which is a sandbox, which is further developing this architecture framework into something which could be deployed in the network as a sandbox activity. That is Y.3181. So this gives you a pipeline example where one puts one's door in the foot with a pre-standards activity, goes towards the standardization phase, and then goes to adding extensions on top of it as a extension activity. So what is a blueprint for a pre-standards analysis? You study use cases for local applications. That's a good point where you study the requirements at the local stage, and then pool some knowledge base around the world. Put your initial ideas on the table. Collect some ideas from around the world. Then fine tune it with local experiences and data. This I'm talking about. What are the use cases which one could look at in various fields, and then monitor with feedback. This is what one would do. So if I take the example of what we did in AIML, that is the focus group that I talked about. Around 2019 or so, 2019 or 2018, we started working on this, on studying the advances, getting the gap analysis and integration going, then creating this knowledge base and some sort of data collection, and then going towards the POC for it and creating some architecture options somewhere. So this is a blueprint that we followed for pre-standards analysis. Perhaps it is a good model to follow for our academics and startups as well, because this doesn't require a membership of ITU. So just to analyze the academia collaboration. So we had actually the pre-standards activity going with the India contribution. That is from 2017 to 2019 we did this. This is not a normative standard. This is an informative document. And then in 2020 we did the WTSA, that is a World Telecom Standards Assembly resolution around this topic of equitable AI and so on. And then 2022, we did another pre-standards contribution on ITUT supplements and grants. So this shows that it's possible to do a pipeline of pre-standards activities on a domain of area of, let's say, AI and machine learning and so on. Then finally, after this got matured a little bit, we moved on to normative standards activities. That's what I talked to you about previously. Then the next step is to getting this India-specific debates and so on, taking positions in ITUT. That's what we did in 2020 and 2021, where we put in specific contributions built on these frameworks, taking certain specific decisions and positions, pushing extensions and customizations go ongoing as part of the currently ongoing meetings. This is not only in India. We have collaborations with our colleagues in Africa. In fact, yesterday we had discussions here in Geneva with our colleagues, professors from Nigeria, who presented exactly this slide. So they with our collaboration, what they have done is that there are student projects which they pushed from 2018. And then they published this in news magazines, ITU news magazines, which is encouraging the students to come forward and work on this area. Regional groups play a big role. The study group 20 has a Asia Pacific regional group. That India has a chairmanship and vice chairmanship for this regional group as well. So this regional group of study group 13 is a good forum for contributions for Africa side. So there is an Africa regional group where they push use cases, as I told you previously. Use cases are informative documents which they push. This is not paperwork alone. There are proof of concept activities which proves the benefit of what you're doing. I think Professor Bhaskar also talked about benchmarking, getting some studies and numbers done. This is actually the activity to do it, the build-a-thon activity, that is to create proof of concepts and do studies on the network, on test beds to show that some of these ideas really work. Okay, so this is the steps which they followed and along with our collaboration. That is the step one, is to form a team of students and scholars working on this, brainstorming on this, and wider consultations with ITU meetings and submissions which follows. Another activity which we also did is to crowdsource some of these innovations. That is pooling these knowledge bases from around the world. That is, a baseline one baseline of simulation resources, which forms the baseline for all these activities, data, AI, ML models, and knowledge bases, which are shared as well. This is actually done as part of the AI ML 5G challenge from ITU. We have opened data, models, and code. Yesterday, the Deputy Director General announced the data for energy management from base stations, which is real network data as well. So there are 4,000 plus participants. I'm not going into details, but this also forms a pre-standard study sharing knowledge base and simulation resources, which you can use to create this sustainable pipeline for innovations. Another aspect is the use of open source. There is what you see here is Linux Foundation AI, but there are other open source bodies as well. There is a large bunch of code. You don't have to start from zero. You don't have to start from scratch. There are 330 projects just under Linux Foundation AI I'm talking about. There are other forums in open source as well, which you can take advantage. And this is free of cost, no membership. You are free to use and you're free to look at reference and as well build upon. Okay, so how do we use this to lead the way for innovations for good? So first thing that we have learned is that mentoring, collaborating with ITU, important for academia in developing countries. This is really important. Open source and AI and network autonomy are important features for 6G. This is what we are currently focusing on. I told you about publishing open knowledge bases that lowers the barrier for contributions, and that's where we have put in our innovations. We are also now currently looking at large language models as a portal for opening contributions, putting in contributions assisted by such models. As you know, WTSA 24 is planned to take place in Delhi in fourth quarter of 2024 in India, and this is a good opportunity for all of us to put some contributions aside. So now, how do you convert these innovations into standards, essential innovations? Again, I'm stepping back from patents and looking at it a holistic innovations map. You look at a cluster of core ideas, like Professor Kiran mentioned just now. You look at a cluster of core ideas. Let's look at what you see on the right side is my set of patents where I have for a set of core ideas. What is that set of core ideas? Let's say paging optimization, mobility optimizations in 6G, right? So you take that core idea and then develop it in the form of these clusters that you see here. One is the SDO specific instance. So you look at ITU, you look at 3GPP, you look at IETF, whatever it may be, wherever you go. You look at that SDO specific instance. That is one part of it. Another part is the open source instance. I told you about Linux Foundation. There are other bodies which does open source as well. Look at whatever you pick. Look at the open source instance to give you that practical aspect which you can put as a proof of concept. Another one is industry body instance. I think the morning Sendil talked about industry body and the influencing bodies for 3GPP. You have your fingers there as well in that pie also, which can help you to do this, pushing these innovations and patents into 3GPP. And another one is locally tuned instance. I already told you about local flavors and extensions. And finally, academic instance is the first starting point. I have some claims here. I don't want to go into details of it. We already saw Professor Kiran and Bhaskar talk about it. Some considerations. I want to leave you with this. Some considerations. One is that a fast-moving train. You want to get into that train. It's very dangerous. So this is like what Professor Kiran also mentioned, that you have to find out where it is going, where is it stopping, what are the release points of 3GPP. If you want to get into that running train, you better figure out where the stations are. This is like if you want to end the SDO release cycle, you better figure out where you don't want to run into a walking train. Another thing that he also mentioned, there is no magic algorithm for conversion of patents into standards essential patents. You go through this sustainable pipeline, there is a good chance that you get a standards essential patent. And also a map. And you need a map to go from place A to place B. Right? So you go look at my idea. I think Professor Bhaskar called it potential patents and key areas. That's what I have noted from his speech. So you start with your key area, potential patents. then go to pre-standards analysis, then go to local use cases, then go to extensions and monetizing those APIs or extensions, whatever you have. Okay, how do you reduce the cost of innovations? Yesterday in ITU, we had very good discussions around using ChatGPT. This is not my words. These are coming from the chairman of Oran Alliance, Alex Chua. We have a webinar from him. It's all recorded. You can look at it. ChatGPT generated software programs are coming. Generative AI is coming. Use of digital twins and the combinations of generative AI is coming. So if you don't have funds, no worries. ITU is actually looking at generating some of these data and innovations in collaborations with you. So this is my last slide. We are actually putting up Margi. Margi is actually a chatbot which will help you to bring up some of these innovations using these large language models. You look at training ITU data with use cases, architecture, and code. Used with these large language models, a chatbot will be open for you. All you need to do is come on 14th July. You can scan that coffee cup over there, and you can register for it. It's open to everybody. No membership, no fees. Contributors, innovators, and students it's open. We are having a workshop. It's actually focused on autonomy for 6G networks. Margi chatbot is going to assist contributors and innovators to submit this, come up with these innovations, then take it forward using the pipeline that I mentioned. That's it. Thank you so much. Thank you once again for the invitation. Back to you. Thank you very much.
Thank you, sir, for giving us valuable insights into creating a sustainable innovation ecosystem. We are pleased to have with us Shri Gaurav Khandelwal, co-founder, Intricate Research, an IP research and analytics company. Shri Gaurav has around 14 years of experience in the field of patent analytics. He has worked on all aspects of patent services, ranging from patentability, patent drafting, to patent monetization. He's an expert in telecom standards and has worked extensively on projects involving invention evaluation, patent to standard mapping, SAP verification, SAP-based continuation recommendation, and telecom standard patent landscape studies. We are pleased to have you here, sir. May I request you to please deliver your talk.
Thanks for the introduction. Good afternoon, everyone. And first of all, I would like to thank TEC for inviting me here as a speaker and share my thoughts on standard essential patents. Today, I will be talking about the best practices one can adopt in their innovation strategy while developing an SCP portfolio, and how one can leverage their SCPs and SCP portfolio going forward. I will touch upon on different aspects related to standard essential patents, their importance, how one can align their innovation strategy with the standardization activity, and build their product portfolio around that, and the SCP licensing as well. So what are standard essential patents? Much of about it has been already discussed here, so I'll not go in much detail. But standard essential patents are basically those patents which are inevitable for implementation of a technical standard. The members of an standard developing organization declare their patents as essential in standard developing organizations. But one thing is to note that not all declared patents are a true SCP. There are many patents which get declared but are not standard essential patents, and there are some which are truly standard essential patents. So why does this happen? When the companies can declare their patents in an SSO during any stage of the patent life cycle, some of the patents are even declared before they get published. And what happens that during the prosecution journey of the patent, the claims get modified, and then some limitations are added into the patent claims which make them different from the standard essential standard features, even though the initially filed claims were mapping on the standard specifications. So this is why Declared SEP, it is important to understand the difference between a declared SEP and a actually true SEP patent. And the essentiality test of an SEP actually happens in a court when a patent is subjected to a court trial and the jury or the judge decides upon whether the patent is actually essential or not. And also some of the companies employ a in-house team of legal experts or consult outside IPR experts to check the essentiality of declared patents. So, and I would like to emphasize that SSO or SDOs do not check or verify the essentiality of a declared patent. This is, one must understand this, and it is not their job to check whether a declared patent is actually as essential or not. And one must also know, that, as already been discussed, that the IPR declarations in SSOs, with SSOs, mandatorily come with a friend commitment by the patent owner. So they cannot charge any licensing fee, whatever they want. It has to be under the preview, under the terms and conditions of the friend terms. Now, this is a snapshot of a IPR declaration. So Dr. Kiran already showed a snapshot similar to that. So I'm just skipping this. This slide shows the importance of SEPs as they hold a very strategic value for the patent owners. It acts as a defensive as well as an offensive business tool or business strategy tool for the patent owners. SEPs promote interoperability as the product from different manufacturers can work together if they comply with a technical standard. It fosters innovation. It ensures fair licensing practice in the industry. And there are other benefits that, such as it has a global impact. It improves the reputation of the patent owners, and it also brings a kind of predictability and stability in the technology domain. Now, let us take a deeper look that how one can embark on a path to develop an SEP portfolio, and what are some of the important steps during this journey. So first of all, one needs to plan their direction of innovation well in advance, such as, for example, as discussed earlier, that for example, for 5G, the first commercial rollout of 5G happened somewhere around 2019, but the requirements or the ITU started working towards the 5G specifications and defining the requirements of 5G way back in 2012. So you can see there is a gap of 7 years when the planning actually started by ITU. The practicing entities or the companies had started planning well before that as well. So there is a clear, you can clearly see that the planning starts well ahead of the actual launch of a technology standard. Now, when you are doing a planning, one should look at what are the technology white spaces, like what are the future use cases, which and what are the requirements of those use cases, whether the existing technologies and the standards are able to fulfill the requirements of use cases, and then you find out what are the problems the future applications may face, and then suppose you find out 10 or 12 problems which are there, and then based on your own technical expertise and your team's technical expertise, you choose certain problem areas where you try to solve those problems, and in that path you tend to create some inventions and you innovate something new. And then when you reach a solution, you should also then look at whether there are similar solutions in the which have been developed in the due course of time, which are also targeting those particular problems. And then if you think that, okay, there are some better solution and I need to improve my solution, you should work on that. And when you reach a final solution, then you can think of filing a patent around that. And then as Dr. Ramamurthy and Dr. Kiran said, that there is a patent filing procedure that you either file a provisional patent or a PCT application. Based on the timeline, you see that when that solution can get into the market, and based on that you decide your patent filing strategy. And when you decide to file a patent, it is important to first conduct an invention screening so that you see that whether someone has also developed a similar solution. Because if someone has developed such a solution and if you go ahead with patent filing, you might face problems while patent prosecution. So it is very important to get a patent screening or invention screening study conducted before filing a patent, which we sometimes call novelty search or patentability search. And when, if you find that your invention is actually novel and at the moment nothing similar to it exists, you go ahead and file your patent. And once you file your patent, then you should also contribute or propose your solution in the standard organization meetings. Because even if you don't propose your solution, it is they are not likely to get included in the standard. So, and once you propose your solution, it is important, as said before as well, that it is very essential to be active contributor and active part of those standard meetings, standard body meetings, to push your invention, to generate a consensus around it, to make the members of the standard body aware of your solution, what are its advantages and why it should be included in the standard. And similarly, when the standard standard is getting developed, you should continuously monitor your patent portfolio to see whether the patents that you have filed, they are actually going in line, or they are in line with the direction which the standard is progressing. And suppose if you find that there are certain patents which are not in line with the standard, the direction which standards are moving, and are unlikely to get included in the standards, either the current standard or the future standards, then you can decide to prune those patents, and rather than investing much time and effort on those patents. And then when the specifications get finalized, then you do a patent declaration in those standards in which you think that your patent is relevant to, and then you declare your inventions. And then when your patent is about to get granted or has granted, you kind of check that whether the patent claims that you have written and the specification that you have drafted in for your patent, you check whether there is any technical matter in your patent which has not been claimed yet, but it is relevant to the technical standard. And if you find any such unclaimed technical matter in your patent specification, then you can go ahead and find a patent of addition, as it is said in Indian Patent Office, to broaden your patent portfolio and its coverage for the standard related features. And then when the patent gets granted, then it is open for licensing activity. And when doing a patent licensing activity, it is important to check whether the patent is actually essential or not, whether it is mapping with the technical features which are described in the technical standard. So this is an example of patent to standard mapping, which we tend to generally create for our clients. As you can see here, that the priority date of the patent was August 2012, and the publication date of the standard on which that patent claim is mapping is June 2018. So there is around a gap of 6 years between when somebody thought of this invention and filed a patent application about it, and when that feature was actually got included in a published standard. And here you can see that we have also tried to show the similar features with a color coding, and there is a very good mapping between the features described in the claim and the features which are there in the technical standard, and the terms are also quite similar. So there are quite a few possibilities why this has happened. One is that either the patent filer or the inventor was very well aware of the terms which are used in the standard and its standard specifications. They might be also actively participant in the standard meetings, so they knew what is there going on in the standard meetings, where the direction of the standard is, what terms are going to be included in that, and they might have tuned their patent claims around that. And it is also possible that the patent inventor was actually the contributor in the standard meetings, and it was the contributions of that inventor which were got included in the final standards. So in the 3GPP document, they provide a good documentation and how the standard progressed and change requests and the T-docs where the contributions are made. So one can actually trace back from the published standard to the actual contribution where, who and when actually contributed that feature in the standard. Now, over the course of our experience working with the industry players, we have seen that the startups are many of the startups are hesitant to enter industry or work in the SAP domain because they see that it requires quite a lot of time and money and investment, and the results with the effort they are putting in now, the results are not immediately visible. The results will be visible in a due course of time, sometimes even 5 or 6 years after. So they are kind of hesitant to enter this area. So we need to make them aware that it is okay, and and also we should make them aware about the importance of patents, SEPs, and also we kind of suggest them that apart from investing your efforts into SEP, you should do that. You must invest your time, effort, money in the SEP related patent portfolio development, but you should also work on other features which are not covered by SEPs, and work and develop some innovative and unique solutions which can act as a unique selling point for your products. That will help you get a market and generate a market presence, capture market, and then using the revenue of your market share and the products, you can then reinvest that money into development of your SEP related patent portfolio. So it is essential to emphasize that the SEP strategy should be planned with a far-sighted view. It should be planned very carefully, and a long-term vision is very important when you are thinking about generating or developing a SEP-related patent portfolio. The next slide talks about briefly talks about the SEP licensing, that there is in licensing that someone who does not have a patent can take the license from other patent owners. The SEP owners can or they must license out their patents on friend terms, and then when there is a deal happening between two patent SEP owners, then it is a cross licensing deal where they take license or license out each other's patent, and then there is monetary value involved based on the strength of their respective patent portfolios. So here are some of the key takeaways from my presentation. That one of them is that innovation is the key. One should try to file as many patents as possible, covering the each and every aspect of their solution. It is not, as rightly said before by both the professor, that it is not that you file a patent and it will get included. It is not a guarantee that it will get included in a standard. So you should, when you are filing a patent or you are developing a solution, you should take a holistic view. Try to protect each and every variation of your solution which you can think of, so that all the bases are covered, because you never know that which variation of your solution will get finally included in the standard. So it is very important that one should keep a far-sighted view. One should keep a long-term plan, and then protect each and every aspect of their invention, so that there is a less likelihood of missing out on anything. And then one should actively participate in standard body meetings to understand where the standard is progressing, what is the status of their patents in view of the standard where the standard is progressing, the features which are getting included in the standards, and whether their patent applications are in line with that or not. And this will also make someone the person abreast with the standardization activity, and increase the chances of inclusion of their invention or their patents in the standard body. And it will also give an idea where what is the technology landscape, and also give you an idea where what is going to happen in the future releases, what the standard bodies are thinking about, what to include in the future releases, what is your plan about that, so that you can plan your existing R&D activity around that and make a good plan about your innovation strategy. That's all from my end. I hope it was informative for you.
Thank you, sir, for making us delve into the nuances of standard essential patents and licensing. Our last speaker of this session is Shri Avinash Agrawal, who is currently working as Deputy Director General, TEC. An ITS officer, Shri Avinash has almost 30 years of diverse experience in telecommunications, information technology, and broadcasting while serving in various positions in the Government of India. His research interests include ethical aspects of artificial intelligence. He is the chairman of National Working Group related to broadband cable and TV. He is also the vice chair of the National Working Group related to economic and policy issues of international communication. He also chairs the working group on anonymization of data supported by the Ministry of Electronics and IT. Sir, I request you to please deliver your talk.
Thank you and good afternoon to all. So I will be talking about the need of tracking telecom patents and how we are doing it in TEC. So we have just recently started tracking telecom patents in TEC, and in fact that was a direction coming from our Secretary Telecom. So this work is being carried out by the Convergence and Broadcasting Division. It includes tracking and monitoring of patents in the telecom sector filed by Indian companies, organizations, colleges, etc. in the emerging technologies. And we are like initially focusing on 6G patents, 5G advanced quantum communication, satellite communication, IT, IoT, and all other related things. And we are slowly moving into other areas of telecom also. And also we have instructions to track patents for IT and electronics also. We are focusing on the Indian patents only. So basically like maybe the applicant country is India or related things like that. And we are not very much interested in going back in the history of what has been filed earlier. And because we are more focused on the emerging technologies, 6G, 5G advanced, and other things. So as per the experts on the dais and also in the speakers there, we were suggested that we can focus on the patents which were published 2021 onwards. So what is the need of tracking the patents? One is that we get insights into the technological landscape, what is happening on which technology our countrymen are working on, identifying the emerging trends and collaborations. It is also very important that it becomes kind of a benchmark for measuring the technological progress. So even just a few days back and in the morning session also, we heard that our Honorable Minister has set some targets of some percentage of the 6G patents coming from India and all those things. So, and if you have seen the press releases also, so a few months back there was a declaration that we have around 100 patents of 6G, and just last week the press release mentioned about 200 patents. So that monitoring and benchmark is also facilitated by this tracking mechanism. Then it also helps us in identifying and tracking the institutions and industries who are doing some innovative work. And in fact, while we were looking at the data and we were expecting that most of the patents would be from the academia, would be coming from the IITs, we found that there is one university which is in Jalandhar, and that's why we could reach out to one of our speakers who will be talking in the next session. So it helps us in identifying that who all are working in this area, and then we are also identifying the researchers where we can identify the actual persons who are working in this area, and then we can reach out and then we can collaborate for contributions to the standards. So our aim is to get talented people, researchers who are working in isolation to collaborate and contribute in patent standardization activities. So then after tracking, we have also developed a dashboard. Because of time constraint, I will not be able to demonstrate it live, but it would have been a pleasure to show it live because it is an interactive and dynamic dashboard. So if you click on any graphic like on the circle or on the bar, then you can further apply filters just by clicking on that. So these are 3 or 4 screenshots. If you see the bar on the left side, broad category left or right, like this mobile technologies, and we see the figure of 221. So sometime back it was roughly 100. And if we can, so this is something I think which is more related to the 6G or 5G advanced patents. We can also find out like in which month, how much progress took place, year-wise publications. So I will tell you how we are doing it. So it is not very accurate, but we are just trying to make it more and more accurate and more inclusive. So we have just started a few months back, but this is one of the first screens. Then this is the another screen where you can get the geographical spread. So in fact, through this dashboard only, we could find out that there is a big circle on top of the country, like in the Punjab. And so that we found out that it is LPU University in Jalandhar, which is also having a lots of patents. And then if you can click on any, like suppose I click on Uttar Pradesh, so all data like in the previous slide also, all these figures would change and we'll have only the numbers and bars and all those graphs related to that particular state or section. And then you can apply multiple filters also. And then we also have certain more dashboards, like you can have the keyword-wise patents, and then you can go to the organizations, and then you can also see the individuals. You can also find out how much is from the academia, how much from the industry, and whether they have been filed in the country or outside the country. So, and then we also can find out, like, we also have the names of persons and the names of patents, and on the left hand side we have tabulated just one screenshot of the some patents from academia, and the right side we have those from the industry. So how do we get the information? So basically, like, we are getting information from the patent websites. Basically, we are following those 3 patent websites shown on the bottom side. We are looking at the Indian Patent Office, then the US Patent Office, and WIPO. Then we also get information from academic institutions. We have tried to reach out to major institutions. We reached to IISc also, and some of the IITs. So we are just not relying on the websites, but also getting actual data from most institutions are having their patent offices also. So we have just started, but we'll soon try to have a mechanism that we get information from there, and similarly from industry, and from individual experts also. If they have some patents, they can reach out to us and tell us. So this is the step. These are the steps that we follow, that we list out certain keywords, we talk to the experts, and then we find out that these are the keywords on which we should do the search. Then we also filter based on the date and other parameters on the basis of applicant country, and then we search primarily on the Indian patent side. Then we also search on WIPO and US patents, and then we also clean the data. Like if there are duplicate entries, then we remove those data, and like this, we are also then adding information that we are receiving from the companies or colleges and like that. So based on all that, we are just doing this work. This is just a glimpse of what the keywords we have used. Like for mobile technology, we used, this is not the exhaustive list, but most of the important keywords I think are available, like beamforming, massive MIMO, meta surface, all those things. Then for radio, we have other keywords. And then because there was some requirement to track the patents related to other verticals like IT and electronics, so we have just started doing that part also. So, and we will be just expanding this list. This is just a sample, but these are not limited to these 4 broad areas or these few keywords. There are many more, but we have just listed a few here for illustration. Then because we need expert guidance on whether we are moving on the right track or not, and whether we can improve our tracking mechanism. So we have just formed an advisory committee, and I am happy that almost all of these experts are available here. We have Professor Abhay Karandikar sitting right there, and Professor Kiran Kuchi, Professor Sirohi, Dr. Dalela is sitting right in the front there, and myself, Sujit, Sanchit, and Harsh. So this is the advisory committee, and we are expecting someone from Tejas also to join. And the idea is that, sir, you can guide us on what are the keywords that we are using, whether we are tracking on the right path, whether we need to improve, and all those things. These are just some of the sample data, like what we have done so far. Based on that tracking, we could see that lots of patents are being filed by the academia, then followed by industry, government organizations, and so on. State-wise also, if we see, then lots of patents have been filed in, maximum are there in Tamil Nadu, then we have in Telangana and Karnataka, then Andhra Pradesh, West Bengal, and so on. So then what next? Like after doing the patents and preparing a dashboard, these are the next things that we plan to do, because otherwise the tracking is of no use. So the idea is that once we have tracked the patents, we have identified the institutions, and we have identified the experts who have filed the patent, then we would like to map the patent holders with our national working groups. Like we have national working groups corresponding to the ITUT, and also we have mapped certain working groups of IEEE also with those working groups. So with the terms of reference of those working groups, we will see that which expert could be able to contribute in which national working groups. We'll reach out to them and request them to join the national working groups, identify the work items. Like in ITUT, we have lots of work items, more than 1,000 work items are there. So identify, work with them that on which work items they would be able to contribute. And if required, based on their patents, we can even create new work items. I am talking of ITUT, but they can contribute in 3GPP and 1M, 2M, and others also. So the idea is that after tracking the patents and identifying the individuals, let us collaborate and see how they can contribute to the patents. So that's all from my side. Thank you.
Thank you, sir, for taking us through TEC's initiatives towards evolving a telecom patenting ecosystem. We thank our esteemed speakers for this enriching session. May I now request Dr. Pankaj Kumar Dalela, Director CDOT, to formally present a token of thanks and gratitude to our esteemed speakers. Professor Bhaskar Ramamurthy from IIT Madras, we thank you, sir. Professor Kiran Kuchi from IIT Hyderabad, we thank you, sir. Shri Gaurav Khandelwal, co-founder, Intricate Research, we thank you, sir. Shri Avinash Agrawal, DDG TEC, we thank you, sir. We also thank Shri Vishnu Ram, independent expert TSTSI, for connecting with us virtually. I request the speakers to please come forward for the group photo. Thank you. Considering the paucity of time, we'll move on to the next technical session without the break. We'll have the break at the end of the concluding session now. We'll just wait for a minute to convene the next session. Our next technical session aims to deliberate on the topic how academic institutions can help build a standards community. May I request the speakers of this session to please take the respective seats on the dais. We have with us Professor Abhay Karandikar, Director, IIT Kanpur, Professor Krishna Sirohi, IIT Delhi, Professor Manoj Chaudhary, Vice Chancellor, Gati Shakti Vishwavidyalaya, Dr. Akhil Gupta, Associate Professor, Lovely Professional University, Punjab, it is our privilege to have Professor Abhay Karandikar, Director, IIT Kanpur, as our first speaker in this session. Professor Karandikar was the founding member and chairman of TSTSI. He was also the part-time member of Telecom Regulatory Authority of India. He serves on the board of several companies and has founded and mentored startups in telecom and networking. He also serves on the board of governors of IEEE Standards Association and advisory board of European Union's 6G Hexa 2 Consortium. He's a member of Technology Innovations Group on 6G and chairs the 6G Spectrum Task Force set up by the Department of Telecommunications, Government of India. It's our honor to have you here, sir. May I request you to please deliver your talk?
Thank you. Thank you very much. Since we are already overrunning the time, I will be very brief. Some of these have already been talked about in the previous session. But focus of mine will be that how the academic institute can participate in standardization and what has been our journey. I will just briefly capture. I think I don't have to repeat this, but has been already mentioned in the previous session that the standardization is a process where you need a lot of collaborations, a lot of consensus, and open communications between stakeholders. There is a common methodology where you can initiate the study items, which can lead to new work items. There is, of course, open call for contributions. And then, these periodic meetings are held where the contributions can be actually included in the standards. And in all these process, let me just briefly mention, what is the academic institution's role and how we can sort of contribute. Now, typically, in an academic institution or in a university, a conventional research, either through a PhD scholar or an MTech thesis, will typically start with the literature survey and problem formulations. And then, you spend some time looking into the solutions of the problems, the novelty of the solutions and applications. Then, the new ideas may come up during the problem solutions. You verify the solutions with the help of either simulations or experiments. And then, if these ideas have advanced the knowledge, then you end up publication in some of the top tier journals and conferences. And also, some of these ideas can be patented. Now, as far as, however, the standardization is concerned, and I think this point was also made by Professor Bhaskar Ramurthy, that this research which will lead to standards is a little different than the conventional PhD research which normally happens, but it can be extended towards standardization to bridge this gap between the research and actual implementations. This definitely requires the interactions with the industry to understand how the research work can become the part of the standards. And as you saw that Professor Kiran Kuchi also mentioned that even the contribution that was made, one has to really work with a lot of industry stakeholders and even make them signatories to those contributions. You therefore, when you prepare the contributions based on your research, you need to take the feedback and support from the industry, and then you can submit and present and bring about a consensus before you can reach the stage of contributions being included into the standards. Now, there are certain challenges, and I will just highlight some of them. Before actually, and since in this session we are discussing the topic of how academic institutions can contribute, while they do a significant amount of research, there is a need for alignment between the industry and the institution's research priorities. There is a limited availability of state-of-the-art facility, including the experimental test beds to verify the ideas. We also see the lack of knowledge and motivation towards participating in standardization bodies, because in academic institutions, typically there is a more focus towards publication in the research journals. We also need to find support for participating in the standardization meetings, which happen throughout the year, and therefore there is a funding not only for doing the research, but also even for participating in these standards meeting and contributing. And of course, you also require the coordinated teamwork to develop the standardization oriented solutions. So all these are actually the challenges which actually need to be really addressed before we can really see a large scale participation from the Indian academia into the standards bodies. However, as we have seen, we have few groups in the country which have done some work. You saw in the previous session, IIT Madras, Professor Bhaskar Ramurthy, CVIT, IIT Hyderabad, and my research group at IIT Bombay. For the past 15 years, we have been working on research problems towards scalable service-driven architectures. Actually, our research focus is more on the core networks and the network protocol stacks. Our group doesn't work so much on the physical layer or the RF aspects. And in this context, we have looked at the problem to design a scalable service-driven architecture. More than 20 PhD students and a large number of MTech students and master students, more than 100. We have had several publications and 40 plus patents. And we have been continuously interacting with the industry for the inputs on the research directions. Now, some of these research, and I will just tell you sort of our journey. We have taken it, some of these research problems having both research and industry relevant components to make those contribution to the standards. We have made it part of the various implementation projects, and these projects have been mostly in the area of the network protocol stacks. And our research staff and students have been continuously participating in the standardization body meetings. Now, before I sort of give you some samples which have been recent, for a long time, we have been participating in IEEE 802.1 carrier Ethernet groups. That those time, there used to be provider bridge Ethernets, then what needs to be called as the carrier Ethernet solutions. and we have had several contributions in the area of protection and restoration in the carrier Ethernet space. More recent, we have been contributing in two IEEE standards. One has been on the SDN-based architecture for multi-rate wireless networks, which is IEEE 1930, and I will talk about that. Another has been on a network architecture for a rural broadband communication, which is IEEE P2061, which will go to the balloting soon. We have been also looking at the broadband broadcast convergence in terms of the broadcast offload, the NTN integration in the 5G, and also in the enhanced relays and a service-driven architectures. Let me just give you a case study of a IEEE 1930 standard. This is the first IEEE standards which has come out of the Indian efforts, and our group has significantly contributed onto this. This started with a research on developing a software-defined networking-based architecture for a multi-radio access technology wireless networks. By multi-radio access technology wireless networks, I mean a heterogeneous networks where you can have a Wi-Fi, cellular mobile communications, even a broadcast radio heads, and you have actually a common SDN based controller for controlling all these networks. This was started way back out of my one of my PhD students' thesis in early 2010 or 12, and finally in 2014 or 15, when the SDN-based controller started coming in the core network protocol areas, we decided to take it up in IEEE for standardization of this concept. So a project authorization request, as it is called in the IEEE standards parlance, was submitted in 2016, and it was approved in November. After the it was approved in March 2017. A working group was formed by IEEE in September 2017. One of our research group scientists, Mr. Pranav Jha, who was the working group chair, and he's also led this standard. And since September 2017 to March 21, it took 4 years to work on this standards. After multiple stages of review and balloting, standard was finally approved last year, and that got published in September 2022. So this actually just gives you a journey of some of the ideas which actually germinated out of 2 of my PhD theses, and 3 of our MTech theses went directly into some parts of this IEEE 1930 standard. The other one has been a P2061, which is actually defining an architecture for the rural broadband. Again, as I mentioned, that since my work is focusing mostly on the service-driven network architectures, we are not focusing on so much on the air interface or physical layer or the RF. So this actually also defines a service-driven architecture which can actually integrate the 3GPP, 5G, or even 5GI, and so on. This was also came out of the research of 2 of our PhD students, and I believe that this will become a standard in this area. Some of these concepts of the service-driven architecture, we are actually now taking it to the 3GPP also for defining a core network architecture for beyond 5G or 6G networks, which can incorporate a very novel concept of a disaggregated RAN and core networks. So these are, some of the examples I gave where, we have taken some of the research which has resulted into both publications as well as standard essential patents and contributions to the standards. But as was mentioned even by the earlier speakers, this has been a really difficult journey. And as I mentioned, that this not only requires a research which is relevant for the industry, but it also needs substantial investment in terms of funding to attend such meetings and contribute. I believe that industry's support for such efforts for the academic institutions can make a big difference in scaling up these activities to a much larger level, where we can see large participations from different universities and academic institutions. We also need some efforts to expand the knowledge and education about standardization process. We need to actually, because it is not just a question of research, it is also the question of, and it is also not the question of orienting the research towards standards, but it is also a question of educating our researchers about processes that are there in different standardization bodies. I know that we have a TSDSI platform, and I would really urge the TSDSI to hold these kinds of workshops to educate our academic researchers about the standardization processes. So the research and the orientation of the research is of course one thing, but even the standardization processes also, required to be sort of taught. And finally, of course, I would say that academic institutions need to reorient their research focus on standards contributions and translational research, along with the publications. I believe that joint effort with, and in this context, I would view this workshop is really a right direction. I hope the momentum generated in this workshop can be sustained both by the TC, CDOT and TSDSI, where we can take this forwards for ensuring the larger participations in the standards. We just need, not in ones and tens and twenties, given the size and population of our country, given the size of the market that we have, we need the contributions of hundreds and thousands in order to really make an impact. We cannot be just satisfied with ones or twos or tens of standard essential patents. If we want hundreds and 200s or 500s, then we really need thousands of researchers to be contributing to this. And as I said, this requires substantial investment, substantial team efforts, and then only it will be possible to make a global impact and a global visibility, and for bringing India-specific needs and IPRs into the standards. So thank you very much. I think I hope I could make some points here. Thanks.
Thank you, sir, for highlighting the key role of academia in building a standards community. Our next speaker is Professor Krishna Sirohi, who is currently Professor of Practice at Bharti School of Telecommunication, IIT Delhi, and contributing towards setting up new dimension of academia-industry collaboration for cutting-edge research translation and the development of field-testable deep technology solutions aiming to meet the emerging national needs. Prior to joining IIT Delhi, Professor Krishna has a long experience of 33 years of research and development in the field of telecommunications and defense communication products design. It's an honor to have you here, sir. May I request you to please deliver your talk.
Good afternoon, and thank you very much for this very detailed introduction. So my view on the standardization activity may be a little different than what has been presented so far, and primarily because of our national aspirations are the volume. We want to have a global leadership in 6G. We want to have 10% of the patents owned by us. And so there has to be a very significant volume, very sizable volume, to take our proposals to the standardization bodies, and so that finally that debate, which was very clearly described by previous session, both the professors, we should get some good number of patents, and those numbers should become essential patents also. And so this is just focusing on standardization is possibly not enough. I think we need to focus more on a bigger goal, and that goal is possibly the self-reliance goal, right? So that's what I'm going to lead few concepts in this direction. And so the question is how we from academia can really build this standards community. And my idea is we cannot really do anything unless academia build advanced technology solutions, and that to be which is ahead of state of art. Just focusing on the standardization and our significant, we are making a very significant impact so far. No denial on that. If I consider academia and industry together, the contribution from academia into this space is very sizable. But where we want to be in the next 3-4 years, because after 2027, say it, 6G window will be closed. So a window is open only for a few years. And so that what accelerated rate we need to carry out our activities is sizable. So from that angle, I think we cannot help. But if we focus ourselves to build the solutions, complete solutions, then yes, it is possible. Now, how we can build these solutions? These can be done in a collaborative manner. When the industry come forward, work with us, industry has got a capability of developing state-of-art solutions, then we academia can bring that solution ahead of state-of-art solutions. So we know how to add the upcoming research as an integral part of the product. Even before the standards happens, we can at least bring these products to the market which are ahead of this other solutions. So this, if we are able to do that, then of course this capability or this initiative of developing solutions ahead of state of art will make nation self-reliant, and of course standards community would also get built. Now, this collaborative and would certainly need to refocus our academic position. The research must go beyond publications, and when we talking about beyond publication, so this is the focus of industry academia collaboration, which should do a focus must be from the day one on this research translation activities, so that these products, this should turn out to be a product which is field deployable, globally competitive, and of course a multidisciplinary in the nature. So unless we focus on these aspects, our research will not really be that fruitful. And with this, we will have these objectives which more relevance to the research, creating an experimental setup which is needed to develop these products, and of course verifying our standardization ideas in time, and so the products come up, and of course it becomes a fruitful source of many startups to come up out of these technological assets. Right. Now we look from the certain perspective from the 6G, whatever it is. It's not defined, but of course the global views are available in some form or other, right? So if you look on this, that there are some deployment patterns which are shifting. Now these deployment patterns are from global to regional to wide area. These are the very common up to existing generation, the past generations. When we reach 5G, then there's something called the local specialization, which is a confined wide area or really a local area. So this technology, the cellular technology, which was wide area technology, is now entering into a confined wide area or confined really local area. And this is something you are creating a solutions utilizing that wide area technology, but for a local applications. And what we commonly know is the private 5G networks. So that this private 5G network is a reality. Now, whether this 5G private network should be supported by the infrastructure of service provider or owned by the enterprise owner or something, those are different things. But the fact that this technology would be utilized for the campus wide requirement or the really local area wide requirements is truth. Now, this trend will go further in 6G, where you will have hyper local specializations, and this hyper local specializations means you will have a new strategies of these products to be developed. So what I'm focusing, I'm not bothering about how the patents are coming up. I'm bothering for those use cases which are not yet addressed by the technological solutions, and so that we should identify and how those solutions can be built by the newer technologies which are likely to be 6G. Right. So if we take this as a major focus area, so our research would be application driven research, and this research will lead to innovative solutions, and these solutions would meet the national needs. When if my TSDSI, for a moment, let me forget that TSDSI is a organization partner of a 3GPP. TSDSI is a national standards body. So if there are some standard solutions coming up for this, without bothering how it finds place in the global standards scenario, can we make those solutions at the national standards? And if this gets adopted in national at wide scale, we are 1/6 of the world, then I'm sure some of them will become global standards as well. So what I'm pursuing here is, let us focus on a bigger goal. And all these faculties which is required to develop these solutions, from the product conceptualization, standardization, development, implementation, and all that. So this all need to work together with much harder goals. But the final goal is actually our own products, removal on the dependency, or minimizing the dependencies on the foreign solutions. Now, from where these ideas will come, we very clearly know that 5G has already done some amount of overlap between these three worlds, which we know as the physical world, digital world, and the virtual world. Now, the amount of overlap between these three distinct worlds is decided by what is the capability of the communication networks you are having. So if you have a real-time capable, low latency, reliable communication, then the digital world becomes capable of controlling the real world in a real-time manner. So that means that this will make your overlap between digital world and the physical world more. Now, so creating these overlaps, more and more overlaps, and talking about a scenario of a virtual world where I'm getting trained in a virtual space, and the same person is working on the physical machines to repair. So that means this aspects, when we took it in a different fashion, we get a new product definitions. And those new product definitions, when we as researchers find out that, look, some of these solutions can be made by the, say, 80% available building blocks, but 20% something need to be done afresh. And that 20% is a feed for my research. And if I can build these solutions where almost in the same timeline, based on the available technology building blocks, I'm developing a solution, my parallel the research is going on. So it's a coordinated effort. Then without losing any time, the research is integrated into the solutions, and that gives me an opportunity for a solution coming out which is ahead of a state of art. These are the various stages when you talk about the solutions, that in research we are ideation level, we do a verification of our result by simulation, and possibly this is good enough to publish, and most of the time our research ends after the publication. If I need to go for experimental level, you need, as Professor Abhay says, that you need to have very advanced experimental setups. which are normally missing. So we have to create parallelly very advanced experimental setups so that those research can be validated on experimental setups. Then it can be verified in a complete network settings, and all, of course, you can do performance optimization and all that. And when our research publication goes after subsequent stages, I think it has much more value. So since it's a multidisciplinary, and many of these disciplinary areas, of course, we do not have sufficient solutions. Even many of the things, even globally, the sufficient solutions are not there. So that is actually a race which is going on. And of course, academia, along with the industry, must pick up many of them. IIT Delhi has picked up some of these areas to work together, right? So what I'm trying to say, let's look at the sequence in which we can we think of working for an effective goals. So if we create number of center of excellences which are domain specific, then this domain is specific. You have experts which are of a domain. We create the requirement, we translate the requirement into engineering requirement, we identify which are the material for the new research, and which can be done by the new technology, right? And this is the way we reach out to a deployable POCs. And once these deployable POCs actually goes successfully trials, then we really come to know what we need to do more to make it mass deployable, and what is the good candidate out of which should go to the standardization contributions. And possibly out of this, when we have experimental pilot results with this, when we go for the standardization, our other colleagues would know better. When we take our discussions with this deployment related results, and then we are much more effective. And there's a good chance that we get more success in our proposals. And the 10% will not come without experimental verifications kind of proposals we take to the standardized body, right? So I picked up some of these examples. I think we don't have time much, but these are the certain areas where solutions do not exist. So we need to work. So 5G today is deployed, but in 2 years, 5G is going to be a dense network. The kind of problems these service providers are going to have will not be really solved with the current product manufacturers. There has to be a mechanism to prove something that where these algorithms are failing in those conditions. So these are opportunities for us to detect the problems of a dense network and also solve the those problems. And if we start solving, there's truly a feed for the research. If we can develop some improved algorithms, then those improved algorithms would be needed by all equipment manufacturers. So whether our product goes into the Airtel or Geo network, but at least in future, our solutions would somehow start fitting into this as enhanced algorithms, right? So these are some of the other examples we say which are unsolved, right? We have very difficult terrains, and we need to have a advanced communication infrastructure. We need to have a very detailed monitoring of various aspects of these areas. These areas are strategic for the country. Now, how communication technology with sustainable energy aspects, whether it is NTN will solve the problem, or I need to have autonomous vehicles flying over it, whether I can put those sensors which requires zero energy, zero battery. If it is a zero battery, then how I'm going to solve them. So these are the various. Maybe you need to wake them up by some mechanism, charge them enough so that by next time when this communication capabilities comes to them, then they once again wake up and start communicating. So various such research. These are not yet solved, these problems. I think these are our crucial problems, and we need to work on that. And this chart shows how the complex problems where one side you're reducing the latency of the network, other side you demanding the higher reliability on the network, and then you have too much reliable and very low latency. What is the kind of a new solutions you will be able to generate? I think these are the areas in which, when we start focusing and when we target to be the world's number one in some of those solutions, then of course the innovation will happen, and certainly we'll have materials which is good for patenting. I think I'll stop here because I'm rushing on time. Thank you very much. So if you, I was motivated to share one more fact in continuation of Mr. Mittal's talk in the previous session before lunch. We were remembering the WTSA, which is World Standards Authority or ITU body. So year 2000 in Montreal WTSA, CDOT had the vice chairmanship in that. A new study group, which was the first mobility study group in ITU was formed. And I, as a member of CDOT, was representing as vice chairman on that. And this study group, two major things happens, and they are still valid today. That this mobility group created the mechanism how standards developed outside. 3GPP was recently formed. So how 3GPP standards should be adopted by ITU. So those frameworks were done by our team. A second, which was very popular in last 20 years, is alternate approval process. The AAP was created by our team then, and one of the very important ITUT recommendation which we led was Q.1761 on principles of mobile and fixed line networks. It came. So we created some base there, but of course, Indian contribution prominently started working only after 2010. I think we are at a very right place now. Thank you very much.
Thank you, sir, for bringing to the fore the critical need of synergistic collaboration between academia and industry for building a standards community. Our next speaker in this session is Professor Manoj Chaudhary, who is currently working as the founding Vice Chancellor of the Gati Shakti Vishwavidyalaya, Vadodara. Professor Manoj Chaudhary is currently on loan from IIT Jodhpur, where he is a professor of electrical engineering. Prior to joining academia, Professor Manoj has had a very vast experience in the technology industry as a lead technologist and business leader, having worked with the top electronics, semiconductor, and telecom companies like Samsung Electronics and Texas Instruments. He is also an invited member of the 6G Task Force. We are privileged to have you here, sir. May I request you to please deliver your talk?
Good evening. After a lot of discussion the whole day about patent, standards, my talk to talk about academia ecosystem and standards. And let me tell, I am in academics world formally only for last 2 years. 21 years I was in industry, and that experience is something that I want to talk today on what can be done. 20 years back in 2003, I attended my first 3GPP standards meeting. It was a system aspect group, as it was called, SA2 meeting. And the topic that time, which was burning topic that time, today it looks very old, is how 3G and wireless LAN could interwork together. Right? Those were the days when 3G had come, wireless LAN was coming. As you enter the home or an office, how seamlessly 3G and wireless LAN can interwork. And subsequent to that, I had an opportunity to create perhaps India's biggest or largest standards group in Samsung that took part in IEEE, 3GPP, 3GPP2, Open Mobile Alliance, IETF, Wi-Fi Alliance, Multiband OFDM Alliance, Media Alliance, you name it, almost all the various standard body, including Connected Car Consortium, FIRA Consortium, and so on. Therefore, the experience that I have is something that I'll talk. Firstly, to start with, as everyone says that there are billions of research papers, not all are useful. Right? They remain in the libraries, in the journal books. Let me also tell, similar is the case for most patents. People get a patent as an ownership right, where they claim ownership right over what they can build. Does not mean the thing is actually built. Patent in some sense is also a negative right to prevent others from using the same invention without taking permission. So most of the patents are also actually not used. You have that ownership, it remains as an ownership title with you. Same is the case for standards. There are plethora of standards that exist in the world. Most of them are not used. Why they are not used is something that let us start having a discussion. They are not used because by definition, a standard is something like an operating protocol that allows vendors or equipment makers to create interoperable products. So unless there is a large ecosystem that is available in the market who will build product based on that particular standard, that standard is more or less a useless standard. You will find plethora of such standards existing and nobody is using. Therefore, the summary that I want to highlight is a standard success depends on the ecosystem that uses that standard to deploy the products based on that standard. Otherwise, standard has no meaning. Today, why India is talking about standard and why such a discussion I try to contemplate. As we focus on Atmanirbhar Bharat, as most of our companies in India try to develop their own products, we want to develop products that do not remain in some shelf because of fragmented market if they do not adhere to a standard. If we build a product that adhere to a commonly accepted standard, then that can be deployed all over the world. If we build a product that is not part of the standard, then it is a fragmented market. You have a very small market size for that kind of a proprietary market. Number one. Number two, we want to play the standard game because if only we participate in a standard body at the same time that we are developing our products, we can be in some semblance of a leadership position at any time. Otherwise, if a standard is already made and we are making a product based upon that, we will always remain a follower. That is precisely the point of all this debate about why India should lead standards. As we are trying to develop new technologies, we must try to ensure that interoperable products are made from India, by India, based on India's innovation, which can be there in the world, in the entire market as a marketplace. With that as a context, now let me tell a happy news. I have only one slide. Right? But the slide is loaded. I will utilize only some of the points. Today, the discussion I try to assimilate, the discussion point is we want to move towards an innovation-led, India-driven standards for the world that facilitates and enables democratization of emerging and new technologies for the mankind. Whether today focus is telecom, but this is what is our push. And we are living in a paradigm, and that paradigm is what I define. Today's world, if you see particularly technology world, is we live in a paradigm where winner takes it all. Now, by winner takes it all means in technology world, you will see in any space only 2 or 3 companies maximally existing, surviving, and progressing. All other over a period of time from that space will disappear, whether you take of search engines or whichever technology world you take. Telecom, you can always talk about top 2 or 3 companies, and then there are many others who are playing. Therefore, today's game of technology is a game of winner takes it all. So either we play and win, or we are just one amongst others who will just be a follower. It is that context that we have to see when we talk about standard. Firstly, whichever company try to play the standard or try to build the standard actually are the companies or the countries which are building the product at the same time or ahead of that, not after that. And currently, this is what we want to do, is what I highlighted in the blue point. That is, first point I want to highlight is, in order to be successful in the standard game, we have to focus on implementation of that standard along with what we are trying to do in the standard body. Doing an implementation post facto, actually, more or less, we will be in the same situation. The four different elements that I want to talk here is, firstly, on research, that of late, great things are happening. 20 years since I attended a 3GPP meeting, and I can say with a lot of confidence, India is changing, India has changed. Let me tell why. Let me tell a small story without naming anyone. In 2003-4, when the world was starting to talk about 4G and 4G requirement, there are many interest groups that come together to look about what are the requirements, how technology build. I'm trying to share a story which is a true story. 3GPP or IMT, all those things will come. Meanwhile, there were also groups like Wireless World Research Forum. They were trying to gather requirements with players from Europe, Nokia, Samsung. Many people were coming together to look at 4G requirement. They organized one meeting in Jeju Island in Korea, together with all. And I was one of the organizers that time, trying to work from India. They requested, can some leading professor from India attend the meeting and share India perspective? I talked to a leading professor in India at that time, and he blasted me. He told, we will create our own India standard. We don't want to talk to Nokia, Samsung, Motorola of the world. I felt, he blasted me. He refused to go. That's a different part. I found another one who went. That's a different. I felt that was a false sense of jingoism. Chest thumping when we did not know. If we have to win a game, we have to be part of that game as a player. We cannot sit outside as an audience and see how the game is getting played and then try to think that we will win the game. Today, the situation, as I said, India has changed. Today we are talking to world over. We are talking to America. We are talking to all over, trying to win a game by being a player in the game. And therefore, I say that a lot of things have changed on how academia industry viewed each other 20 years back to what they do today. And that is the basis of my confidence that some things that I talk are workable and will work. With substantial government encouragement, significant improvement in our own academic system, a lot of high impact research is already happening on 6G, quantum, many such areas that we look. Our institutes have started to think more about interdisciplinary nature of the work. That is a very positive thing that is happening. What that means is that no one system can be built only by one group. And in a complex standard game where you are looking at a system, it is very, very important that you leverage all the strengths that are available, which are complementary skills. We are focusing on top quality research with substantial funding. Therefore, a good ecosystem is already getting created, which is a necessary input, not the sufficient, necessary input for the standards. Now, if today we are talking, let us do more from standards, more on standards from India. Let me ask one question that all of us should reflect. How many of us in academia or in this audience actually can read and understand a standard? Not many. Not many. Reading and understanding a standard to be able to perhaps test the system whether it is built according to a standard, maybe yes. But to understand why a standard made a particular design choice vis-a-vis plethora of alternatives that existing earlier is a whole different game. Today, if somebody asks why 3GPP succeeded, 3GPP did not, 3GPP2 did not, not many people may know. One can always say Qualcomm was there, but Qualcomm is here also. But there are many reasons one can talk. For example, different Wi-Fi standards evolved. Why only a particular variant moved ahead and remaining did not? Those design choices is what I call understanding of the standard. Understanding of standard is not merely what is written that a system can be built like this or will behave like this or behave under this condition like this. Understanding a standard first means understanding design choices amongst various alternatives that are available. So the first request I'm making to us in academic system and to industry is operate a standard cell in every institute that will, at the minimum, train people on related topics. For example, wireless. Within wireless communication topics, if people are teaching, our professors, our faculty members, our PhD students, they should all know why a particular design choices of a particular modulation scheme and a particular error control coding was chosen for this standard and not for that standard. That is a design choice. If it is purely wireless, why cannot everything that was done in Wi-Fi be done in 3GPP? No, because requirements are different. That is what I come to the second point. Requirements. Requirements means anticipating what will be needed 5 or 10 years down the line and looking at your research and research outcomes that will fulfill that requirement. In some sense, it is stargazing. Like 10 years before, if somebody says that in India, we will have bullet trains that will be running maybe 300 kilometers per hour, we will require mobility to operate at that level or that speeds, people would have laughed, but that is a requirement. And therefore, our mobile systems have to be made that can operate at a mobility speeds of such scenarios. So that is a requirement. Every next generation, there was a mobility speed that increased. Why it increased? It increased because of the requirement. Therefore, the second thing that I highlight is, before we start defining what the standard will be, first we have to understand what the customers or stakeholders mean or require. So understanding of requirement is very, very important. Sometime in academic system, we are very good in solving a problem if a problem exists. Here, the goal is more on defining the problem, not solving the problem. Problem can be solved, but it is about defining what the problem will be 10 years down the line. And we do a research according to that. When, for example, now 6G's discussion happened that, okay, for 6G, we have been able to define mission and so on, right? First thing that people agreed there is what requirements 6G should fulfill. And it is based on those requirements, every single proposal henceforth, every single research will be done in order to meet that requirement. To be able to anticipate that requirement is the most essential part before even we think about what we will do to the standard. So that is where I mentioned. The third point I highlighted in blue color is key performance indicators for the requirement. Most of our research is very nice, advanced. We build functional prototypes. It was also mentioned POC. POC, what I call is functional prototype that indicates new functionality, new things getting developed. One level up that academia can do in partnership with industry is on transforming that functional prototype to a product. Because moment we talk about product, there will be performance considerations, there will be power considerations, there will be whole lot of considerations that will be put which are needed for a prototype to work in a product. So most of the prototypes are also, if I have to say, showcased, demonstrated. In newspaper it comes that XYZ developed and this thing, it will change the whole world, and after that nothing happens because they do not end up getting converted from prototype to a product. Therefore, key performance indicator for that requirement is an important thing for that research to move from a prototype or POC stage to an end product stage. It only if we are able to do research that can meet those key performance indicators is when we can take those kind of research or those kind of outcomes to a standard body. Because in a standard body, the question and the discussion that will always happen is, can it satisfy broad set of requirements that we agreed upon or those performance parameters? Third, I want to highlight, I think, industry-academia relations. Just one key point I want to mention. Of late, industry has been coming forward. And we also hear everywhere, every institute is gathering or more and more funding support from industry. The relationship so far has been give or taker. Industry will give money, academia will solve the problems and give. I propose that this giver-taker relation has to change to a co-create relation. Otherwise, Otherwise, prototypes will be only prototypes, cannot go forward. Therefore, we have to move from a giver-taker model to a partner and co-creator model is something that I wish to highlight here. One of the very important point I think earlier was mentioned in any standard body, irrespective of whichever body, is negotiation. By negotiation, I mean it is not merely the strength of the proposal that I present, for example, before standard body, but what backdoor social I do socializing with the many stakeholders who are participants of that standard body, that they are willing to accept the idea. So negotiation is also an understanding of what are the strengths of my proposal vis-a-vis other proposal, and how can we assimilate the best of all the worlds to move forward. Therefore, having an adaptable approach, negotiation is also having an adaptable approach that we assimilate ideas from many people, because all players who come in the standard body have their own way of solving the problem. Finally, a consensus will be built based upon what kind of negotiations or discussions you are able to do backdoor, socially in different forums, on different other groups, because all the standards are interlinked to each other. They also do not operate in isolation. One of the body will send a mandate to another one. You will get requirement to another. Therefore, in this interlinked world, the game of negotiation is also very, very important one. Is something that within the academic communities we need to learn and appreciate that this is actually a game. Choose the standard body wisely. I told, because there are too many of them. We neither have the resources, not have the money power, not have the too much of a time, because in academia, all faculty members also teach a course that runs a semester as per a schedule, cannot travel to US or Europe or every now and then. And therefore, we have to also choose standard bodies wisely where we should put focus. Each standard body also has a different context. They have a different voting rights. IEEE, for example, have individual members who can become voting members if they attend few plenary meetings or some meetings in a succession, right? A 3GPP is more like an organization game. So each IETA, for example, runs more on online mode, right? So each standard, so this part is important, because should it come to voting, our voting stance should also be made politically from now. After 2 years, for example, from here a proposal is presented to 3GPP or IEEE or wherever, right? And the proposal is good. We have to also do a lot of background work, as was discussed earlier. And should there be a voting, we should be able to garner enough voting members from India who can help us there. Last point, I want to highlight here is we have to focus on the outcomes. One significant standard proposal accepted can be much more than hundreds of contributions that are made, which may be optional, editorial, so on and so forth. And therefore, we have to focus on outcomes, not merely on output. And I am very confident if from India, multinational companies could have many standard members who have become chairmen of standard committees within India, Indians, whether from Intel, Samsung, Ericsson, wherever. Why we cannot form a strong standard group from India with the collective strength that we have to move forward with goal? And that's where I'll stop. I'll be happy to answer any question. Thank you.
Thank you, sir, for highlighting the importance of leading standards and innovation with focus on the emerging needs for the larger benefit of the society. Our last speaker of this session is Dr. Akhil Gupta, who is currently an associate professor in the Schools of Electronics and Electrical Engineering, Lovely Professional University, Punjab. His research interests include physical and network layer perspectives of 5G and 6G communications technologies, such as device-to-device communications, massive MIMO, cognitive radio, and ultra-reliable low-latency communications. He's also working on the security issues of next-generation networks. It's a pleasure to have you here, sir. May I request you to please deliver your talk?
Thanks for the introduction. And first of all, I want to thank Shri Avinash ji for identifying us and giving us this platform to put forward our ideas or whatever thinking about this in front of you all, and giving us this opportunity to present among all that what we think that what need to be done for the academic institutions with the industry, what need to be done. So the topic is how academic institutions can help build a standard community. Since this is the same topic and I'm being the last speaker in this, so most of the stress points are already being covered by esteemed presenters. So they have already touched most points. But my point is, the first main point that I want to discuss is that awareness that is there. So the most of the important thing that is lacking in the university or the academia system is the awareness about the standardizing bodies. So first I want to say that in the last 2 to 3 years or the 5 years, the awareness about the patents are also being increased. But before that, the awareness about the patents are also not there. So if I'll say, if we have published so many publications and we have got so many ideas that are stored in the publication, those are stored in the journals, in the shelves, like Professor Siroi has said, they are already there in the journals, but they are not patented. And if they are not patented, they are not moving towards the standards. So how they are going to move towards the standards? So first, the awareness should be there in the academic community, so that if we are focusing more towards the patents, and then we can think about that how we can move take them towards the making them the standards. So if I'll say, I will give my example only, that I have filed my first patent in 2015 on the 5G, but that is a way earlier. So at that time, I know how to file a patent, how to write a patent and all these things, and I have filed a patent. But at that time, we are not having that much collaboration with the industry, and we are not been able to convert that patent into some standard. So the lack of awareness is the main issue. So what we can do, my presentation is somewhat different from the others. I'm focusing on the awareness. So we should focus on the awareness that need to be given to the academic institutions. So first we have to make them the standards that are needed. So I need not to cover these things because these are already being given by the whole complete session of the day. So we are moving towards for the next. Since we know that we are the second largest telecommunication market, we are first in the population, and by 2025 we are, this is a news article that I am referring, there is a need of approximately 22 million skilled workers in 5G and centric technologies like IoT, AI, robotics, and cloud computing. And all these points points to a dire need for Indian participation in global telecom standard bodies, so that we have to promote Indian specific requirements and standardized solutions for meeting these requirements. Why I'm saying Indian specific requirements? Because India being a diverse country, we are having multiple use case scenarios. The use case scenarios that are mentioned in the research papers can be the part of the standardizing bodies. But because of the lack of awareness, we are not converting that thing into the standard. So that is the main disadvantage that the academic institutions are facing. Now, if I talk about what are the benefits of the standardization, we already know it, that it improved interoperability, increased innovation, efficiency, and scalability, systematic cost saving, enhanced security, global market access, and guaranteed future proofing. Now, if I talk about the key enabling technologies that we have already seen, like 5G enhancement, we are going to move towards it, or we are moving towards the 6G. Or if I'll say, generally we're talking about artificial intelligence, machine learning in communication system, but we have to focus on applications of AI and ML in the communication systems. Because if we focus on AI and ML applications, then we can have so many opportunities open for filing for the patents and for the standardizations. Then if I talk about smart communications, it's smart communications as well for the smart IoT communications and smart machine-to-machine communications also. So if we are moving towards these kind of key enabling technologies, there are so much possible use case scenarios that we can focus on, we are working on. Now, if I'll say in the academic community, there are MTech students, there are PhD scholars, those who are having a proper committee is verifying their topic, and they are showcasing their this objectives that these need to be worked upon. So if that objective, there are so many chances of getting that objectives to be patents or to be the standards. So there are so much opportunity there in the academic institutions. Now, if I talk about UAV-based communication, so I just want to give you a small example. In the morning, I heard Professor Subramaniam that he is saying that a small idea, don't underestimate your small idea. That small idea can be a bigger thing. So if I say, I've seen the standardization of TSDSI, the UAV. So I've seen that they have seen that if we are using a UAV for the communication, what should be the height of the UAV, up to which range it should be moving. So these all things we are focusing on. But if I'll say that in a PhD thesis that I have guided, I have seen that we can also focus on, like if we are incorporating the massive MIMO on the base station, we are having multiple antennas on the small cell, then what are the number of antennas should be there on the UAVs? If we are thinking about that, that can also be a part of standardization. But if we analyze that, if we have simulated that or put an algorithm about it, we have implemented it, we have published it, we have filed a patent for it, but how we are going to prove that thing? So in that case, if we want to prove that thing, we need the industry to collaborate with us so that we can prove that thing, that the work that we have done is actually possible, and that can be used in, that can be the part of the standardization also. Since we are having a blockage, if I see the person who have shown the intricate research, those who represent intricate research, they have shown the steps what you are following for having a standardizations. So what I have seen, that we are on the halfway. We are only filed the patents and we are not moving towards the standardizations. So that's what it is a request on the open platform that industry should collaborate with the academia. There are so many brilliant minds. We are having so many population, so many engineers are coming out of India, and they are having a great idea. So if industry are going to collaborate with these great minds, then we can have a very good amount of standardization coming in the 6G. Now, how we can do that? If for academic institution, how we can do that? We have to make this standardization as a part of human learning process into the system. We have to incorporate standardizations into the curriculum for the undergraduate and graduate students, because most of the undergraduate and graduate students don't know about standardization. If they know about the patenting, that is a very good thing, but they don't know about the standardization. So if we are incorporating that information into the curriculum, then they know that how standardizations are going to be made, because most of the things that are coming here, how we can go for the SEPs, that maybe I am not aware about that. So how we are going, no, sir has also told me that if you are having, your institution are having so many patents, why you are not having a standardizations? So if we can say that we are having a patents, but how to move that patents towards the SEPs, how to make them the SEPs, we are less aware about it. Now TSDSI and CDOT has given us the opportunity to make aware about this to the students and to the faculties and to the researchers, that how we are going to move towards this better approach for making a patent in converted, or an idea converting to be in their standardization. So what are the learning stages we need to follow for understanding of a standardization, or to make a standardization? So first, what we should have a good understanding of the standards, that we should know what are the key aspects or the key components of that particular idea, or what are, if we are focusing on that idea, what should be the trade-offs that need to be taken care of. Then we should focus on the design of the system, that if we are designing a transmitter, receiver, then what should be the standard specific transmitter and receivers, how we are going to do that. And if we are designing something, then we have to focus on that what are the key parameters or key performance parameters need to be taken care of, like synchronization, throughput, latency, and spectral efficiency. Now, the third step is defining the test and the figure of merits. If we are making certain thing and then we are going to test it, what should be the figure of merit? How we are going to evaluate the performance, and the confirmation tests need to be done on that particular system so that it can become a standard. And then we can implement it, but that here, implement and testing, that the industry, we need a role of the industry in it. We are doing certain research work, we are filing the patents, we know what we are able to do it, but because of the lack of the infrastructure and a lack of the support from the industry, we are not been able to move to that particular stage. So I have 6 stages of the learning, but here I am stuck into the 3rd stage. So I want that if industry is collaborating with us, if industry is ready with us, so we can move towards the implementation and having a standardization up to the 6th learning stage. So next one is the review and the product and process, and demonstration and product and process. So that is being explained by the other keynote talks, those who are explaining about the patents and the standardization. So they have very well explained about these things in their presentations. Now, so what we want, so what's our point is that what we want, academic institutions want. So academic institutions, we want a collaboration with the industry or with the government bodies. So first, what we can do, there are certain proposed solutions that we can have. So let's see how many can be happening. So explore and identify common avenues of interaction with industry. Like here, we are getting an opportunity here in this one. That is one of the things. Then establish convergence with industry and research organizations from various fields through MOU as a form of interaction. Then establish center of excellence by industry corporate to provide real-time exposure on the technologies, like sir has said. Then to give industrial exposure to faculty members and students, thus enabling them to tune to the knowledge to cope up with the industrial culture. Next point is that the visits of faculty to industry for study and discussion on delivering lectures on subjects of mutual interest, because if they know that what kind of work need to be done, they can transfer that information to the students. Then student can visit to the industry, so an atmosphere or an environment is created. So with that environment, we can move towards the objective, that is a bigger objective, we can move towards that. So we can have a practical training of the students in the industries, encouraging engineers from industries to visit institution to deliver lectures, because that will cover many number of students. Then visit of the industry executive and practicing engineers to the institute for seeing research work and laboratories. Now, what we are doing, whether we know that thing that we are doing is right or wrong, or if they are eligible for the standardization or not. So the members of the study groups or working group of industry should have interactions with the selected members of the academia and analyze with them about their approach for providing constructive suggestions with which academia can also contribute in standard making. And last but not the least, creation of state-of-the-art laboratories by the government for enabling R&D by students, faculty, and industry researchers. If they have the capability, if they have the proven some publications or the patents, they should be allowed in that R&D lab, so that they can work and they can enhance their things towards the standardizations. So that's all for my point. Thanks all.
Thank you, sir, for letting us know about the potential of converting innovation in academic institutions into standards and patents. We thank our esteemed speakers for this insightful session. May I now request Shri A.K. Mittal, Advisor TSTSI, to formally present a token of thanks and gratitude to the esteemed speakers of this session. We have with us Professor Abhay Karandikar, Director, IIT Kanpur. We thank you, sir, for your enriching talk. Professor Krishna Sirohi, IIT Delhi. We thank you, sir, for being with us. Professor Manoj Chaudhary, Vice Chancellor, Gati Shakti Vishwavidyalay. We thank you, sir, for your enriching talk. Dr. Akhil Gupta, Associate Professor, Lovely Professional University, Punjab. We thank you, sir. I request all the speakers to please come forward for the group photo. Ladies and gentlemen, we'll now have the concluding panel discussion to discuss the way forward. We just need a minute to convene the session. एक और हटा दीजिए तो कैसे रहते हैं So, ladies and gentlemen, we'll now have the concluding panel discussion to discuss the way forward. We have our esteemed panelists with us, Dr. N.G. Subramaniam, Chair, Telecommunications Standards Development Society, India, who will be chairing the session, Dr. Rajkumar Upadhyay, Chief Executive Officer, Center for Development of Telematics, CDOT, Shri Shrikant Chandrasekharan, representing IEEE, Shri Sharad Arora from Mashbury EdTech. So without taking more time, I'll hand over the proceedings to the chair of the session.
Good evening, and we'll be very brief in this session. I think, all of you are tired, and I think we are even more tired because we spoke earlier, right? So we will try to conclude it as quickly as possible. I think we had a very invigorating day that reflected on the future. Of India. I think Secretary in the morning spoke about the need for connecting India, and in that context, how digital technologies are important, how standardization needs to take the front. And then, during the day, we had several sessions. The whole standardization process was very nicely enunciated. And then it was followed by a session in which people talked about how they went about publishing a standard, what are the hurdles that they went through, and then approach to protecting their innovation, protecting their patents, and how did they identify the opportunity to get the patent to be a standard essential patent. All of that is a process that they went through, and then it's not a straightforward process. It just took enormous amount of time, effort, patience, and consensus building with many people to get to the end goal, which is really about, okay, our innovation finds a part in the standard and our patents have been rightfully acknowledged and marked, right? I think that's what we went through. I think the patents and SCPs, the case studies that Professor Bhaskar and Professor Kiran, I think it was quite an eye-opener. In my opinion, it was very well articulated and wonderfully captured. There are 3 or 4 key takeaways that came up, which is standards have a larger role in making your innovation work. I think, you may innovate, and somebody said that, look, I think I had filed a patent, but then, I didn't have any industry connector. I didn't know how to take it to industry, and then it's still lying somewhere, right? So I think whatever be the innovation, I think if you can somehow get it into the standard, it has a potential to play a larger role. And I think that point came out very clearly. Then we also talked about, standards is a skill. And I think, I'll ask Sharad to speak about it a little later on that. But, I think standards is a skill and it's a competence and it's not a part-time job, right? I don't think that we are doing justice if we are going to do it as a part-time job. That particular point came out. I think then, winner takes it all. I think, that point came out. So in that context, if you don't take the lead, then you will end up being a follower only. So it's time that we take the lead, and we have to reflect on today's deliberation and see what steps that we need to take, how academia, industry, all the researchers, the standards community, innovation, everything is rightfully brought to the fore and joined at the hip so that we go and march towards the goal of 10% of the patents for 1/6 of the contribution for the 6G. I think winner takes it all, and that I think is a very inspiring statement, I thought. And then as we work on innovation, as we work on standards, the implementation needs to be done simultaneously. I think, It's not that you define a standard and then wait for that standard to be, or innovation, and put it into standard and then wait for that to take place, because then you will end up following a standard. So, the product development and standards should go together. And if you are the first one to come up with a product which embraces that standard, innovative, maybe you have a competitive edge. So I think that point came out with it. So with all this, I think, there are about 3 or 4 points which came to me, which probably was not touched upon very nicely. So I'm going to ask one question to each one of you in the panel, sir. The first one is backward compatibility of standards, right? Or for example, 4G to 5G to 6G, as we define 6G standards, the backward compatibility of this is a very important aspect. And that particular thing was not talked about it. That is one first question that I thought that we will try to conclude. The second thing is, I think if we have to work on the implementation simultaneously, how about the whole manufacturing ecosystem? The manufacturing ecosystem which we need to develop, and there's a lot of work going on, but that's again an aspect that we did not spend much time in any of these sessions today. So I think if any of you have a word on that, it will be useful. And then the third one is obviously, or maybe the first one is it's a skill and competence. And I know, Sharad, you have built a EdTech and you are focusing on standardization skilling as a key thing. So maybe you want to start spending a few minutes on that. Then, I would request each one of you to address the other two.
Thank you, Mr. Chairman. And before I start, I must say that my standardization journey started with Mr. Mittal. So I want to just thank him for it. Mr. Madan, Mr. Sushil Kumar. These are the group of people 10 years back who started the journey, and they're here fortunately today. Pamela is not here, another great motivator for standardization. But now coming to answer that question that NGS just put across, I feel that standards for India, the times here, that standard is neither a skill nor can it be a way of thinking. I think standards has to be a culture. When I was taught in Xerox, the leadership through quality program, which was a common denominator across all Xerox people, we learned how to talk after we learned leadership through quality. And the same thing, leadership, the TLPs at the Tatas, I think it has to be a common denominator. The scale that we need to operate at as a country, we need to have standards in BTech, MTech, PhD. So simple, jumping a lot of analysis and research and thinking. A BTech, we used to in BITS Pilani have a program called the semester program. You did a thesis or a practice school. So I think students from premier institutes should come to NWG for 6 months to do a thesis. If they complete a contribution, that should grant them an A grade. BTech students, if they complete a contribution, should get that same that same scale. MTech student, if they get past an A.1 justification or whatever is the equivalent in IEEE, 3GPP, and so on and so forth, they should get that scale. And a PhD student that gets a recommendation to be accepted should straight away get his or her doctoral program. Something like that has to imbibe as a culture in our technical training. And I think one more thing I just want to quickly say, in that same program, when I used to travel abroad when I was very young, I used to cringe because one of the things that hurt me very badly was how we behaved inside an international context as people, as Indians. I saw that entire thing repeat itself when I started participating in standards. We actually don't know the culture of standard, but we want to participate. We need that culture to be taught first. Otherwise, we just create a bad impression. And that actually does hurt the sentiment. It hurts our presence. It hurts our acceptance. So the culture of standard also starts with this education. And that, I think, starts with our teachers and our mentors. So we need a population class change. there is no need for anyone to justify why standards must become the most prominent part of whatever we are developing in education, in TSDSI, in TEC, etc. But I think the education associated with standards needs to become population scale, sir. Thank you.
Thank you, Chair. First of all, I want to thank the audience also for attending this and staying up to so late. I think that shows the interest in the standardization activities. I would just, I have some statistics. I wanted to read it out before I answer those questions. If you look at the SDOs like ITU-T, total membership is 264. Indian participation is 6 out of 264. USA 32 and China 30. ITU-R 272 total membership, India 5, US 34, China 14. 3GPP IMs 818 total membership, India 56, US 99 and China 176. So our presence in the total overall membership in these big forums where these standards are made is quite less. Now this the other membership, the other body which is into standardization, IEEE, the total membership there is 4,09,654, and in that 1,25,000 are students. And here, if you look at the Indian participation in ITU, it is out of, IEEE, out of 4,09,000, we have a participation of 59,000. And 41,000 are students. 41,000 students. So it is close to 33% participation in IEEE from the students. So what it says that there is a lot of interest in standards at the student level, but when we come to the organization, I think standards are forgotten, and therefore these don't translate. If I look at today, I was, introspecting that what we are doing at CDOT for standards. So the guys who are doing firefighting are also doing standards. I think one lesson I learned today: the standards is a different ball game. You need to put a separate manpower for these standards, whose job is only standards. When I was in TRAI, one thing now I am understanding. That time I didn't understand this. When you used to go to these ITUs or 3GPPs, I used to see that sometime I go, sometimes some other advisor going from DOT also, sometimes Shiv Kumar, sometimes Ram Kumar, sometimes Shyam Kumar. But we used to see the same 50 people of Chinese, 50, 60, same guys. They will come exactly in a busload of people and they will dominate the session. And that is why they are able to put their point of view across into IEEE or ITU or 3GPP. Only now this thought process is coming in India that, oh, we should also get into standards. Otherwise, we used to go, to be very frank, we used to go, listen and come back and sleep and come back. The focus has to come now, and that is why I think Secretary Sir was also telling in the morning after this inaugural session that we must send 50 fixed people. 50 fixed people. At least in CDOT, I'll implement it immediately. We'll set up a standard cell. We'll allocate manpower for each of the division. Their job will be only going to these 3GPPs, ITUs, and IEEEs and contribute only to standard, not do firefighting job. So that is one part. Now, sir talked about backward compatibility. I think whether we like it or not, the system what we design have to be backward compatible. If I am designing a Wi-Fi 6, it has to work with Wi-Fi 5, 4. If I am designing a 4G system, it has to hand over to 3G, it has to hand over to 2G. So in some way it is taken care by design, because upward compatibility is not there, but backward compatibility is definitely there. The third part is, sir talked about the manufacturing. I think manufacturing guys, sir, in my opinion, they are hardly bothered about standards, because what sells in the market, they manufacture. I can quote the example of PLI scheme. We have PLI scheme where we give incentive cash rebate of 6% and 7%. Some companies took for a particular product. Suppose they have taken the PLI scheme for product A. They came back after 6 months saying that, oh, there is no market for this. Let me change the product. I want for B. So typical answer from the government will be, no, I gave you for A, you manage with A. So he says, no, A is not selling in the market. So manufacturers primarily look at where the market is there. And finally, we changed that PLI policy. We're saying that, okay, if you are not able to do A within some time frame, you can come back and tell that we will do it for B. So manufacturing is, as I know, I may be wrong, as I know, they care, they will manufacture items which sell in the market irrespective of standards. For example, Wi-Fi 6 is much smarter, much more efficient in terms of usage, in terms of number of users. But the sale of Wi-Fi 6 in India is not happening. People are still happy with Wi-Fi 5. So even though standard-wise Wi-Fi 6 is better, and people are not buying. Same is the optical. I can give example of we initially did our ONT, which can do 1G, 1G, then 2.5G. Then we did XGS PON, which can do 10G up, 10G down. Not even one piece is selling. Even though standard-wise it is very, very ahead, but that there is no demand. Hence, there is no manufacturer which is ready to take the XGS PON, NG and PON 2, even though standard-wise it is way higher. So, to nutshell, what I'll say that standards are very, very important unless until we get into a standards journey. Now, as India is coming up in its indigenous journey, this backlash from the SCP holders will hit us in some way. And therefore, we also have to back up ourselves to generate standards and generate such standards that convert into SCPs so that we also have tomorrow a bargaining power with all these giants so that we can get better off in the negotiating table. Thank you, sir.
Thank you. So it looks like I'm the last speaker of the day. So I will comment on both your points, NGS. The one you talked about on backward compatibility and manufacturing. I have a slightly different view than Dr. Upadhyay. So on the backwards compatibility, standards are largely industry controlled, right? So there is something called a return on investment. So the industry understands that you have to recover the investment you put in, and that investment can be in the form of R&D, can be in the form of people that they send to standards development working groups. So I think it is counterproductive for the industry to not develop standards that are not backward compatible. That means that you have to go back and sell a completely new product that the market will not have the hunger for, right? So it is in the best interest for the people who are controlling the play, so to speak, right, to make sure that everything is backward compatible. And that has been one of the most biggest selling points for 802 technologies, right? 802 technology A, B, G, and they have been backward compatible. And yes, there is one aspect of, I agree with Dr. Upadhyay, if there is no market demand, probably the latest technology will not sell. But certain things, right, your cell phone immediately adapts. Most of our cell phones that we are using in this room are probably on Wi-Fi 6. The access points, the routers are not, and eventually they will catch up, right? But the fact that you can sell all these different pieces of a very large ecosystem at different phases needs backward compatibility. Otherwise, it will be impossible to run a macro system because I will be on a different technology, the other end will be on a different technology, and you cannot change everything overnight. So I think it is absolutely imperative to maintain that compatibility. But I also made one point earlier in my talk when I was talking about standards development. Standards development, from when you look at the starting point, if somebody is coming with a proposal or an idea, it really takes a decade to evolve and market adopt, right? So if I'm thinking about an idea today, 4 years for development, 3-4 years for market acceptance. So really you are looking at a very large cycle. So you need to make sure that not only they are backward compatible, they are in some sense future proof also. The society would have evolved in a decade. Today's decade is a very long time, right? My kids, next generation, they are living in a different planet almost. They want to talk metaverse and multiverse, right? So, but the technologies you are developing has to be backward compatible and future proof. So I think it's very important for standards developers to take cognizant of that. And I think those are the standards which are really going to become successful and hit the market. It's possible that you develop good standards that were for that time, but if it's not future proof, by the time you come to that point of market adoption, you are outdated, right? So those are the couple of points I wanted to make. On the manufacturing side, I feel that we made a lot of good standards, but it was just not manufacturable. So they are sitting in shelves, and I don't think it is because the standards were not good. I just don't think that they got the manufacturing perspective. So you say that there's a fantastic design, just costs $1 billion to make. Manufacturers say, forget it, who is going to, I'm not going to invest $1 billion. Nobody is going to buy my $1.5 billion product. So I think it is imperative, and I think we work very hard, but it's difficult to get the manufacturers. I agree with that. But within IEEE, of course, we are not nation state based, but we are perspective based, and we work very hard to make sure that all user perspective are represented. And one of the user perspectives that we look at is manufacturing, and of course, policy and regulation. Sometimes you can have the best standard. Policy will say, I remember a product which was doing scanning of ultrasound scanning, and then they could determine the sex of the child. In India, it is policy stops that. So that handheld device which you could do ultrasound could not be sold because of the simple fact that they overlooked a policy that was not changeable. So I think these perspectives are very important. Sometimes there are great standards, great technologies that are out there, but when we don't capture all these perspectives, then you don't hit the market, and that's it's a little bit of a shame because of the amount of effort that has gone in, right? So those are my submissions at this point, sir. Thank you.
Thank you both. I think Secretary also mentioned about relay race, right? I think that's again an important point that we need to take into consideration. That look, anything that is there, someone has put in efforts, and let's not leave it. Let somebody else take it and then continue with it, because it may have some value, right? That's the first one. I think the other one which he also said is that this participation and in international standards forums and contributing much more effectively and in large numbers is very important. And he said maybe this workshop would have rekindled the thought, and maybe he said that repeat these workshops, and then he also mentioned about conducting regional road shows if required, right? I think that's a other thing that I just wanted to say. And then someone out there, I think one of the young minds, he said that, look, why are you bothered about all these skills and etc., etc.? Did you try crowdsourcing of standards, right? I think that's not for me. And I think someone who is in the 20s and 30s, when they assume leadership role, I think probably, it'll be great to see how that's going to work. But, it's a very interesting thought. But I felt that I should share this with all of you anyway, right? With that, I think, pretty much we have summarized this. But maybe, if any of you still have the appetite to ask one or two questions, we are ready.
There's just one thing I want to say to Mr. Srikanth. We worked with TC to write a standard for trust registry. We wrote a standard for bootstrapping. It got done in 2 years. It has an effect on how National Trust Center can be set up for us. I think one of the things that I want to just say is that if you have the right leadership, guidance, the right mentorship, standards can go through much faster than the 10 years. So I just don't want people to walk away thinking that it's all 10 years. It can start and finish inside about 6-7 technical plenaries. And I think it can be put to immediate use. So I just thought I'd clarify that. Thank you.
Yeah. So I was not talking about the development life cycle, but mass market adoption, right? 802, the technology that used 802 is in the museum today, right? But and I think that's an interesting point you are making, because the good standards will find very interesting applications that you are not thinking about today. I think that's a very key point, because when people started doing the Ethernet, it was only for cloud computing, pushing data as fast as possible. But today, can somebody guess that who is the biggest customer for our Ethernet working group 802.3? It's all the automotive manufacturers. mobility. So they say that, okay, this can be applied with some changes, right? Not exactly, but they don't want to reinvent the wheel. And then there is a completely new ecosystem that flourishes on the existing standard. So I totally get your point. I agree with that.
Okay, any questions? Anybody? Okay, on that note, I want to, okay. We've got...
By the time she gets a mic, can I make one comment?
Yeah, please.
Yeah. So, and I think Sharad mentioned it earlier. I have been in the standards working standard system for about 20-25 years. When I moved to India about a decade back, it was painful to see that I used to go to the standards working groups. There will be multinational bodies having Indians, but not from India, right? But all the technology is being developed here. But when it comes to standards participation, there will be a standard cell sitting in Europe, sitting in US, you know. So I think as we are doing a mindset change with leadership in India, I think for the multinationals, I think we should also do a mindset change with the headquarters, because they need to recognize that there is a talent here and they have to address that problem where people can represent from India being Indians. And I think that's a very important mindset change that organizations need to go through.
Well said. Yes, Bindu.
Thank you. I'm Bindu Srivastava from TSDSI. The whole day we have learned so much about standards, the processes, and the various avenues of contributing to standards, the challenges, etc. We have three major organizations, standards bodies: TSDSI, IEEE, and the NWGs at TEC. Any thoughts from the panelists on how these agencies can collaborate with each other so that the efforts can be conserved and we can go much faster in contributing to standards?
I can take a shot at that. So, yeah. So, and I think Bindu, you are aware of this. So, one of the things that we have been working closely with the TSDSI and TEC/DOT is doing the roadshow. I think Secretary mentioned it in the morning. So, you know, we have been talking about it for 6 months. We have not actioned it, but the idea is to do not exactly these kind of sessions, but standards awareness sessions at multiple colleges and academic, not just as IEEE, but going along with our partner in India, TSDSI, and of course, having the ministry presence is extremely important, because that talks about the seriousness. You know, it is just not about awareness, but the ministry is saying that we are here to support you, guide you through the process, right? I think that kind of mentorship that you mentioned, I think will be beneficial. Thank you.
Chair, I have one thing on this. So I think picking up exactly where you left, the TEC as the SSO, TSDSI as the SDO, and IEEE perhaps as a global window, and ITU as a global window into that. But run through what you just picked up. I think the crowdsourcing part comes in here. Can the government just clarify that the Ministry of Housing and Urban Affairs is running a smart cities project and does not know how to standardize camera feed and camera viewing and the security on top of that? I think this was started with TSDSI. It doesn't exist any longer. Please, the most important thing right now is to state challenges, to state population class challenges that the government will back up. The Secretary Saab talked about incentives. So give incentives to population class challenges published by the SSO, the SDO, and then get the ministries involved to say, I back this up, and you will see a change. Crowdsource solutions after that, including standards. So that might actually solve that issue as well.
Mr. Madan?
I would have to hand that over. Yes, sir.
Thank you for giving me a chance to comment. I have one last comment. One thing was not covered is mapping the existing standards to the requirements and work on the gaps. So that will focus our attention to the gaps in standards to our requirements, and not just repeat those standards once again or reinvent the wheel. That was my comment. Thank you.
Great. Don't reinvent it. That's the incrementally improve it.
Yes.
Yes, sir.
I'm Kishore Narang. I didn't want to actually question today, but I could resist after getting triggered from Bindu and then last from Sharad. So I think one thing, we are talking telecom standards. and we talk about products also. Am I right?
Absolutely.
And no, we are talking only TSDSI, we are talking TEC, we are not talking about BIS, we are not talking about IEC. You know, IEC standards are invisible everywhere in telecom, but nobody talks in telecom community in India about IEC standards. That's a topic for next discussion, maybe. But I think it's high time that and I was very surprised to see BIS conspicuous by its absence in this discussion. But BIS, yes, it is so to mirror the ISO IEC, not ITU, but that does not mean that in India we do not have a collaboration. We don't work in a harmonized manner, and that is one of the disconnect we today have. So on the face of it, we have a lot of coordination meetings and all that between BIS and DOT, but there is a real always tug of war. Why BIS is doing this standard around telecom? If TSDSI does not do it, BIS will have to do it. And talking about smart cities, I think we have had so I've been the founding chair of the Smart City Standards Committee for the digital infrastructure, and I made sure everybody from the telecom ecosystem, CDOT, TSDSI, and everyone was invited to the committee. And then again, after some time, we start hearing, no, this should be done by TEC, not by BIS. This should be done by TSDSI, not by BIS. I think as long as we have this kind of a siloed approach within our national standards organization, I don't think we are going anywhere. I'm sorry to be skeptical, though I'm deeply into standardization, and I'm happy to see the homogenized ecosystem for standardization, be it telecom, be it products, systems, services, anything.
Thank you, sir. I think that's one of the intent and one of the proposition that we made today was to be joined at the hip and remove overlaps between these organizations.
Sir,
and in my presentation in the morning, in fact, I had suggested that I put actually BIS logo as well there. So I take your point. I think, as you rightly said, it's probably the topic for the next workshop as well. Thank you for your comment. Yes, sir, please.
Sir, good evening. Myself, Sushil Kumar. I am DDG IoT in TEC. There is a sync at the international level as ISO, IEC, and ITU. They are having joint smart city task force, and they map the standards, and they created a world smart city forum in 2015, and from 2021 they are having the joint smart city task force. Mr. Narang Kishore and myself are also the member from India in that task force. There is a collaboration between TSDSI, BIS, and TEC at some of the points, but at some of the points there is always lag pulling type of things. I also chair in BIS in LITD 27 on IoT and digital twin, but there is no doubt there is a very, very poor participation from India, whether it is the national working group meeting, study group meetings in ITU or ISO, IEC meetings there at the international levels. It becomes to carry forward only the 10 persons or 15%, even 15 persons in virtual meetings. And if the meetings are in the night, we find only the chair attending the meeting. Then how to take a lot of people in the standardization? At least they should participate. If they participate 2, 3, 4 meetings only, they will learn what is happening there. Otherwise, we send the people to physical participation. They will walk here and there and will come back. First, the virtual participation of the people is very important, and once they start contributing, only then they should be permitted to travel. This is from my point, and there should be a good collaboration at the national level also when there is a collaboration at the international. Thank you, sir.
Thank you, sir.
Thank you, sir, for giving me opportunity. It was good learning, great day today. The question or thought that comes to my mind is, first of my name is KK Minocha. I'm superintendent from DOT. I'm sitting with my all working colleagues and retired colleagues. All along my career, I've seen right of way in telecommunications. There's hardly, till I have retired, there's hardly any standardization in terms of policy or in terms of standards for underground utilities, be it telecom, water, electricity, or coexistence of the utilities. One digs, damages others, and beat goes on. I was reading even till yesterday newspapers. It's a ROW standards or absence of ROW policy standards is a problem for NHAI. It is a problem for telecommunications, whether be it overhead cables or see that quality of the network we have with the cable TV overhead going on the poles. We are aspiring for a quality of service of the network, high latency and this and that. The cables get damaged in the underground, overhead, and then it is a challenge for power grid transmission also. They say we have excess capacity of generation everywhere. Energy is a big challenge. But where's the capacity in the transmission lines in the power grid? So they are reconducting the towers. Reconducting boloto, you are putting more conductors wherever the tower load can withstand. So why not? And real estate is a challenge, and it's a federal setup of the country. I don't know what, where the state governments view it, ROW, as a revenue generation aspect. But the infrastructural growth, be it telecom or other infrastructures, they are all correlated, cannot come without standardization in this area. That's my humble submission. I don't know, I have asked right question, wrong question.
Always the right, any question is the right question, sir.
Thank you, sir.
Thank you. Okay.
Sir, I'm Venkat Ramaraju Chelle, Director Quantum Technology, TEC. My observation, last 10 years, you look at the China, when they were very initial stage, they are not very prominent in a research and standards. Now today they are leaders, are leading in the standards and research. They're in telecommunications, CC, communication center of excellence they established. They have made drive through that institute. Many participants are coming from that and also from industry. Similarly, Japan also same fashion, and any developed country also most likely either the top companies or maybe in academia. Whereas in our country, the more academia concern is the journal papers rather than a standards participation other thing. This have found, it seems to be lacking here, where the education is need to be reformed, as Mr. Sharad Arora said, that should need a curriculum as well as drive from there, and also government, where the government ICT and telecom is a separate divisions. No country have a separate units, ministries. That is also one of the driving convergence force is required. Collaboration is really lacked in the implementation. That I think so. It is very much required. Thank you, sir.
Thank you. I think we need to wrap this up right now. So thank you all very much. And I think that your point on quantum, only thing I'll summarize is that telecom is becoming a horizontal to every other vertical. As we move forward, every other vertical, whether it is banking, financial services, insurance, healthcare, agriculture, anything that you want to do, they will first use telecom as a horizontal. So in that context, I think, what we are attempting to do here is to get our act right in telecom, get the standards process right, get as much of contributions right by identifying India's needs holistically, and get rightfully our place in this world of standards, specifically for 6G and if possible earlier, right? So let's all go and participate, observe, learn, contribute, and lead. Thank you so much.
Ladies and gentlemen, we thank our esteemed chair and panelists for concluding the workshop proceedings in such an interactive manner. May I request Shri N.G. Subramaniam, Chair TSTSI, to present a token of thanks and gratitude to Shri Sharad Arora from Mashmari EdTech. All other speakers have given their enriching talks in the previous sessions. We thank you, sir. I request the speakers of this panel to please come forward for the group photo. May I now request Shri R. Mittal, Advisor and Head TEC, for the closing remarks.
So, first of all, I'd like to thank the audience for being so patient. It was a long day, but very informative seminar. And I wanted to summarize, but I think the previous session, Dr. NGS summarized it already. We will come out with a takeaway kind of a small report, which we will circulate to all. I would also like to thank TSGSI, CDOT, and my own TEC team for very collaborative work in organizing such a comprehensive workshop to bring together so many people over a span of few days. Really calls for coordination, and I think this spirit of coordination we have to also take in terms of standards building also. And I would thank Aman for anchoring the whole event, and all others who were behind, whom I may not know. And so I'll call it a day. Thank you all.